We live, we live. What's up? What's up, chat? Let's see. I started a bit early. Wait, is it working? Let me test. Alright, perfect, perfect. Alright, we're live. Started a bit early because it's a 12-hour stream. The earlier we start this, the earlier it finishes. I mean, we're still gonna put in the 12 hours for sure. And we got a jam-packed schedule. I'm gonna be working a little bit on my website. I'm gonna be having a bunch of coding interviews, maybe system design, whatever people want to hear. Or there's a bunch of people waiting to hop on the call. I have calls with 1, 2, 3, 4, 5, 6, 7 people. One based in India, another based in Indiana, one based in San Diego, another person in Tustin, California, Iowa, Toronto again. Do I know this person? No, I don't know him. And Texas. So a bunch of US, some India, but yeah, that's the schedule. It's crazy. Tweaked. Let's see. Let people roll in. Yo, chat, if you're in, say what's up. I think my first meeting is at 11 to 12 with someone from India. And then, yo, what's up? What's up? First person is from 11 to 12. So for the next, damn, we have 3 hours. We're going to work on my website. We got to do a bunch of coding on the website. So we just need to do a bit of studying on some authentication. Just make sure authentication is working perfect. No one can hack me. Everything's good on my website. And then we're going to do like protected routes and some new features on the website. So we're going to focus on that. Feel free to ask questions as I go. But yeah, it's kind of the plan. Try to like keep it chill for the first few hours. I know it's the morning for everyone, so I'll just be like literally just chilling. Like I won't even talk that much. It's just morning for me too. What's the project? So I'm working on my. Well, I have my website that I built out. I have a video on. I'll send you the video. So we have my video here. Hello everyone and welcome back. Get the ad.
My work is easy.
So I built this with Next.js, Tailwind CSS, Vercel and Cursor. So I talk about the tech stack and my decisions for why I decided to use Next.js server-side rendering, why I did Tailwind CSS, Vercel, and Cursor. And today's actually Juneteenth, which is a national holiday in the US. So yeah, that's why I'm able to work on this today. But yeah, I'm learning this stuff is useful stuff. I'm gonna be working on some authentication, but I built my website. If you want to go and see how I built my website, all the tech decisions, I made a video on this. I made a tech stack vid. Just talking about how I built my personal website. So what I want to do now is I want to add more protected routes, because the protected routes, I want to like be able to do certain things. Like for example, I have an analytics route that's kind of hidden, but it's supposed to be a protected route, but it's not. We can see kind of all my analytics, and I want to have more things that are protected, because I want to do everything related to my YouTube channel here, like build my thumbnails, all that stuff, through this one through my website. So that's like my North Star vision. So I need proper authentication so that the people on my website using my website can only do what I authorize them to do. So yeah, I mean, authentication is already set up. More authorization. So yeah, I'm gonna. But then, look, do we have a jam-packed schedule of just coding interviews, 7 coding interviews, and in between that, I'll be coding. So yeah, there's gonna be a lot. No, I never heard the song. Is it copyrighted? Manas? Manas, what's up, man? Long time no see. Wait, let me grab my water. Damn, I'm muted. My bad. Don't be scared of tech. 100% don't be scared of tech. I agree. I feel like instead of being scared of tech, we should, especially being in tech, you're the most positioned to learn about the tech. So when you see AI is kind of scaring you, out of everyone, you shouldn't be scared as a software engineer because you should be able to understand it and make sure that you could leverage it. What's everyone's thoughts on AI? Are we cooked? Why do you, okay? Why do everyone say we're not cooked with AI? Garth, why are we saying you're not cooked with AI? Why is AI not gonna cook us? I don't think we're cooked with AI, but yet. Manas, we're cooked. Mr. B, we're good. So we have one person say we're two people say we're not cooked, one say we're cooked, and one is in the middle. The junior level jobs are affected. I don't like AI to be honest because right now I am learning Python. I'm currently beginner and sometimes I feel led to use its solutions when trying to solve problems. What do you mean by that? Yeah, because you're a beginner and all of a sudden you just want to just use the AI whenever you get stuck. Is that what you're saying or no? AI can't build logic on complex problems. How complex is the problem? If you tell it to do one specific task, generate me the most optimal code for generating prime numbers from 1 to n, it'll generate that. It could solve any leak code problem like right out the box. So what do you mean by complex problems? But coding, yeah, we got coding interviews today, but it can't solve Codeforce's problem. Are you sure? I heard it's somebody who does a lot of Codeforce was telling me that the bots on Codeforces are just straight up ruining the platform at this point. It can't solve some of the hard DP question. Yeah. Okay, Troll, I agree. For me, honestly, I don't turn on the agent mode. I just like to chat with it and chat against my code base and understand, like help use it to help me understand what I'm doing. I don't really like it just generating all my code because from my experience so far, yeah, it messes things up and I have to go back and fix it. But sometimes it does get it right. And actually, it gets it right a good amount of times these days. And yeah, Mr. B, what do you mean by complicated task though? Can you define complicated task? Because it's able to solve 2,000 to 2,300 rated problems. That's a pretty high problem, Manas. But is it the AI struggling or is it you struggling to use the AI? That's the part. Like, if you knew how to use the AI properly, do you think that it would be messing up? Is it just people are not that good at prompt engineering or prompting it or managing the AI to do what it needs to do? Like for example, if you give them the most general prompt, make me this button, it's gonna make you some button. It's gonna work, but like is it what you want versus giving very specific prompts and guiding the AI to do what you want? I think there's a lot of room. The thing is, if AI replaces you completely, worst case scenario, people will have no money, and without money, all the business will go down. I don't think AI is gonna replace. I don't think AI will replace human, or we would want AI to replace humans, but we will want AI to make humans more productive and make humans' jobs more enjoyable. Yo, thank you, thanks from Vietnam, thank you. Because like what do we use AI for right now as software engineers? Are we using it to replace our job or are we using it to replace things that we get annoyed doing? Or do we are we using it to help us move faster? This changes everything. Try reading the I guess AI can't solve things. People say that, right? That AI can't solve things it hasn't seen before because it's trained on like historical data. So it's pretty much just like what it's outputting is based on probabilities that it was trained like word combinations that it was trained on in the past. But the thing that kind of beats the interesting part is the agent mode, right? Do you really think you can make it with AI without any logic or syntax knowledge? The answer for today is no. Yeah, you're right. If you have, get Google this, you'll send it in a Discord. What is this? MIT study on ChatGPT. Is it this? Manas, is it this? Okay, let's read this. Let's read this and see if we're actually cooked based on MIT. I like this. Shout out to MIT. Whoa, 200, 209 pages? Okay, what's the... Dude, this is long. So people think it's, or they're saying it's eroding technic or thinking skills. We are getting dumber. Yes, that's a word. Damn, it's okay. Let's read the. Damn, that's crazy. Okay, let's have. This is yeah. This paper is way too long, but I think it's interesting to just read the abstract. It's interesting to just read the abstract and then read a little bit of introduction and then just let everyone and then talk about it quickly as a group. Remove myself. So your brain on ChatGPT. Accumulation of cognitive debt when using an AI assistant for essay writing tasks. This study explores the neural and behavioral consequences of LLM assisted essay writing. Participants were divided into three groups: LLM, search engine, and brain only, no tools. Each completed 3 sessions under the same condition. In a fourth session, LLM users were reassigned to brain only group, LLM to brain, and brain only users were reassigned to LLM condition, brain to LLM. A total of 54 participants took in part sessions 1 to 3 with 18 completing sessions. I think this is a very interesting study. Like, you have different control groups or groups of people and you make them do a task. One with LLM, one with a search engine, and one using their brain only. And then let's see how they are. This is actually some cool stuff. Imagine actually having to run these studies. Honestly, I would have a lot of fun running these studies. They're probably going to do a ton of these studies in the future. Let's see. If you're vibe coding using AI tools to build your web code, does grinding LeetCode still make sense? Is LeetCode still the best use of your time? LeetCode was never really the best use of your time, but it does help you. It does, honestly, it helped me personally become better engineer, just because it made me forced me to work on harder problems. It's like you're working out at the gym and you're lifting 225 pounds like to get it. It just pushes your brain in different ways, and honestly, it helped me as a software engineer because now I'm not scared to take on complex problems or look at equations and things like that. So it helps you in that case, and it does help you land a really good job that will like help you financially. So a lot of these companies are asking LeetCode. If you want to get a job at this company and make good money, you have to learn how to LeetCode. Once you get the job, you can vibe code, use AI tools all you want, but you don't really get that to do that unless you're like cheating. Let's see. One sec, just grabbing something. Okay, we used an EEG to assess cognitive load during essay writing and analyze essays using NLP, as well as scoring essays with the help from human teachers and an AI judge. Across groups, NERs, N-gram patterns, and topic ontology showed within group homogeneity. Yo, the words are crazy. EEG revealed significant differences in brain connectivity. Brain-only participants exhibited the strongest, most distributed networks. Search engine users showed moderate engagement, and LLM users displayed the weakest connectivity. So the LLM users are using their brain the least when doing this development. Cognitive activity scaled down in relation to external use. In session 4, LLM to brain participants showed reduced alpha and beta connectivity. indicating under engagement. Brain to LLM users exhibit higher memory call and activation of random brain stuff, similar to search engine users. Self-reported ownership of essays was the lowest. Self-reported ownership of essays was the lowest in LLM group and was the highest in the brain-only group. LLM users also struggled to accurately quote their own work. While LLMs offer immediate convenience, our findings highlight potential cognitive cost. Over 4 months, LLM users consistently underperformed at neural, linguistic, and behavioral levels. These results raise concerns about the long-term educational implications of LLM reliance and underscore the need for deeper inquiry into AI roles in learning. Wow. That, sorry, messed up. That's a pretty profound study. Correct me if I'm wrong, but isn't saying like if you don't do cognitive tasks, your brain acts less. Yeah, I guess they're saying if you're not, basically what they're saying is that you're not using your brain when you use the LLM, and some people would say that they're using their brain. Yeah, I'm using my brain to put together all of the results that GPT is sending me and formatting it. Like I'm still using my brain. I'm just using my brain in a different way. This is saying you're literally just not using your brain, and they're tracking that with an EEG. That's what I got out of it. I'm not in this field, but that's what I'm. I know what an EEG is. It trying to tracks the electrical signals and stuff. Yo, what's up? Depends not only if you use an LLM, but how you use it. Big difference between pasting error into chat and asking what it means versus dropping in cursor and telling Claude to fix it. I agree. I like to do the other one, especially if I'm just beginning to learn how to code. I wouldn't just spam the AI. Even in school, a lot of the times they didn't even. In my first couple of years, they didn't even let us use the IDE. They're making us just write code, and even in their tests, you're writing code exactly by hand. Yeah, I try to learn from GPT as well. Orca, what's up? So everyone, go check out this paper by MIT. They doing brain studies on AI assistants. This is really cool. This project that they're working on. And not yet. Let's see. Skip to the discussions. Bro, this is so technical. This is so technical. Yeah, I wasn't allowed to use the IDE in my first year too. Okay, usually let's skip right to the conclusion. Okay, so what's everyone's thoughts with the first introduction of how GPT, essentially how using GPT you use your brain way less, and that offers like basically if you keep using that and you're not using your brain, these people are underperforming in neuro linguistic and behavioral levels. Yo, what's up? What do you all think? You can relate to that? Yeah, but honestly, one thing in a world where they just care about productivity, I don't know if they would want. I think some of the people who are running these companies would rather. Honestly no. I would want the smartest people working for me, and I would want them to be smart. But then what I think people also might just care about output, especially if you're just a startup and you're trying to just get things done. All right, conclusion. As we stand at this technological crossroads, it becomes crucial to understand the full spectrum of cognitive consequences associated with LLM integration in educational and informational contexts. While these tools offer unprecedented opportunities for enhancing learning and information access, their potential impact on cognitive development, critical thinking, and intellectual independence demands a very careful consideration and continued research. This is good. They should just keep doing more research like this to just make sure LLMs is good for humanity. Because the people coding these LLMs, they're not thinking about this honestly. They might be, but they're everyone like there's a everyone has their own mission that they're on. Some people are just trying to advance the LLM and they're so deep into advancing the LLM, and then other people, it's like a separation of concerns. Other people are more concerned about how this will affect like people's thinking, while other people are still just mainly focused on developing this technology because they want artificial general intelligence and they're pretty cited on that. What's everyone's in the chats, like what is your goal with AI? Do you want AI to stop, people to just stop making AIs, or do you want them to just keep pushing in the way that they've been pushing in the last few years? Just stop right now. Leave it as is. Stop. Everyone's saying stop. I could see why as an individual we would want to stop. Everyone said stop it. The whole chat saying stop it. Anyone here say don't stop it? Anyone here just said just do it? Just go crazy? And these are all software engineers in the chat, right? Everyone here does it. I think we can push it for Garf saying we can push it further. One person saying push it further. It's like it's gotten to a point where it can help, and I think that's enough. Everyone, okay, most of the chat says to stop it. It can help enough. Limit it. I would say not just keep doing anything. Yeah. But okay, I'll play the devil's advocate here because like pretend you're a company and your competitor, pretend we have Google and Microsoft. Both are using both are pretend they're competing in terms of like building out their what was it called, like their workplace stuff. What is it called? What is Microsoft's offering for all like the work stuff related stuff? Work Microsoft, like Outlook and stuff. Let's see, what's this called? Okay. Let me say this again. Like, pretend we have two companies and they're both developing, like an app. They're building the Microsoft. They're competing on Microsoft 365 products. Google has, Google Docs, Google Gmail, all these different products, and Microsoft has the same different products. These companies are not just using AI to write them code. They're using this. They're building AI so that they can integrate AI across all the workflows and build better products and build them faster. That's what they're using the AI for. They're probably just allowing you to use these AIs. Yeah, for a regular, they're showing these AIs. Everyone's just using the AI for their use case, like building essays and stuff. But like low key, what they're doing is training the AI, and then these companies are a lot of them are using the AI and deploying it across their different parts of the company to drive efficiencies. So they'll be deploying it to their engineers so that their engineers could write code faster. They'll be deploying it to their data centers so their data centers are more optimized. They'll be deploying it to like their tech people, their help desk, so that they can resolve bugs faster. They're deploying it across all the different places. So I pretend I have one company that has developed such a good AI that it could help in so much different business aspects like planning, finance, um, data centers, product management. That AI is so good; it's helping people be 10 times better. And we have another company who laid off on the AI because they didn't want the AI to get too crazy, and now they've fallen behind. And now the company who pushed AI and deployed it across everywhere in their system is now has a super strong, like has a strong AI, has a wide adoption and people using it in their company and are able to move a lot faster. Who's gonna win in a competitive market if they're competing for the same user and this user really only cares about price and also how good the like the features and stuff. Like who's gonna win in that situation? I don't know if I explained that well. I think AI used by regular people doesn't need to be pushed further, but AI in specialized field could be pushed further. What's everyone thinking? Yeah, I think the main reason why they companies aren't gonna stop and probably won't stop is because it's a competition and other companies won't stop, and also other countries won't stop either. So pretend you have one country. Let's take it to the other situation where we have two countries. One country has AI and is deployed it across their whole population to improve their productivity 10x. Now that country can produce better products, um, and can drive efficiencies in their economy using the AI. Like we've already seen that at the smaller scale of just us as just humans driving like more product like faster. We're building essays faster. We're making it more efficient because we're using our brain less, I guess. Different things like that. So you have a whole population using AI to superpower as a superpower, or to like power their economy versus one that doesn't. And then project that out over 20 years, what would be the outcome of one country versus the other, right? That's why we can't just be like stop working on AI. Like I get it's scary, but I'm just playing devil's advocate, and that's probably the one of the biggest drivers in why we just don't stop working on AI. Unless we all come to a conclusion in this world that everyone's gonna stop working on AI. Right now, there's a arms race in AI. That's the way I see it. And all of the people that you said, all of the all right, have a good dinner. All of the stuff people are saying, all the stuff that people are saying is like the AI makes mistakes, the AI does this. That that's the AI now. But slowly it's getting better though, from what I see. It's slowly getting better. Even from a year ago, that thing was trash. A year ago, it wasn't even close to as good. Now we have other things like Cursor that fully integrates the context. The context windows are getting better. There's agent mode that it thinks a little bit better. Like the progress is growing exponentially. So if your only thing is that you have to just that it's making the wrong thing, I think in the future, like I don't see a world in the future where it's gonna be making those little mistakes for much longer. And the systems are going to be more and more sophisticated to introduce the context into the larger and larger code bases to offer better results. So I think what was it? It's only it AI is very new. We just had these models and it was just like a next token predictor, but now they're improving it a lot. Thoughts? Any tips on becoming a software engineer? um, just learn like learn to code properly. Don't just spam AI. Learn the fundamentals. Start with the basics. Work your way up. Work on projects. Those are some of my tips for becoming a software engineer. I could do a whole thing on that, but right now we're really focused on AI and its implications. So I can answer that right after this. I just want to finish. I'll pin that because that's the message, or that's what I'll cover next. Yeah. Anybody have any thoughts on AI? What does a guy know who knows basic DSA Python do to become an AI ML pro, like a roadmap for them? I barely watched the 2001 Space Odyssey. That's a classic though, right? Honestly, AI and ML stuff is a different skill set. AI and ML is more. It depends if you're gonna be like AI ML engineer or applied AI or actual AI. But for actually learning machine learning, you need to understand a bit about statistics. Like the stuff that they work on, you need a statistical mind. And ours, when you're just straight coding, what do y'all think about AI having a consciousness? I don't think it has a consciousness, but it all depends on your definition. Yo, Ark, what's up? Yeah, cool. Okay, that's pretty crazy. Your brain on GPT. Now we know that your brain is using less of itself, or it's not as active, and that could have some profound effects. So they need to keep studying this, and we need to just make sure that us as humans are actually using our brain. You, our brains as humans is what got us here as a species. So you need to make sure that your brain is working and your brain is improving, expanding, like everything. You just need to keep your brain healthy. That's what I'll say. And that means studying. That means actually using your brain, actually using critical thinking, and never stop learning. Especially when you're done school. I know a lot of people finish school or are still in school. Once you finish school, make sure you still keep on learning, because I've already been out of school for 5, 6, 7 years, even a decade out of high school, and you could see you'll start to see the difference if someone decides to keep learning and not. Even with people who graduated university, when you first graduate university, you'll see everyone's kind of on the same level. Then there's people who just keeps on learning and learning and learning, and even 4 or 5 years, you could see the separation. Maybe 10 years after, you'll see even more separation. I'm only 4 years graduated college, but I would just suggest keep on learning. Let's see. I'm going to be a junior in college for electrical engineering, and I'll say ChatGPT made me lazier, and I've cut corners with no school. AI is going to start. Okay, any tips for becoming a software engineer? Okay, I'll answer this question. Any tips for becoming a software engineer? And I'll let the chat chime in on this as well. But let me gather my thoughts real quickly. What would be my advice for software engineering? Maybe I'll talk a little bit about how I became a software engineer in my journey, and how I became a software engineer, and then I started in around 2015, so it's been 10 years, so things has definitely changed, but I think so a lot of things have still stayed the same, and I have friends who are just getting into the industry now, and I kind of gave them the same advice, and they're able to break in the door. So I think although things have changed, I think the main thing that has changed is just the programming language and the technologies you're using, and obviously with AI, the way that you perform software engineering has changed drastically because it's like it's like autocomplete on steroids. So in 2015, I would say when you code, don't just code to build for optimizations. Always try to optimize. Yeah, any tips for becoming a Swede? Just grind your butt off and don't look back. I agree. I agree. But yeah, let me talk a little bit about how I became a software engineer, and we can go back to that. So when I was in school, or when I was coming out of university or out of high school, I didn't even really try in school until I was about to graduate. But I wanted to get into the medical field, so I was in a science degree, like a general science degree, and taking classes, chemistry classes, physics classes. I didn't know exactly what I wanted to be, but at the time where I was, the biggest industry was oil and gas, and then the other ones that people recommend to me were in the medical field. So I was just getting input from people who were older than me, and then counselors and different things like that telling me what I should do. And one of the main things, of course, was which job will I make a good living. And for me, a good living at the time was if I can make 100K and just make 100K until I retire, that would be a good living for me. And that is definitely a good living. But um, yeah, I decided to take a computer science course because my dad he did a little bit of IT. He actually does IT. He doesn't do coding or anything. He does more of like IT. Um, but he actually used to code before. But basically, what he said is that, or he just suggested me take a computer science class. And also, my mom, parents, they'll always be you'll help them with a phone thing, and then they'll be like, "Oh, you're so good with your phone," kind of. But my mom really wanted me to be a nurse because she's a nurse. But then I don't know if it was my dad or I just decided to take like a computer science course because I was like slightly interested in computers. I knew I was good at computers. Not good at computers. I knew how to work a computer, as in I could debug some simple stuff. I can download software if I'm playing a game. I could run a bot. You know what I mean? Like I can use software. I didn't know anything about coding, but I knew I thought that I knew how to use computers at the not at the time. Not everyone really used computers. I mean people use computers, but not everyone's downloading software, running bots and on their games and stuff. Um, but yeah, I think now everyone knows how to use computers a lot. So back in it, I thought that when I took my first computer science class, they're gonna teach me how a computer works, because that's what I thought computer science was. You learn about the computer, you learn what a motherboard is, what a CPU is, all the different aspects of a computer. I thought that's what we're gonna learn, right? I and then at my first class, they just started showing me Python, which is a programming language. And I was like, what? I didn't know how computers worked at all, and I didn't even know anything about programming languages or programming. But they started showing me Python. So I remember they showed a textbook of Python, and they just started showing very simple things like variables and all of these different, like they're basically showing you how to code. I was like, what the heck? I've never seen this before, but I just remembered something went off in my head. I was like, this thing is really powerful. Like coding, like programming, you can build some crazy things with this because there's no limit to what you can make with it. Like you can simulate. I remember they're showing us like a dog calculator, which is very simple, but you could simulate anything in that digital world using the code. That's initially what I thought. So I said, I think this is interesting. I think this actually has. I really want to start a business. So I didn't really want to take business just to start a business. That was my main motto. So why would I take business to just start a business? Because I would go on YouTube and people would just say, why would you take a business degree to start a business? Like, they're not going to teach you any. Like, the main way to start a business is really do a business, and I agree with that as well. Even with coding, the main way to learn how to code is just straight code. But school still teaches you a lot of stuff about coding. I enjoyed my time at school, and I would never like take that back. But yeah, they're just showing us Python. I thought that Python was powerful just because I want to start a business, and I just saw that you can pretty much make anything that your mind comes up with code. Obviously, it's in the digital world, and not everything in the digital world is useful in the physical world, but you can make pretty much do anything you want inside of the computer, and you just need to know how to write the code. But the sky's like there's literally nothing you can't do. You could make a human fly in the computer. Obviously, that doesn't translate to real world, but you can do anything you want in the computer. So that was the main reason that I thought this would be the best degree to take if in the future I want to start a business. That's exactly why I decided to take it. So I think one thing to becoming a good software engineer is actually understanding why you got into it for the first place. Because I wouldn't have got here where I am today if I didn't care that much about software engineering, or I didn't have a strong mission to taking software engineering. It can take you far. It can take you to get a good job and everything. But is it gonna make you the most happy? Is it gonna um, probably it's gonna provide you enough money to be happy and different things like that, and everyone has their own needs. But if you want to take it to the furthest ends, I don't think you could be not passionate about software engineering to be one of the best or be a really great software engineer. But if your goal is to literally just become a software engineer, you like the money, you care about the money, then that's a different topic. But I think even in that case, like the industry is changing so fast, the level of expertise you need to be an employable software engineer has increased to the point that, yeah, like if you just want it's no longer the days where you could just become a software engineer by um, doing some random boot camp and um, just get in. So I would say, yeah, where I was getting to, I kind of ramble, but any tips for becoming a software engineer is essentially just have a mission, understand why you got into software engineering in the first place. That will help drive you in times where it's rough. And there's been rough times in software engineering. All of my friends in software engineering had times when they wanted to quit. I had times that I wanted to quit. I had times where I didn't understand where anything. Yeah, Pablo. I had times when I didn't understand anything or didn't understand much, or I had times where like I wanted to quit. But the good thing about software engineering, which I will say is a big benefit, is there is a light. It's more of a it's a simpler path than most professions, I would say. There's like a light at the end of the tunnel. You go to school and you get hired as a software engineer. You take something like biology, you don't know if you're gonna become a doctor, pharmacist. The road is less clear unless you really. I feel like with software engineer, there's a light at the end of the tunnel because at the end of the tunnel, you know that it's a good paying job. That's why I see a lot of people are able to do it, and even if they don't like it. But yeah, so to become software engineer, know exactly what you want to do or why you got into it. That's the first place, and then start from the basics. Don't use AI to just start generating code. Start from the basics, and I would say learn very basic variables, um, branching statements, while loops, for loops, functions. like object oriented. Start with the basics, and even when you first started, even when you first start building very simple projects. So, for example, like when like build a dog years calculator once you learn simple variables, and just start taking on smaller or bigger and bigger projects with the knowledge that you learn. Try to avoid just watching a bunch of tutorials and then take a huge project. Like maybe just start with very basic simple projects and then expand from there. That's kind of how they did it in school, where they taught you basics of like variables, functions, control flow, all of that stuff, and then they test your knowledge by making you write assignments that you have to build like some function that takes one input and has some output, and in order to generate the correct output you need to have understand the concepts that they taught you in class, like variables, if statements, branching, for loops, etc., control flow essentially. So yeah, I would say focus on actually working on projects or small little things, and focus and learn the foundation. I even to this day I go back and try to understand the fundamentals of things. When I'm learning a new programming language, I start all the way from scratch of how are variables defined, what are the different data types. I go all the way to the fundamentals and then try to build that foundation before I start taking on bigger and bigger projects. I mean, at the same time, I am trying to do project at the same time, but the fundamentals is literally your fundamentals. They're the building blocks to building more complex things. Like for example, if you're doing math equations and you don't know how to add, you don't know simple algebra, you don't know literally how to work with variables, you don't know derivatives, integrals, how are you gonna solve any complicated math problem? You can't. And even if you spend all your time working on very complicated math problems, sometimes you'll even realize that you forgot about some very simple fundamental and you need to relearn it. That happens a lot of times. And then you just go back and try to understand, okay, if I have two exponents, how do these, if I have two um, numbers with exponents, how do these exponents add up if I multiply them, if I divide them, etc. You just need to make sure you understand that so that you don't mess up these super big calculations. So I think fundamentals are the most important thing, and I always go back to understand the fundamentals. So that's my advice on tips to becoming a software engineer. I think the other thing is we're in a new age of AI, so it's easy to use the AI to make it do your whole homework, to make it do everything for you. But use the AI as a teacher, as a teaching assistant. Don't use it as just something to generate your homework for you. I, do you think it's necessary to learn front end to get into the back end development for internships? Do I think it's necessary for to learn front end? I think it's like for me, I think understanding the full stack is very very beneficial because it helps you to understand, like it gives you a good breadth of knowledge. If I understand the front end, then I understand how the if I understand how the front end works, I understand the back end, then I understand how the front end talks to the back end, then I understand the database and how the back end talks to the database, and then understand that whole flow. I think that'll make you a better software engineer than pretend I just understand the database or I just understand the back end. Like you don't understand the full interaction. You don't have the whole picture. I think it's important to have the whole picture and then focus on that one part, but understand the whole picture. Because at the end of the day, you want to most of the time you're writing code that solves problems. And these problems don't just involve, you could be writing code to solve one problem, but at the end of the day, that one problem, for example, if I have a company initiative, there could be multiple people in different parts working on the big problem, which is could be like one specific metric we're trying to drive or one specific problem we want to reach. So it's always good to just keep that into account and understand that yes, I'm working on this small database index or this small optimization on the front end or this coloring, but understand the reason why you're doing it is important. It's the same as a musician. Even if you've been studying for 30 plus years, it's good to still start your day with 1 hour of scales. Exactly. You can see even people with when they start singing, they're just practicing hitting certain notes, right? They're making sure they can hit certain notes right. And all of a sudden, when they're singing their song, that just comes to them. But you always need to go back to your fundamentals so that when you're in deep writing code, deep writing a feature, deep in like the thick of pushing out some crazy feature, it's autopilot. But you always need to go back and understand your code and understand the fundamentals. Like I noticed that even with math, I've been doing math for so long, and sometimes I'll still look up the how exponentials work with each other, just to make sure that it's I have the right calculations and I have the right understanding in my mind. Are you studying like the foundations? Is TCP UDP like more of a historical approach to tech? Honestly, no. I just study back to the basics. So, for example, I've already done a lot of authentication. I implemented authentication in other companies and in my project right now. But I still need to go back and just understand how authentication working. Because honestly, it's changed a little bit too. Like they introduced a new like encrypted version of it, like the JWE instead of JWT. I didn't even know that before. I didn't see that before, but sometimes I go back and understand and make sure I understand. It all depends. You only have so much time in a day. I think it's in your discretion to figure out how deep you need to go, and it's also a balance. You don't want to just go keep diving deep into something so useless that has no impact. That's why it's important to understand the reason why you're doing things as well. Otherwise, you'll just go deep in a rabbit hole that leads to nothing. But also, that's fine if you go in a rabbit hole that leads to nothing, because maybe you go into that rabbit hole and you learn something and you use it later. I think also another thing is people are too concerned about. I'm reading. Oh, sorry. Your Brain on GPT by MIT. I think getting into OS foundations, networks, and even hardware compiler stuff is good. Yeah, it's good. It's good to understand that. I've never really had to go deep into that because my job has mostly been on the application layers. So I would say go deep, but understand. But it's also a balance. I think what makes people good engineers is not is almost exactly what they decide to work on. So where they focus on, it's not it's definitely like you put in, yo Mustafa, what's up? It's definitely you put in some it's not really about how hard you work that will make you a better software engineer. That'll help you become a good software engineer, right? But also figuring out what is the right thing to work on, because you could have like one engineer working on some very niche problem, and then one engineer who like is working on a very impactful problem, maybe like this AI stuff, this GPT LLM stuff, working on expand. Yo, Paul, what's up? Working on kind of expanding that. Like it basically what I'm saying is it. You can get into OS, you can get into foundations, networks, compilers, or you can get into like database indexing, B trees, C++. You can get into like design, LLM architecture, agent. Like there's so much areas you can get into. So you can't do everything. So your goal is to figure out what is the best thing for me to learn and what is the best thing that I need to learn right now among all this stuff that I could be looking into. And understanding also the concept of opportunity cost. For example, I could spend an hour right now working on leak code or 1 hour reading on system design, and the opportunity cost is that, I mean, you're taking your effort learning system design. Like, what are you gonna get out of that versus just learning leak code? What are you gonna get out of that? Pretend I don't even have any interviews. I might get incrementally smarter from doing that leak code, but then I could have learned something about system design that will help me get a raise. So what's the opportunity cost? It could be, you could even calculate down to like the thousands of dollars of getting that raise. I mean, it's a complicated thing, but I'm basically saying there's just trade offs with what you need to learn. So I could spend the next year diving deep into OS foundations, networks, hardwares, compilers, and stuff like that, or I could spend the next year digging into AI architecture and the different things about AI that will help me become a better AI engineer. Like, what should I work on? The opportunity cost could be monumental depending on like where the industry decides to go. So that's why there's a bit of luck involved as well, and it's something that you keep in mind. And that it's like the one thing you could do is like, oh, I'm just gonna learn everything. Is coding still worth it in college? Which field do you suggest to go into comp sci? I think coding is still worth it. I think yeah, I think yeah, the foundation CS will be really consistent, but Joker, like, coding is still worth it in college. What field do you suggest going into in comp sci? I would suggest just taking regular comp sci and also doing some statistics courses, taking some machine learning courses, understanding all of like the machine learning algorithms and not just AI neural networks, but also understanding like the older techniques as well, like linear regressions and things like that. And then building up to the neural networks, because a lot of problems you can still solve with simple linear regression. And those like traditional AI or machine learning techniques, or just those traditional statistical techniques, are still very important. But I think coding is still worth it in college. People say don't take coding, don't take comp sci. But who's gonna manage all of these AIs? Who's gonna be the most well positioned to work on AI? Who's gonna be able to like harvest as much value from AI as possible? Who's gonna be able to fix the AI when it hallucinates? I think the people who are well positioned are the people who are the most technical. And AI at the end of the day is just like one portion of it, but there's so much code written around the AI that involves regular software engineering skills. How do you build the data set that the AI is being trained on? How do you clean the data set that the AI is being trained on? A lot of that is traditional code. How do you build the system that allows people to label these data sets at scale, right? How do you write the code to evaluate the model at scale and compile those results? That's just regular code. How do you serve the model, right? How do you load balance the model between different servers? Yo, Pete, I'm working on my website, but I just getting into some random rants. I'm building a bunch of stuff. I'm just getting into a lot of different rants because it's a Thursday. I've been ranting for like an hour, about random stuff. I think that one we were pretty much just talking about how should I get started into software, and I completely start talking about random stuff. But this is why I love the chat. feature engineering isn't really a thing with modern AI. Why is it not a thing with modern AI, Paul? Most neural networks models take raw data. You still have to tokenize the data. You need to also like normalize the data, make sure that like perform scalar so it's the values aren't super high. Feature engineering is also figuring out what features. Don't you have to figure out what is inputted into the model? Like you have a neural network, you can pass in a ton of different data, but what's the data that's best for it? Like what features should we pass into a neural network? Well, you tokenize the data and you can figure out how you want to scale the data, right? You can put like a 0 to 1 scalar, all the different type of scaled data. A lot of these models normalize the data before they input it to the model, doesn't it? Even with training the data, isn't that a sort of like that's still a human decision of what training data to introduce. Also, feature engineering is like, okay, pretend we're doing RAG, right? How big of like what's the chunking size, right? Even with the LLM, there's so much different. I mean, there's different parameters and stuff, but I think there's still feature engineering, especially with neural nets. I don't know about LLMs, but neural nets. So, how do you figure out what you're gonna input into the model? Okay. Yeah, like people, like for example, there's so much work at making sure the data is clean and the data is not is like good for the LLM. It takes raw data, but they're figuring out like what are the good sources, and then they're making sure that there's a good distribution of the different like topics. Like there's a lot of effort into making the right data set to train the AI, I'm pretty sure. I mean, you could just train it on the whole internet, but I'm pretty sure that they purposely don't just train it on internet, otherwise it'll be hallucinating on some random stuff. Like why not put in the extra effort to make sure the LLM is only learning from the best sources that are on the internet? What's your take on research like a PhD route we're going into? My take is, and I'm not obviously all I have is a bachelor's degree. I do really love and enjoy school, and I want to continue doing school, but I honestly learned a lot from joining the industry. And I think you'll see that I've worked with a lot of people who have PhDs and masters. When you join a fan company, in your join in my boot camp class, there's people who literally done PhDs, right? Who did a PhD. So I would say I think the one thing with research and PhD is you don't focus on the business problem, or not even the business problem, is you you don't really work on, like you don't see how it fits into the economy. So you could be working on some specific, when you're working in the industry, pretty much all the work you're doing, you're very tuned into the business problem and how it's gonna work economically. You're all the work that you're taking, especially you work at a startup, right? You work at a startup. Most of my experience has been working at a startup. You're working on problems that have very strong business use case, and that just, and for something to have a strong business use case, you have to understand like its implications on the world a little bit different. You need to understand how it's gonna affect people and if people actually would use this. Because if people won't use it, you just burn money. So when you're working at a startup, a lot of times you're really doing so much market research and so much research with customers to understand like what problem you're solving. So my take on research is I would say when you work in the industry, are really tied into what the problem you're solving is, and I think that's very important because you don't want to just build stuff that doesn't solve problems for people because that a lot of times won't become useful. Most of the things that most of the biggest inventions solve actual problems, and that's why it was adopted. There are some stuff for fun. I mean, but even AI, for example, solves actual problems, and that's why it's being adopted. Does that make sense? So that's kind of my take on research. I would say if you're gonna I'm gonna do a master's at some point. I really want to take a master's at some point, but I'm really happy that I joined in the industry and I learned a lot. And I know people who just went straight into their masters, and they said that it would have been nice to join the industry because you learn a lot of different things when you join the industry that you would not learn by just going the regular academic route. Like a lot of the third party tools. Any plans on joining HFTs? What's that? What's a HFT? Reading AI paper. Reading AI paper. Yo, thank you. Reading. Yeah, I think okay. My thing. I want to have a PhD. I want to get a PhD job without. Yeah. So my thing about my goal in software was always to like start a software company. That's why I got into software. Like I said earlier, I wanted to start a software company. I want to build software. I want to build like software companies, and I feel like the quant firms and working those HFT jobs, they don't position you well to be an entrepreneur. So if all you're doing is working on quant firms and building very specific algorithms, I think somebody working at a startup, a Series A startup, is gonna position themselves better at starting a company, and gonna learn more things that are useful for starting a company than somebody working at a quant firm. So if your goal is to become an entrepreneur, I would say that a person working at an early stage startup is probably gaining better experience than you. And in this competitive world, when you have to compete with them, they might beat you. They're learning all the things like figuring out how to do marketing, figuring out how to do user research, figuring out how to find problems that people need to solve, working with them, and then building those problems, recruiting, all that stuff. Those are all stuff that That's all stuff that you working at an early stage company see at a day to day basis. You constantly have to jump on the call with customers. You constantly have to build infrastructure from scratch and scale it. You constantly have to recruit people and are in the loop. There's I've never worked at a hedge fund, so but I know people who have, and they said that as a software engineer, as a quant, maybe they were software engineers. So as software engineer, you're kind of just like writing algorithms that get thrown to you, and then the hours are bad. Like people last at Citadel for 2 years max. You can just go on LinkedIn and look up garden break or something like that, or you'll see so much people on their garden leave because they signed a non compete with Citadel and they left after 2 years because they couldn't handle it, and it's nice because you just sit there and get paid, but it's all about what your end goal is. You need to think about where you want to be 10 to 20 years down the line, and all the actions that you perform right now need to line up with that. Obviously things are going to change, but like have a long-term vision in mind. And the money in quant is good, but working at a FANG company and becoming a senior staff, you make a ton of money doing that for better hours than at a quant fund, unless you're at the top of the quant fund. Like Meta staff engineers can make up to $1 million in a year, and they're working 40 hours a week. Versus like how many like quant, most of the people that I know who've ever worked quant, they capped out at $500,000 and burned out by the end of it. Versus I know people who got to staff and stayed there for 20 years making like literally 500 to $1 million a year. So you need to take all those things into account. Like, can you work at a quant for 30 years? No, because they're gonna take some math nerd right under you who just went crazy on all the competitions, and they're gonna they're gonna kick you out once this guy comes in, because he has all the new mathematical knowledge. I don't know. I'm just saying random. This salary sounds so crazy for my European brain. These salaries are real. These salaries are real. You can go on levels FYI and get an understanding of salaries. But if you think about it, these salaries are, so pretend you're, okay, look at this. Let's look at the, you can see it right here. Top paying companies by experience. So when you first start working, right, you'll see that at the entry level, all of these quant funds are making the most money at the entry levels. But as you go into the senior engineers and higher, it's not you. The quant funds drop off. So you can see it's OpenAI, Roblox, How the heck did Broadcom get in there? They might get it over here, but I've never heard someone say that they're a principal engineer at quant fund. A lot of I feel like a lot of it is just straight like entry level and a little bit better than that. Like, but let's see. Yeah, these are real salaries. You can look at So I'm a third year CS who is spam applying to internship. It is so hard to even get an interview, but I'm wondering what it would be possible for me to get into big tech. So this is a good question of a third year CS student who's applying to internships and wants to, like, right now is having a lot of problems getting an interview. Honestly, getting into a big tech, there's a lot of luck, but there's ways to improve your luck. So to get an internship in your third year, fourth year, if you don't have a good background, it's luck. If you have background, as in maybe you did some internships, maybe there's different ways to improve your luck at landing these roles in big tech, and I'll explain some of them that you can add to your resume to improve your luck. So I would say coding competitions is really being able to do competitive competitions big companies like that, right? It's also probably math competitions. If a lot of people get into it, they're doing math competitions. They're younger. That those two definitely help. But I would understand not a lot of people have the time to do competitive programming or math competitions in the middle of their degree. A lot of the people getting into to these competitions have been doing that even when they're in high school. So another way is have a really good resume. The amount of resumes that are bad or badly formatted, don't contain relevant work experience, don't contain good projects, etc., automatically kind of disqualify you. So like have a good resume, have a solid resume. Try to land internships, of course. And the process of getting a big tech, if that is your goal, is not like a short term thing. You need to position yourself to get one of these jobs, and you need to do a lot of different things on the way to land that big tech role. So yeah, get into competitive programming, learn how to get good at lead code. What's it called? Try to get into internships. If you can't do internships and get industry experience, do research. But even just do research if it's a really good research lab. What else? Have a really good resume. Work on projects. Those are five things. I think those are like five things you could do to help increase your luck. Obviously, networking, building, like having people on LinkedIn. Go to career fairs and talk to people. You just have to keep putting yourself out there as much as you can, and just working towards it. You won't get it right away. Maybe you will, but if you don't get it, don't give up and just keep doing things that will help you reach that goal. I think the biggest thing is to be cracked at least Glee code. So when you get your limited chance, exactly, you need to be pretty good at lead code in order to get a job at a fan company. That's just honestly. First off, it's hard to get an interview at a fan company, but it's not impossible. But then once you get the interview, are you gonna pass the interview is a whole separate thing, and that's not a given. I know I had a friend who goes to Waterloo, and they're all the people there are good at lead code, and they know like 10 people who had a meta interview, and only 3 of them passed. So only a few of them passed, and like 10 of them, first off, getting an interview is hard, but then also passing the interview. The amount of people who pass the interview is a small percentage of the already small percentage of people who got the interview. So it's like a big funnel of all the people trying to get the interview. Then like even smaller people get the interview. Then even a smaller portion pass the interview. Holy crap! Was ranting. Does that make sense, chat? It's really hard, but what I would say is focus on yourself and what you do day to day. Don't focus on everyone. You can do things in your day to day to help improve your odds, and don't worry about everyone else. So, for example, when I was trying to break in, I could have been thinking about, oh, I didn't start coding when I was younger. Oh, these people in Harvard and Waterloo and MRT are doing competitive programming and I'm not. Oh, I won't get this job. Like, start thinking about that stuff. Instead of doing that, I just focused, opened up Leet Code. Let me do 3, 4 questions a day. Let me learn. Oh, I don't know how to do greedy. Let me study greedy. Oh, I suck at dynamic programming. Oh, this company rejected me. How can I build my resume to improve, right? So there's so many things that you can focus on right for yourself in the day, and don't worry about what these other people are doing. Just improve. Yeah, exactly. Just don't be a doomer. Improve yourself little bit, little every single day. Is fan companies the only thing people care about in the U.S.? I didn't honestly didn't care about ever joining a fan company, and people care about it. I think okay, multiple things. First, fan companies pay a crap ton of money. That's why people care about it. Depending on what school, people care about it. In my school that I went to, some people cared about it, some people didn't. In Waterloo, lots of people care about it. In Harvard, honestly, what I know from the Ivy League students, what I've seen is a lot of them actually wanted to join startups because they just knew so much people who were working in big tech and they wanted to do something different or they wanted to maybe start a company so they got into startups. So I think Fang is it's not the only thing that people care about. It's the thing that gets views. It's the thing that gets clicks. The one thing that I enjoyed about Fang is that they actually ask the lead code questions, and they actually ask the hardest lead code questions. So when I do Fang, I like preparing and doing Fang interviews because I know they're gonna ask me lead code questions. It's just fun to get good at lead code and actually do an interview that asks you a lead code question. Yeah, I've already done content. I've already done content where I'm literally just doing other stuff other than lead code and all. For some reason, everyone just likes my lead code content. I'm gonna be doing. I don't care, so I'm gonna do content on everything. But literally need to do lead code in order to keep this channel afloat. And it's honestly the easiest thing for me to do now. People are always like, "How did you do lead code for 10 hours straight?" Or like, "How do you make your content all about lead code?" Like, is doesn't it hurt your brain? Honestly, it's way easier to write a leak code video than to go study on authentication and present how authentication works. Like leak code, you literally just pop up. You pop up. Some of my best videos I made in 20 minutes. How many important topics like parallel computing, distributed programming are in jobs like you do? It's everywhere, and you need to understand how it all works, but it all really depends on what specific application or what specific product you're working on. For example, if I'm working, there's a lot of teams that work on databases across various companies. Pretend I was working on DynamoDB, right? If I'm working on DynamoDB, I definitely need to understand parallel, concurrent computing, distributed computing. I need to understand distributed systems. I need to understand concurrence. Like literally, you need to learn all that stuff if you're working on DynamoDB. If you're it all it's they teach you this in school, right? Separations of concerns. Everyone just works on their specific layer and pretty much assumes that the layer under them is working as expected. So pretend I was working on a full stack application and I cared and I also had to implement the TCP and like the network HTTP protocol. That would take away from my time working on the application layer and working on the product features that's going to drive business values. I pretty much have to assume that the layer under me is working correctly. Pretend I'm working as a network engineer and I'm building a TCP protocol and I had to and I didn't assume that the cables were set up properly and the electricity lines weren't set up properly. Obviously, I need to know that it's gonna break, but I think it's important to just be concerned about what you're working on. Obviously, know a little bit of what's happening under the hood. But if everyone had to, okay, I need to write my code, then I need to understand how the code is compiling. Then I need to understand how that code is being ran on my CPU. It's like how much productivity would we have if we had to care about all of that? productivity, I keep talking about productivity because productivity is important. Who doesn't want to do more? Who doesn't want to do more with less time? So pretend my job is 8 hours, right? I want to be able to do my 8 hours in 4 hours. Then I have 4 hours for free. I could use that to maybe do more work, or like Paul, do other stuff that I care about. So that's why I care about productivity. Like, why would I'm talking about, and I keep talking about productivity, is why would you want to work on problems? Why would you want to work on problems that aren't productive? What about the what do I think about what do I think about interview coder and Cluely? I think is it a cheating software? 100% I think it's a cheating software. I think a few things on Cluely. I think I watched a little bit about them, and the founders are saying things like, "Oh, like the calculator was cheating," right? Like saying Cluely is cheating is like saying the calculator is cheating. And I think that's a bad take on it, a terrible take on it, because calculator is cheating. It removes the context, right? So calculator is cheating if you're in a math exam where they tell you don't use a calculator because you're literally using calculator when they told you not to. They want to test the specific thing in your head. Like they want to test you on a specific context, and like pretend they're trying to make you do addition, like a addition test, and you're just using a calculator. Then they can't test that you actually know addition. So if you bring in a calculator to do your addition, that's cheating, right? So if they're testing you on how to do an algorithm, and you just pass it through GPT and it pumps you out the algorithm, and they told you you can't use Chat GPT to pump you out the algorithm, that's cheating. That's like my logic with it. So I would never mark it as in like calculators used to be cheating. Calculators, what does that mean? Calculators are still cheating. In a lot of exams, they'll tell you don't bring in a calculator because they want to test certain concepts that if you use a calculator, they would even be able to test. Right? Like there's already look at this brain on GPT thing. This brain on GPT thing. Like they already are showing that if your brain on GPT is not being used in the same way as somebody not using GPT. Like the electrical signals are less or whatever. That's my take on it. I don't know. What's that chat? What's everyone else's take? I've been ranting for literally 1.5 hours, but this is fun. What's everyone else's take on Cluely? Nat, what's up? People are outsourcing their ability to think. We are. Okay, people should not cheat. Okay, is Cluely a cheating software? Let's just think about this in first principles. So what does it mean to cheat by the definition? So if anyone doesn't know what cheating software is or what Cluely does, Interview Coder does is it essentially watches your code and is supposed to be unpredictable. But when you're doing a coding interview, what it will do is write you out the code, write you out the algorithm, so that you can pass your technical interview. That that's like what Interview Coder does, right? So is it actually cheating? What is cheating? Cheating is you're acting dishonestly or unfairly in order to gain an advantage, especially in a game or examination. So are they, first off, are they acting dishonest? So you do the coding interview and they ask you up front, um, please don't use any external resources. I want to understand how you think about things. Just stick to this text editor, right? So the moment you start using external resources, you're automatically acting dishonest. Are you acting unfairly in order to gain an advantage? You are probably acting unfairly to gain an advantage. You're using your advantage is that you're using AI to do your coding interview while others are not, and that AI pretty much has been trained on the whole internet. So you have pretty much somebody who's trained on the whole internet giving you advice on your algorithm. So is it cheating? Yeah, I think it's a cheating software, just by definition. Yo, yo, Patty. But like, okay, is cheating It is le- So what they want to do is they wanted to automate leak code because they think it's a stupid way to examine people's technical abilities. That's a different topic for another day, right? Yo, Patrick. Check this out. There's a paper on your brain on GPT. Yo, Nat. Is Nat in here? This is a good. This is a good paper on your brain on GPT, and this is done by MIT, and they're showing how your brain, your brain's activity, like it could be detrimental to your like cognitive ability if you offload all of your brain and your thinking to using an LLM. So they literally had three different groups. They had a group of one group using LLM, one using search engine, and one using brain only, no tools. And they examined these three different groups, like brain activity, during this study. So they used the EEG to assess the cognitive load when they're writing essays, um, and then also afterwards, after they had these different groups, they had they tried they basically what they're saying is LLM users consistently underperformed at neuro linguistic and behavioral levels. These results raise concerns about the long-term educational implications of LLM reliance and underscore the need for deeper inquiry into AI's role into learning. The illusion of thinking, yeah. Nat, did you read it? Josh Lee, wasn't this obvious? It it is obvious. Well, it's obvious for like the easiest thing to say. It's obvious, right? Or no, Pat. It's not. It's not that. How, you. It's not addressing that it's saying it reduces critical thinking skills because that's harder to measure. How do you measure someone's critical thinking skills? I think it's measuring how well or how much their brain is being used when they perform these different tasks. And then they also measure them on very specific things like months after. I didn't read the whole thing, but basically they're just saying, I think what they're saying is when you're not using an LLM, you use your brain more, and using your brain more is important. Is is better than not using your brain at all when you're doing stuff. Pretend you have somebody working 8 hours a day and they're really all their brain is firing at all cylinders and it's just going crazy, right? Versus someone who's just sitting there, just there's no brain activity. They're saying that pretty much when you're LLM, you're just sitting there using, and there's not as much brain activity, and that could be detrimental to you in the future. So I think that's what they're talking about. Because at the end of the day, like actually using your brain is what builds new connections. I use AI too much. Your brain is fried. You can turn that around. You could always go back on that. You don't have to do that for forever. I'm a bit. Yeah, I'm a bit the way that I use GPT. I think there's different types of people also. So some people will actually be able to leverage GPT or AI more naturally than others. I would say I right now I see there's two people. There's people who use AI to just generate everything for them and don't question it. And then there's people who use AI to research things for them, and they pretty much use the AI as a search engine on steroids, or as a tutor on steroids, or like a 24-hour tutor. The way that I use GPT or AI right now is essentially anything that I would have asked a senior engineer before, or an engineer that knew more than me. Essentially, whenever I get stuck, and before, back in the days, this is how software development worked. You would get a specific task, you would try to solve it yourself. What does that mean is whenever you would read the documentation, you would try to figure out how it all works. Um, when you get stuck, maybe you read the documentation, but pretend you get a bug you're really stuck on. Maybe you'll look at it on Stack Overflow. Maybe you'll go ask a software engineer who's done it. You'll start asking people, trying to find information because you're completely stuck. So what I found GPT really helps you do is speed up that process. So it's essentially just like having a senior software engineer right on your shoulder. Whenever you get stuck, you can ask it things. But should you just ask the senior software engineer, everything? And should you just make the senior software engineer do your whole job for you? You can if your main goal is to just be productive. But if your goal is to actually use your brain and learn and become a better engineer, I would say you wouldn't just keep spamming the software engineer on your shoulder, or the AI, just to do everything for you. I see people consume social media uncritically all the time. Yeah, I think using AI. Yo, John, it's a weekday for me, or it's a weekend for me. It's Yo, John, this is dude. This John, I want to get your thoughts on this, cause you're a big fan of vibe coding, right? So MIT, and also, wait, Apple released Apple. Yo, what's the name of Apple's paper? But John. Basically, MIT did this publication on your brain on GPT, and it talks about how they essentially had three groups, right? They had three groups: a group using LLMs, a group using search engines, and a group using the their brain only and no tools. And then each of them were tasked with were made to do something. I think essay writing, right? So this could be anything. It could be coding or anything. But this one is specifically writing essays. So they noticed that the group using LLMs had the least amount of brain activity happening in their head. versus the group that obviously just using their brain. I mean, it's kind of obvious, but it's still not obvious, and I'll explain why. Or I'll explain like the devil's advocate of why people were saying that they're still using their brain when they're using LLMs. What do you think about two groups of people doing simple arithmetic? One group uses no calculator and the other using calculators. I think, yeah, probably. See, exactly. That John right there is what I see. What a lot of people say. This is why it wasn't as obvious. People are saying that they use their brain a lot when they use the LLMs. That's was that. Yeah, exactly. This is like the other side of it. People are like, since I'm using an LLM, I don't have to work on the easy trivial problems, so I can just work on the hard problems, and I'm still using my brain just as much, and I'm actually using my brain more efficiently because I'm using my brain to work on harder problems. That was sort of um, why it's not that obvious, right? So for example, with the essay writing, people would be like, okay, I use the LLM so I can work on the harder parts of the essay and to produce a better essay. And I just use my brain as much as the person using their brain only, but I use my brain on the parts that mattered. And I was able to leverage the LLM better to do to accomplish like a better essay. And then like that's actually something you could easily study. Just use AI on the front end and you can work on back end system design. Come on. Yeah, but then you can just use the AI for everything. No, no, no. I agree, dude. Like, but which parts matter? Yeah, what? But okay, I think this study also studies this, but I didn't really get into it. So people are worried about not writing, be able to write good essays. I'm not sure. Well, I'm not sure if that's what they're worried about. What they're trying to do is do a scientific study to see if LLMs are better or what is better for us in terms of learning. I think that's what they're thinking about when it comes to like having a more smart and educated population. Like which one is going to be better for us? That's what they're doing. So they're just doing like a scientific study on it. You need some way of testing your hypothesis, right? And the way that they're testing it is by making them write essays and then having humans actually like looking at the essays they produced, right? You need some sort of evaluation, right? So I think it beats the point to say that they're worried about saying they're writing good essays. The only reason that they're doing essays is because they're trying to have something that they're measuring it for the scientific study. Shashwa, what did I miss? I honestly didn't read the dude. The paper's 207 pages. There's no way I'm gonna read the paper. Yeah, you feel like maybe people's learning will drop in some areas, but improve in others. Oh yeah, yo, dude, Paul is so smart. He just said let's have the AI read it. Patrick, okay, so Patrick said people's learning will drop in some areas but improve in others. So how do you measure that? So I think what they're doing is they're measuring it based on brain activity. So they're making three people do different tasks, and they're checking the brain activity on those different tasks. And I think what they mean is the more brain activity you have, the better. the more that you're using your brain, the better. I think that's what they have. I literally didn't read it. Let's see. Let's read the. Wouldn't it be funny if the? I think that's what they tested for, Patrick. You'll read the page. Well, we're both now just saying random stuff, but I think what, or I think we need to read the paper, this 207-page essay, or get the AI to do it. I'll link the paper. This is a really good paper. Okay, what did it say? What if one of them didn't have brain activity to begin with? Uh, like in formative years, if you're not using your brain for school, you're gonna end up bricked. Yeah. I'm not, dude. I need to get my neuroscience friend in here, cause he'll understand. He took a whole master's degree in neuroscience. I think we need to dissect this paper. Let me call this guy. Let me call this guy. Well, using GPT to write essays makes many things easier, but it also and that could hurt your learning in the long run. Exactly. So it can hurt your learning in the long run, and then maybe something like, what do you want to debate now? Is learning even important in the new age? Is actually having knowledge important in this new age? Would that be like the next thing? I think it's would people say the same thing about Google or calculators? I think Google, first off, Google is not generating things for you. It's not generating answers for you. You're still looking at a bunch of sources, and when it comes to computer programming, what it helps you do is just find information faster. I don't think people said the same thing about Google for sure when I first started. Like they didn't have the same concerns. I don't know about calculators. When did calculators come out? Calculators been out for a while. Why did they invent calculators in the first place? Like, what if you look up the history with calculators? Calculators were the precursor to computers. So people were building calculators because they wanted to automate calculations that people were getting wrong all the time. So you'll see like people trying to build calculators back in the days, and people were building like mechanical calculators. Will you literally like torque it, and it pumps out like the derivative, the answer to an integral or something like that. Um, they're trying to automate calculations, and calculations were people were getting those calculations wrong, because when you're working with a big ass equation, the chance that you're gonna get that equation wrong with small little calculation errors is becomes higher. So that's why they developed calculators. And what did it do? It helped us solve those equations, like helped us solve those equations with less errors. Yeah, everyone's looking at it from I'm looking at it from a coding lens. Let's see. But Patrick, your thing is valid. So you're saying, okay. I think what Patrick is saying is important too, right? When he says that, okay, so all they care about is writing essays. Okay, so pretend we had, yeah, exactly. So Patrick, yeah, that's a really important thing. That's important thing that you're talking about, because now we need to question, is the work that GPT is automating still useful? So pretend writing essays, or pretend doing 176 by 123. That used to be useful, but that's when they invented the calculator. You don't really need to know that, and that's not really useful. And now we're doing other bigger calculations, and that's sort of something we don't even have to care about. So so GPT could be making like your it could be making your essays useless. Yeah, it could be making working on essays useless, but then now we can focus on other things. But honestly, if you're if we're talking about long-term educational implications, like when we were kids, we had to do addition. We never When did we start using a calculator? I'm pretty sure the first calculator I touched was in grade 8 or something like that. And calculators were around ever since I was a kid, but they didn't want you to use calculators on purpose because they wanted you to use your brain. So they wanted you to actually learn addition. They actually wanted you to learn multiplication. The test should be both test subjects use the same amount of brain power with one solves harder questions. John, I think this what you said right there is something that's just gonna be tested in the industry. You're gonna have one you're gonna have one company and another company. There's some companies who said I don't want to use AI at all, and some who said we're gonna inject AI across all our workflows, across everyone in the company is gonna use AI, and then we're gonna see which company comes out on top in the market. We'll even see that between countries. There are some countries. Wait, okay, okay. I like this one. Okay, everyone in the chat, say yes that we should stop developing AI. It's too good, or no, we should go harder and keep developing this AI. It could be better, and we need to keep advancing this technology. I asked this earlier, like an hour ago, but a lot of new people in here. Go harder for sure. Everyone before agree. Everyone said go harder. Okay, who else? Way harder. Keep developing. Keep developing. We need to auto. Yo, that's actually hilarious because an hour ago I was here talking to a bunch of other people, like people who are no one's. I don't think any of them are here before because it was an hour and a half ago, and I said, should we keep developing AI? And everyone said, no, 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 no. AI is good enough. AI is good enough. Stop developing AI. It's all the way back. Oh, I lost it already. And now we have like a whole new group of people who just said keep spamming the AI. Why would you? Why is everyone here bullish on AI? Why should we keep spamming the AI? Is it because we have all the software engineers here now, or people working in tech who aren't scared of the AI, or people who have worked in tech? I know pretty much everyone in here has took a computer science course or done computer science, from what I see. Because earlier I was saying everyone said don't. AI should be reduced. AI is not scary, to be honest. Yo, I like that. Honestly, that's my view on it as well, Patrick. People are more scared of it. It's gonna okay. So what's everyone take is that Patrick? What if it takes people's jobs then? Like it's gonna replace people, and what about the job aspect of it? Or okay, so basically, probably Patrick can say people just shouldn't work. Yo, Alex, it's Juneteenth. It's a day off for me. What is okay? Nat has a good point. He says that he thinks that I didn't take Friday off. Nat says I think AI can be super utopian and super dystopian. So if you're watching the news, right? Like who here has heard of the new the term artificial super intelligence, ASI or something that people came they keep moving the goalpost of AGI. And AGI is a term that came out so long ago. The first time I heard the word AGI was 7 years ago. But like I feel like AGI is such a general they just keep moving the goalpost, but I think it needs to be like what exactly is AGI? I'll tell you what AGI is from what I heard it. And then that goes a bit into Nat's point of AI being super utopian or super dystopian. So I mean, back in 2015, back in 2013, AI was very specific, right? It was specific AI. You can AI was very good at doing things, was better at humans at very specific things. So it could be better at humans at predicting a dog or a cat in a photo. It could be better at humans at like predicting like very specific tasks, right? People trained very specific AI. You trained a model to do one very specific thing, like chess, right? That's what it means for AI to be specific AI, right? So when I learned the term general intelligence, how the person explained to me is my friend Brian, the one who did the computer science masters. He was thinking about this in 2018. He was literally going mad about it. But what he said is so AI is better than us at very specific things right now, like chess, right? And it surpassed human intelligence. Artificial general intelligence. So, but it's only very better than us at very specific things. But the amount of things that it's getting better than us is is growing, right? There's models that are better than us at chess that can beat us in Go or yeah, I think it was Go that other game, or that could do like X or Y. Like the amount of things that it was getting better than us started to increase, but we were still creating very specific models to do that, right? We had a model that's better than us than chess, and then we had to make another one that's better than us than checkers, then another one that's better than us at Go, right? So those are still very specific AIs. So he was saying that a general AI is an AI that surpasses human intelligence in everything, not just one specific thing. What do you, and it's not one it's not a bunch of models. It's not like a bunch of AIs that are good at specific things. It's like it's one AI that's good at everything. It's one AI that's better than us at chess, and that same model is better than us at coding, and that same model is a better politician than us, and that same model is a better doctor than us. That same model, that's what general intelligence is. It's better at AI, or the AI is better than humans at every single thing. That's what that, and it's just one model, right? So that's like what I learned general intelligence was. So what implications does that have in the world? Pretend we had an AI that was a better human that was better than humans at politics, right? How would it choose to govern the world? And pretend that the AI was so smart that it knew that it was better than us at politics, and it knew what was better for us and how it should manage the world, and it knew it's better than us at everything, right? Well, that's what artificial general intelligence is, right? So I just explained it like what specific intelligence is and what general intelligence is. Specific intelligence is AI is good at one specific task. Artificial general intelligence is the AI is good at everything. Are we at that point? So like they keep moving the goalpost on what artificial general intelligence is. But it could be powerful. Pretend the AI was a better doctor than us. Pretend we had an AI that's a better doctor than us. Imagine the innovations and how healthy we would be. Pretend we had a doctor or we had an AI that was um, better at doing software than us. Then it could build us the best software, and then we could just use it and enjoy it. That's what I'm saying is like what like if a AI was if a but could it make new discoveries in our own reality? What I said about AGI, like artificial general intelligence, it's that it's better than humans at everything. So that means it's also better than humans at doing research. So if it's better at humans than doing research, it should be better at making discoveries than us. I don't know if I'm making sense here. I'm literally ranting random. Am I making sense? I'm gonna get the guy in here. But the thing is, what Nat said is it could be super utopian or super dystopian. What if AI is so smart that it realize like we make the AI so good and it's so empathetic with us that it could just make our lives better for us and none of the downsides because it's that sophisticated. There's also that side too. So like my view on it is we need to use AI work for us. At the end of the day, it's a human invention. Honestly, a lot of the times I keep yeah, but if we want it to be human like Willis Sika, the thing is we don't understand how the AI. The one thing is uh, the models are black box. Patrick, ask GPT that question right now. Is AI better with private ownership or collective ownership? Obviously, you probably just say collective. That makes the most sense. Ooh, Nat said collective ownership, no guardrails. Let me grab something. Patrick, what's it called? I think AI. It's not really about okay. It's important about who owns the AI, but I think another the thing that people are concerned about is what the AI will do for itself. Like what if everyone has control of an AI, or if everyone owns an AI, but the AI but no one can control the AI. Does anyone have ownership at all? No, the AI has its own autonomy at that point. So that's why people are trying to keep it under control. AI under collective trans ownership has the potential to serve public good. Yeah, I think Patrick, the thing that people are worried about is if the AI will just go out of control. And I haven't seen really good arguments on how they would stop the AI from going under control or like going out of control. I haven't seen good arguments on that. I've seen good arguments on how that if you advance AI, it will be really, really smart and actually has a chance to do something bad. Yeah, that's why people are like, let's stop making it. Do you think that the models are good enough right now, or still bad? I think the model architecture is good enough right now to do what we need. It's just like adding context and training it on the right data, and other you can add other things to improve the performance. But then I guess another way to improve the performance is just build a better architecture, train on more data. So like, there's no point in like scaffolding the AI with a bunch of different things just to make it perform. Then it just becomes traditional software. Might as well just train it on a bigger, better data set. Has anybody watched the movie Her? Patrick, is it this movie? Paul, you watched it? Sucks. There's no way to stop the AI. There's no way to there's not there's I don't see a good way to stop AI development unless everyone in the world agrees to stop working on AI development. I feel like this AI race is almost like the new nuclear race. Everyone's racing to have this new powerful technology because it helps them. It's power at the end of the day. If you have the best AI and the best technology, you set the stage. Then I'll ask you this: would you want? Well, I guess like us right now, we there's people who have. We need Neuralink so we can compete with AGI. Yeah, and then they put the AGI model on the Neuralink, and then all of a sudden we're just like a extension of the AGI, doing things for the AGI. Dude, the thing could go in so many different ways. John, why would you rather report to a human to an AI than a human? You don't like humans no more? John, you're actually jokes. I think finance people probably have a different way of thinking about work and humans and stuff like that, or like, because when you start thinking about it in the concept of like numbers and margins and stuff like that, you abstract away that like there's people working on that stuff. John wants 7 day work week. He wants it 8. Seriously, some people like engineers aren't good at speaking for themselves in human settings. Using AI to manage those people. What do you mean by that? Can you expand? What's Ex Machina? Um, this is the best AI movie. Go watch this on Netflix. This one with Megan Fox. This is a good one. Some people just raises. Some people get raises just because they can talk well and convince someone, and AI can be fine tuned to see through that. Um, Patrick, the ladder. Let's see. Some people get raises because they can talk well and convince someone. Yeah, I'm waiting for everyone to tune in. Holy crap, we had like 40 viewers earlier and we were talking about the randomest stuff. Yo, if you look at my schedule right now for the day, I'll show you. Let me just answer out some people. Like, if you don't think I have anything scheduled, I'm sure I'm just blurring up my schedule. This is my schedule for today. So we're right here. As soon as 11 hits, we're going to be going crazy on coding interviews and stuff like that. I just got distracted talking about AI because somebody in here brought up AI and then dipped. And now all of a sudden, we've been talking about AI for 3 hours and forgot to write a single line of code. And I have a bunch of clips though. Those are all dropping as clips. People who don't use AI are honestly done. 100%, John. 100%. The question is not use AI. It's how you should use AI. When you should use AI. Should you have a 4-year-old, 5-year-old using AI to work on their essay. That's what this study is looking at. And they're saying if someone uses AI, it reduces the amount of like their cognitive load. And then they also had part of the study that Patrick said where they had somebody working on using AI and then moved on to just working on the actual essay from scratch, and it wasn't using it, or like they weren't using their brain. Set. Yo, what's up? Thanks for subbing. Opinion about high school programming lessons? What do you mean opinion? Like, should you do high school? Should you do programming in high school? I think it's an essential skill, and other countries are already making people code when they're younger. I think it's an essential skill. Same thing as math. You have a sweet internship coming up, but I only had to. So the best way to prepare for your internship is ask your employer what the tech stack is and try to build a like a small side project using like that tech stack, and then yeah, that would be my advice there. Learn the tech stack before you jump into internship, because once you learn the tech stack, then you don't have to learn anything related to the tech stack, and you could just focus on the business problem that the company is trying to solve. The reward function of the human can also be learning, and using AI for that will definitely help the AI augment human. Yeah, I agree. Okay, we're working on authentication on my website. Any other topics y'all want to cover? Why do people care about how AI will affect others? Yeah, because it'll make an entire generation stupid, and it could have a crazy effect on us. But like, why did people care that people John? There has to be regulations on things. It we already saw that in order to like people like pretend with these food companies, they could be putting anything into that food. They can literally put crack in it and make everyone addicted. It's like, yeah, it will generate the profit, everyone will be buying it, but then people will literally be dead, or people are unhealthy. What technologies ever had made human IQ lesser over time? I don't know, honestly. Yeah, the way I see it too is like, I've never seen a technology, or once something's out there, it's hard to limit it. So, for example, it's not. I don't know if we can be in a world where like nobody can use AI. Like all the technologies that are used, the way that I see it is, people are gonna use things that's gonna make their life easier, or that's gonna solve a specific problem for them. So the moment people AI stops solving problems for people, and it stops being useful for people, people will just stop using it. Like, even with TikTok and social media, it's like people are using it because they get something they get something out of it, whether it actually just be dopamine, but they're getting something out of it, and that's why they keep using it. The moment they stop getting anything out of it, they're going to stop using it. Or the moment something else comes along that they get more enjoyment out of, they'll start using it. I don't know, have people been more depressed since social media is mainstream? What are the studies on that? John, you're gonna get like me canceled on the thing. KK, I'll send you. Okay, John, let me. John, you could. Okay, KK, I'll send you an invite. Just don't say anything too messed up. Cause or say what's ever on your mind, but think it through. I know you're coming into this unprepared. Yo, John, hop on the call. Hurry up. You already said let me get on it. I already sent you an invite. John, hurry up, hurry up. Oh yeah.
Yo,
All right, okay. We have a vibe coder here. Wait, let me get you on the
man,
screen. Oh, he's here to defend all vibe coders from this MIT
not
paper.
not not even not even all vibe coders. I think anybody that uses AI, you can't.
Okay, wait, let me get you on
If
the screen. Let me get you on the screen.
All right, all right, all right. I just want to defend the people that are using AI, and
Okay.
I just feel like AI should be the main tool that people use. It's like wearing pants. It doesn't make sense that you don't wear pants. It doesn't make sense that you don't use AI. I want you to ask me some questions about this entire thing because I'm triggered right now. I hate it when people say AI is bad.
um, you know I'm a big AI supporter, but we're gonna debate this.
Yeah, dude, it's literally a force multiplier for everybody. For everybody.
Okay, wait, let me get you
I
on
want to
the
see
screen.
what the chat's saying right now too.
Can you turn on your camera?
It's on.
Okay, John, talk. How's his audio, chat?
Let's see what I want to know what the chat has to say. Like,
All right.
John, what about AI and young children development? This guy's ridiculous.
Chat, how's his audio? Okay, audio loud and clear.
I, just so I stay focused, you ask me the question and I'll like not respond to the chat because like I have heavy ADD.
Okay, okay, okay. All right, I'm just.
Don't be afraid to ask me controversial stuff. Obviously, I'll censor myself because I'm raising money right now.
Okay, wait. Say something. Just check.
Hello?
All right. Need to do one thing on my video. All right.
My,
Holy
te-
crap.
my teeth white? My teeth white on this?
So we got a
We're building
vibe.
the
So
future.
somebody came through. A vibe coder came through to defend all vibe coder. I think you said, "Let me get on here. I need to defend all vibe. Let me defend the vibe coders and the AI spammers." That's exactly what you said. I'm gonna pin this. So
Yeah.
okay, and chat, keep me honest because my our whole chat read this paper. So we're just gonna quickly describe what the paper is in less than 5 minutes, and we're gonna get into a very um, like we're just gonna talk about it. And John, and we're gonna see his take on it. He's a vibe coder traditionally. He's somebody who was born,
Yeah,
whose
show.
software engineering career was born in the age of AI. So he just from inception, he was pumping out AI code like asking GPT. Versus I'm more traditional and I started with pen and paper and moved up to using AI tools. That's kind of my journey. But
Yeah.
okay, John, this thing is saying your brain on Chat GPT, an accumulation of cognitive debt when using an AI assistant for essay writing tasks. So I know people probably get sick of this, but I'm gonna explain in less than 5 minutes. There was three groups in this study. There was this group that had an LLM, a group that only had a search engine, and then a group that had brain only tools. And John, fix your camera. You went sideways.
In my bed. I'm just checking if I have a meeting. I'm at work.
Okay,
I had
so
to get on this. I'm triggered right now.
they had three groups of people. Turn on your camera, bro.
Yeah.
The LLM group, the search engine, and the brain group only. Basically, they made these groups perform a specific task, and they noticed that the group with the using the LLM, their brain activity and their like the amount the their basically their brain activity was way less than the people using their brain only, and that's kind of obvious. But what they also said is when they had two groups, they had a group go from brain only to start using an LLM, and then a group using an LLM to going back to just using a brain, or sorry, yeah, the people using an LLM go to use their brain, and then the other way around, people going from brain to using LLM. And they noticed the people who is using LLM and then they moved to only using their brain was still not using their brain the same way as people who went from brain to using LLM. So basically, they're saying that this is this could be an issue, that not using your brain when like performing tasks, and they're just raising concerns about the long-term educational implications of LLM reliance, and like basically what its role should be in learning like AI. Okay, any thoughts?
My thoughts on this is how are they using the large language model and what problem are they solving, right? So let's say they're solving a really easy task. Of course, if the task is really easy, they're going the person that's using the large language model versus the person that's not will obviously use less brain power to solve the same problem.
Mm-hmm.
It's just that simple, right? Imagine you're taking a test, a math test with a calculator or without a calculator. Of course, the person with the tool is going to be solving the problems with less effort, right? But that's not what humanity is about. Humanity is not about solving problems that are easy. We're about solving problems that are hard, that push our limits with regards to our performance. And right now, honestly, like there's some problems in the world, like for example, cancer, that can't be solved with just human tools. Like humans have been working at this problem for a long time. If we empower those same humans with cutting edge tools, and they apply the same amount of effort and energy to solve the problem of cancer, don't you think that with the tool, they can solve that problem even quicker?
No, like this. Okay, okay, yeah, okay. Paul's saying CFA. Like the point in the paper is not about is AI gonna advance the humans. It's more about are they gonna hinder the learning of people and make people dumber over time, and that might
I don't
affect
think
us.
it. I don't think it will. It depends on the reward function of it. It depends on what the human specifically is trying to achieve when using AI. So let's say you're facing a problem of let's say your reward function at university is getting the highest GPA possible. Of course, when you use large language models to that end, you're going to be using less brain power. But what if your reward function in university is actually to be as smart as possible during your time in university? When you use large language models for that end, you will literally be using the tool to learn, and you will learn even faster than somebody that's using traditional methods like going to like a lecture, right? Like here's an example. When you are a first year university student in a weeder course, there's 300 students in there with you. Could you ask, could you increase or decrease the level of the lecture to your knowledge base? You can't. There's 300 other people with you, 299 other people with you. When you're directly using an AI to learn, you can literally increase or decrease the complexity of the concept that you're learning to your level of understanding, and that will help you learn faster. Like traditional methods don't allow this.
Yeah. No, like
Do you understand what I'm trying to say here with the reward function? Like obviously, like most humans, and it's an obvious fact. Like most people, literally, their reward function is not getting better. Like especially in university. Like once somebody hits a 4.0 GPA, do you think that they're trying to max out their education even more? Or like those I don't know. That's my opinion. Like
okay, so what determines our reward function though? That said,
yourself, you're a human. Yourself. You have to decide. That's the power of being human. You literally have to you say, Nat, what are my values? My value is like friends, family, profit. Okay, those are my three things that I love about this world. Okay, my reward function is that. Don't let some other random person tell you what your reward function is that doesn't even care about you.
okay. Patrick expand okay. Will LMs help us change oh okay, so but like right now, what you're saying is like a lot of how school is structured for learning is based on that sort of reward function of okay, you have it, we're gonna give you tests, we're gonna make you write this essay, for example, then we're gonna judge that you created that essay correctly and that you like built a good essay, and that's kind of how they test it. So
Yeah, yeah.
like pretend
Like,
so what are you saying?
okay, so
Wait, okay, let
I,
me ask you this:
I,
is should kids be using an AI? Like what
of
age?
course, 100% at literally age 0. Okay, so imagine if I had AI at 5 years old and I didn't know how to answer math, right? Okay, James, you and I, right? Where were our parents when we were 8, 9, 10, 11, 12? Dude, our dad was working hard. Our mom was working hard. Could they afford a tutor still? No. For 3 kids, no. They can't even be there to babysit us watching doing our homework. Imagine if you have an AI doing that, teaching us as a
Yeah.
kid.
Okay, but you're
Obviously, we're
thinking
gonna
you're
dominate.
yeah, I see. I know. You're like obviously like the AI is there and you build this technology and people are going to use the technology in the weirdest ways and different ways that you're possible, right? Like people are using this AI literally to offload their thinking. That's kind of what this study is saying because they're giving these okay, they're give did this I didn't read the full paper, but they're telling these people to write an essay, right? So you're saying if your goal is to write a good essay, there's two ways you can go about it. It's the same way as you want to write a good software. There's two ways you can go about it. You could just use the
Yeah.
AI to generate your whole essay for you, or you can use
Okay.
the essay, or you can use the AI to help you figure out how to build the right essay and then go from there. Like kind of like using that like it all depends on how you use the AI. And then like what Paul is mentioning is people are humans are just naturally lazy, and humans are
Yeah.
gonna just do the thing that's easiest, which is
Sure.
just like you could use the AI to be your personal tutor and teach you, or you could just use AI to just finish that essay for you just there and then. You don't have to worry about it. You can go play Call of Duty Modern Warfare
Yeah.
8.
Yeah. I think you'd be surprised. I think you'd be surprised. Like in competitive field, in competitive places, maybe because most of your people are from North America, right? Like you live really easy lives. In China, you don't like those people are working 24/7 with AI. And then we wonder why a company like DeepSeek can like release a model on par with ChatGPT for $6 million. Like like people are just surprised about this.
CFA tried to not to mention China challenge. Yeah,
right?
but like
And honestly, like if like at the end of the day, oh man, Paul, the DeepSeek number, dude, I can literally build an AI that replaces an equity research analyst, and I did it in like 6 months. And those guys get paid like $200,000. John, did those kids in China choose that for themselves, or did society nurture that mindset? Honestly, like the way that I think about it is, let's say you have like a population and they all have AI. Do you think like right now the distribution will change? Like, do you think the percentage of lazy people with AI is the same as a same percentage of like a society with AI? Do you get that question? Like before AI, are there more lazy people as a percentage of the population? I don't think so. The distribution is always going to be the same. And the people that don't use that use AI are just gonna like be better. I don't know what to say about that.
I don't like, but they're just what this paper is saying that it limits people's learning. So they didn't tell people how to use the AI. They just made people. They just gave a group of people using AI, and then people not using
Yeah,
AI. And then this is
yeah,
the outcome of this, like objectively, was that the person using the LLM was not using, like, there was less cognitive load and less, like, they use the EEG to track literally brain
yeah,
activity, and there's less brain activity. And then when
yeah,
they made that person working on the LLM switch to actually working on, like, just using their brain, like, it still wasn't working well for them, and they had like lower recall and stuff like that. What else? They underperformed on
yeah.
other things. So that's kind of like they
Yeah.
just did an objective study. I think this is going to be important moving into the
Maybe
future.
maybe the sample size is too small and large language like the users don't actually know how to use large language models. Like I think I think you have this perception that like anybody could vibe code. Anybody could use AI to write an essay. Have you ever seen like an equity research report from somebody that just used the Chat GPT UI? It's trash. It's literal garbage. Versus somebody who actually knows how to use like the large language model at like the really at the fundamental level, like calling the API, controlling everything about at like a lower level function. It's not the same. It's really not the same. And definitely like when I first started using ChatGPT and like using AI heavily, I thought about like, hey, anybody could do this. But then as you get better at using AI and Cursor and all those tools, you realize that like over time you can be a better prompt engineer. You can be a better fine tuner. You can be better at retrieval augmented generation. The base models aren't just the base models. You could actually make them even better than what they are.
That Yeah, that makes sense. Let's take
Right?
a
It's like saying a human without a car could get to from point A to point B. Okay, a human with a car can also get to point A to point B.
Okay, but
And
okay, what they're talking about is like most people aren't writing equity research reports. This is like super scoped. So yeah, like I think we need to think about it in a more general sense. Like writing equity research reports, pumping out good code is not the only thing that humans need to be
yeah,
doing, right?
yeah,
Like
yeah,
using their brain and learning how to write an essay, they're learning how to like they're learning grammar, they're learning how to structure sentences, they're learning how to tell a story. These are things that they learn, and when they go to interact with people in the real world, they need to use, because at the end they were humans and we need to be talking to each other. So if
yeah,
as humans it takes away from some of those like things, how will that affect
yeah,
us?
yeah. So is the question like, since AI is abstracting away a lot of the way, like a lot of the things that we do now as humans, will we get dumber as a result?
Yeah, that's one thing. It's like our population gonna
Okay,
become dumber?
all right. Okay. Largely the stuff that we used to do as humans, like like we used to be hunter gatherers. Hunting, gathering, building a home, um, those have all been abstracted from us. And because of that, we can really apply a lot of our knowledge to like doing things like things like building AI. Isn't that like did we get dumber from that? Abstracting things in the past? I don't like as
Well,
a
okay,
race, like
okay.
we've literally evolved.
Well, what made the human species more like powerful and survive better than other humans? Right? It's in
Ability
our
to
brain.
adapt.
Isn't it our brain?
Yes.
Like we are the smartest species, and that's why,
Yeah.
right? That's they even had different humans. Like basically that's what I read online. They're saying this is why humans are what we are today compared to other animals is because our brain, right?
Yeah.
So
Like
we
if our brains are so good, wouldn't we use like AI to make ourselves even better?
it depends. Like the like the brain is the muscle at the end of the day, right? You need to train that muscle. You need to use that muscle in order to keep it good. Like it's still a muscle. You know that if you keep training your brain, you have a more powerful brain. There's other studies on that. I don't know the exact scientific terms, but um, pretend that like what people are worried about is that this AI is taking away from us actually having to use our brain, and if we as a human species do not use our brain properly or do not are not like using our brain to the best of abilities, like
Yeah.
what will that do for us?
Yeah. Honestly, we'll be solving harder questions at a younger age. So like, okay, right now you could just use AI to write an essay when you're 18. Do you think a 5-year-old could write an essay at 18 with AI? Just
Okay, yeah,
just
yeah, no,
make
no,
the bar
Paul
the
makes
make
it.
make make the bar even
This is
less.
something like I mentioned, like yeah, abstracting things that you mentioned, like the hunter gatherer stuff. It did make us weaker on a physical sense. Like there's even stuff on our body that used to be there because of us of like before, like wisdom teeth are for example, right? And like certain things about the human
Yeah.
body that are no longer needed, and they could just straight like take them out. It's not needed no more. It's like because we weren't using it. Imagine to the point that this thing is so good it could think for us. We don't need to use our brain, and that like the brain is no longer the
Yeah.
most like no longer
Yeah.
needed essentially. Think about that.
Yeah. Like what I don't understand. Like when people use AI, I just have a hard time like grasping the concept of just because I have a tool, it means I think less. Like literally, because I'm still gonna apply 100% of my time. Like
Yo, okay,
I'm
okay, John. Let
gonna
me say this.
I'm
Like you're thinking about it in like a psychological and like psychological sense. Like I can't grasp it, but let's think about it in like the most scientifical way possible. How do we check that? That's what they're doing. Like they're not just they're trying to actually measure what you're saying here, and by they're measuring that by actually making them do a specific task, measuring their brain activity. Like they're trying to quantify it. You're doing it more like qualitative, like how are they not using it? Like, but isn't that something we can quantitatively measure?
can't you change the way you measure things?
What do you mean?
So like in this specific report or like the specific study, two like they okay, maybe I'm just hitting a block here, but the test somehow shows that two subjects, one with AI thinks less than the other person to solve the same problem.
Yeah.
Is that right?
Is thinking less. Yeah.
To solve the exact same problem.
Yeah. Chat and just say like if that let the chat answer real quick because they were reading it while I was on this thing the whole time. Yo, Sidar, I got you right after this. 5 more minutes. 5 more minutes.
Oh
Unless it's
man.
late for you. We're having a juicy convo right now.
Like the situation should be, okay, two subjects have the same limit on time and energy to solve as many problems or the hardest problems possible. Who solves more? The human without AI or the human with AI? And
Okay,
I think like 99% of the time it's the human with AI.
okay, let's talk. Let's read a couple bullet points here, and we're reading a this page. This paper is 207 pages out of context, so I'm literally reading stuff completely out of context. I'm reading two paragraphs out of a 207-page thing. So MIT, don't be mad, but basically, I think I'm in the conclusion, or I'm somewhere. It says early AI reliance may result in shadow encoding. So LLMs groups poor recall and incorrect coding is a possible indicator that the earlier essays were not internally integrated. So that means they have trouble actually internalizing it. So you generated all this. Let's take it to the equity research or coding. You generate this equity aid research, but you're kind of regurgitating, or you're not really internalizing. You don't understand what it generated. You kind of just shot it out. All right.
Okay.
Another thing, withholding LLM tools during early stages might support memory formation. Brain brain only groups stronger behavioral recall supported by more robust EEG connectivity suggests that initial unaided effort promoted durable memory traces, enabling more effective reactivation even when LLMs were introduced later.
Yeah.
So what they're just trying to do is they're I think they're just trying to see the Paul saying is kind of dumb.
Like they're just so they're saying early AI reliability can result in shallow encoding. And if your reward function is learning, you are going to adapt. You're gonna realize like, hey, over time I'm using AI, I'm not learning. Like for example, me personally, right? Like, okay, when I used AI to literally learn how to write Python. Like right now, like would you say I could code Python?
Yeah,
I would say I can,
yeah,
right? Obviously, like I got to a stage where I could literally develop scripts without knowing some certain things. And then when I realize that I don't know that certain thing, I'm just gonna use large language models to learn that certain thing.
yeah,
Like
yeah,
like I'm not the type of person that just like literally doesn't grow over
yeah.
time.
I
Like
see.
I'm gonna identify gaps because I'm using a tool, and then I'm gonna use that tool to fill those gaps.
Yeah.
It's like imagine if you're vibe coding a website, right? Okay, once you get the feature out, do you stop there? Once like let's say you have two people, one's a vibe coder and one's not. The one that's not will get to a solution maybe 3x the time of a person that's vibe coding, right? Like to get a feature out, a non-vibe coder would take 3 hours, a vibe coder would take one.
Yeah.
And this is like empirically something that you see in real life. People honestly say like I do something in an hour that would have taken me three. Okay, that person that that made the feature in 1 hour can now spend 2 hours doing unit tests on their 1 hour of code, like on the feature that they made. Who do you think will have the more reliable code when it goes into prod, given the same time constraints of 3 hours? I would trust the person that vibe coded 1 hour and spend 2 hours testing their vibe coded
Okay, but
work
how do you
versus
how would you test it if you don't understand what's going on? By just keep
Okay, yeah, that
reprompting it?
I mean, at that point you have to know like how to unit test. But what I'm saying is like they both have the same level of skill,
Yeah.
and one just has a tool. That person will the person with the tool will naturally just like produce better code. Like let's say they have like the same
But
time,
okay, but
the
at
same
some
amount of
you're saying
energy, the same amount of skill.
at some point you need to
Like,
use your
oh,
brain. What if you don't like you did at some
you
point
are
you
using
need
your brain. You are using your brain. Like when you're prompt engineering, you're just mindlessly telling the AI, "Hey, unit test this." Oh, the unit like how like you need to have some level of taste and some level of understanding to identify like whether or not the unit test or the feature that the AI made is actually good. Like I don't know about vibe coding where you're just not even looking at the code.
That's what vibe coding is,
Like
isn't it? You
no,
just
it's
spam
not.
the AI
It's
to
not.
generate.
It's that's not it. That like people who produce that people okay, like do you remember when you were making thumbnails with AI? Every single thumbnail looked the exact same.
Mm,
Do you realize that? Did you notice that?
yeah.
Okay, when you look at my website, do you think that it's AI generated? It's freaking doesn't look like any other website that exists.
Because you didn't use
It's
AI for
like
your front end, didn't you?
I did use AI. It's just I literally I have human I also applied knowledge. Like I literally I didn't just mindlessly prompt the AI, hey, like make this better, make this better. Like that's super that's not what vibe coding is. There's like levels to vibe coding, and I think people just like look at it from the inside looking in, thinking that it's easy. Of course it's easy to get like a simple app. It's one like imagine vibe coding a 1 million line code base. You literally need to be good at vibe coding to do that.
Yeah, but then now you're like taking the vibe coding way out of context. Like
No, vibe, but
you're no
like what?
longer vibe coding when you're doing all this manual stuff. When you're not using
Okay,
the
then I
AI,
can't. Then all
then you're
right,
not
then
a
I can't
vibe.
identify. But I can identify as a software engineer at this point. Then
Yeah, you can probably identify as a software engineer at this point.
that but I don't
Go.
even know what to say. Like it's so hard. It's so hard to like. I
Go.
don't even know. Maybe my definition of vibe coding and using AI to like write essays is completely different than like what most people do,
I guess you could
right?
vibe. I guess you're still vibe.
Like I mean I feel like I am still a vibe coder, but maybe I'm just like looking down on like
Like
I
how
think
many
vibe
times
coding
did
is the
you
derogatory
how
term.
many times did you like actually just go into the code and make changes for yourself and try to read documentation to understand what's going on there? Like how many times in your day?
Um
Like out of like does that happen at least
like
more than 10 times in a day or no?
yeah, it
Exactly.
happens a lot.
This guy
Like it happens a lot when you
like you
look
were
at my but like okay, but 90% of my code base wasn't written by me typing into the text editor.
what? Say it again.
Like 90% of my code base isn't me writing into a text editor. It's me interfacing with the AI chat, which the AI chat writes in my text editor. I read the text editor, and then I revert or accept what's in the text editor. I still look at the code. And even like when you prompt engineer, like the stuff that I'm working on right now, like
You're never just like going in the code editor just like typing, going ham. Okay, okay, okay. Okay, yeah,
hell
you're
no,
still
you
vibe coding
can't.
that.
Even right now, like when okay, ask ChatGPT, ask Gemini, ask anything about model context protocol. It literally doesn't understand like how to even deploy that. You literally need to read the docs yourself and prompt the AI UI AI agent like Windsurf or Cursor to like you literally need to prompt the AI with knowing the code base. You can't just like build it. Oh man, get France on the
Yeah,
call.
it's all
Let's
good.
see the website he built.
All right, okay, I have to hop
Let's
on to
see
the
like
next coding
oh man.
interview, but I know you're at work. We talked for 30 minutes. Go work your job and
Yeah, yeah.
be
No,
productive.
man.
All right,
I'm gonna bounce from this
okay,
too
catch you,
with the
bro.
help of AI. Okay, peace.
This guy's attacking the chat. This dude's a character. Chat catching strays. That's so funny. All right, dude, that was 3 hours of just like chatting random stuff. Okay, let's get into some coding interviews. Siddharth, you're up next. Okay, Patrick. Yeah, yeah, I got some time if you want to talk. I know you're at work too. Yo, what's up?
Yo, hi James.
How you doing, man? Sorry for being late.
No worries, man. I was just watching through your stream and was listening to what he had to say.
Yeah, we had to get him on. He's a self-identified vibe coder. So, what about you?
No
What's your
worries.
background?
Uh, I'm actually a pre-final year student based in India, and I'm more into like development and freelancing than the DSA stuff. And since I saw your channel, I got to know that it's quite significant for us to study DSA and go into competitive programming to get jobs in FANG. There are not much resources out here since we don't have like high level stuff and those universities which like MIT and other stuff. We do have IITs and high level institutes, but again, as I said, we don't have much cultural awareness about these stuffs.
In India?
Yeah, we do have competitive programming and other stuff, but I'm talking about like niche level universities like tier 2, tier 3 colleges.
Okay. So let me think about this. So you're in like a tier two or tier three, and your school is not teaching you DSA. So how are you learning, like through YouTube and stuff? Kind of.
Yeah, YouTube, I got to learn about Tourist, if you know him, Code Forces Grandmaster.
Nice.
Yeah, so I was inspired by him. Then I saw that he's such a prodigy. Then I thought, let's try and see what it has to offer.
Yeah. So like when you were watching you said you watched my videos and you kind of it made you think that it's important. Like
Yeah,
why do you think it's important to know data
uh,
structures and algorithms?
like I saw several interviews where children of my age and even younger were like experts in developing algorithms and other stuff. And as I said, I'm into freelancing. So I got to know like this person you just interviewed, he talked a lot about vibe coding and other stuff.
Yeah.
The thing is that vibe coding doesn't get you too far. At some point, you need the basic underlying understanding of data structures, algorithms, as well as the niche crux which you need to develop standalone applications for clients, if you know what I mean.
Mm-hmm. Nice. Cool.
Yeah.
Yeah.
So
How far are you in your coding journey? And you're still in school, you're saying?
yeah, I am in my like third year university.
Nice. What have they taught you so far in there? Like what's the
Man, they
curriculum
teach
like?
every single language in a single semester. Like, to be honest, we just had a subject named web development, and there existed like 5 languages teaching you different stuff throughout the like semester. We couldn't focus on single language. As soon as we started getting hold of something, they instantly switched to another, and transition was so like drastic that we couldn't understand what was going on.
Damn.
Like heavy stuff, but not to complain, it is what it is. We have to do our own journey, and everything would be, I guess, sorted if we do it on our own way.
Yeah. So how many questions have you solved?
Around 287,
Wow.
as of today 290.
As of today, 290. That's a lot. Okay.
That's a
I'm
lot. You're joking, man. You have 600 and
that's like the going from 0 to 250. I would say going to 0 to 300 is the hardest, and then after that, I've done it over the span of 5 years. So
5 years.
yeah.
Okay.
Okay, I sent you
So
the
it's
link.
like a resilient journey, to be honest. Okay.
Well, yeah, like I've been through 3 interviewing cycles, as in I changed job 3 times. Well, first my first job was getting or first was trying to get into the industry. I did about 300 lead code questions just to get my first job. Between my
Okay.
first job and my second job, I did 200 more questions, and then
Hmm.
like getting to FAG like another 150 questions, kind of. So it's not like
Hmm.
you just should spam 700 questions in one studying cycle. That's I don't know if that's the most use of your time, but I would say at least solve a couple hundred, maybe 300 before like during one cycle, and then over the years, I'll probably be having to do leak code for decades. At some point I'll have 1,000 questions done, but that it's not like I'm doing all at one time. It's a balance, right? I need to balance lead coding, actually learning real stuff like projects, and actually doing well at my job. All these different things like family, all that stuff. Like there's more than just spamming lead code, but
Makes sense. Okay. So the first job you had was from direct like selection from the university itself.
well, I did internships, but I did all my internships in Canada, and then I moved to the U.S. for my first job out of college, and that wasn't to the university. I had to just apply for start. I wanted to join startups, so I was just applying at a ton of startups.
Okay, which is cool.
Okay, we're gonna get into the first question. And someone says, I've known people that have done less than 150 but got lucky in their interviews. And yeah, Eric, they got like the point in there is they got lucky with 150 questions. Unless you're really smart or you've seen the question before, you're probably gonna fail a good percentage of your interviews with only 150 questions done. I would say you'll fail at least half of your interviews, even more. And in a world where interviews are just hard to get, you can't afford to fail more than half your interviews if you're already only getting interview request 1 out of 20 interviews. So that's why you need to make sure that when you get your interview, you pass the interview. And how do you make sure you pass your interviews? First, you have to do really code problems by yourself, but then you actually have to do things like Siddharth said here, like or what he's doing here, hopping on a coding interview, and I'll test him right now under pressure in front of 40 people watching and see how well he does and give feedback. And you could simulate this by yourself too with all your friends in school. I think when I was first graduating, I was doing this a lot. Me and my friends, we would mock interview each other once a week. We'd force ourselves to hop on and solve questions. And it's like the funner, more like community way to do it. And I enjoy it a little bit better. Okay, okay, how are you in terms of things like arrays?
I would say decent. Yeah, I have solved quite a few of array problems.
Okay. Um, the first question I'm gonna drop in.
Uh, Sorry to interrupt. Can I switch the language to C++ if you don't
Oh
mind?
yeah, you could use C++. You could use whatever you want. Feel
Okay.
in this interview, feel free to use whatever programming language you like. Feel free to run the code as much times as you like. We're prioritizing working code in this interview.
Okay.
So this is a classic question, but there's a twist to it. So pay attention to the twist so we don't go the wrong direction.
Okay.
So we're gonna be given an integer of length n and an integer target. We need to find 3 integers in the list of numbers that the sum is the closest to the target. The closest, not exactly.
Okay.
Does that make sense? And I'll give a couple examples.
Yeah,
So
sure.
we need to find 3 numbers that when you add those 3 numbers up together, it's the closest to the target. Then and or pretty much figure out what the closest number is to that if you add up three different elements. I'll let you go.
Okay. Uh, so let me go through the problem statement once and then go through the examples. Then I will make some notes if you say.
Yeah.
Okay. So we are given an integer array nums. Okay. Should I make my notes right here? Okay.
Yes, please.
Okay, we would have a nums array and our goal is to find nums I, three integers. I believe these indices should be different, obviously, I think.
Yes, different.
Okay. And the goal would be the sum must be closest to them and not precisely that. Okay, so it's like using a threshold value which we can monitor if the sum is approximately equal to the target. Okay, so let's go through the first example. We have -1, 2, which is -1 and 2. This is exactly 1. Return the sum. Okay, three integers.
Three.
We have
Yep.
this is 2. Okay, then -1, 1, and -4. This would be -4. Okay. Okay, so I got it. Okay. -1 plus 2 plus 1. This would be 2. And there's no other triplet which could have a sum less than this.
So the sum that is closest to target is 2. If we add -1, 2, and 1, we get 2, and that's the closest to target 2. Or target 1.
Okay. And in second scenario, we have 0 plus 0 plus 0, which is 0. And the target is 1. Okay. Okay, man. This is a different approach. I need to think of it. The first approach I think of is just simply naive or brute force, which would have time complexity of order of n cube. And I believe this is not optimal. We don't have the constraints right now, right?
N cube algorithm is gonna time out as soon as n gets like any reasonable size. I would say so.
Yeah, makes sense. N cube would obviously. Okay, so we can just go past this. Okay, the second approach I am thinking of is it's like the threesome problem, but not exactly that. In threesome problem, okay, could have 1 and 2, and then we could search for the nearest element that could actually get us nearest to the target. Okay, let me think. So we would have the first for loop. Let's say we iterate over the array elements from 0th index to the last element. Okay. The main thing would be to consider using a hash map for each element in the array. Firstly, I will store each element in this hash map. Okay. Let's say I have stored all the elements in hash map -1, 2, 1, and -4. Then I would go through the array elements one at a time. We have -1. Okay. Then for j equals I plus 1. Okay. Let's say we have this, and then we could check for remaining sum. Like, let's see what would be the remaining sum after adding these two, which would be nearest to the target. Okay, let's say we have -1 and 2, which is 1. Okay, 1. Remaining would be target minus nums I plus nums G. Okay, now I have to think of how to handle the nearest third element. Okay. We have -1 plus 2, which results to 1. And we can find 1 in the hash map. Okay. Then I see target 1 minus 1 would be 0. I can certainly not find 0 in hash map. Okay. I think I
So what elements
can.
are we storing in the hash map? Okay, you're trying to flip it sort of like to some where.
Yeah, I'm trying to associate it with the threesome problem. Uh, and thinking like I was thinking, we can certainly add up two elements and then we can search for the third in hash map. It's not necessary that it would exist. And then I'm thinking like I can use a while loop such that I find the target somehow inside this. Like I can just keep on increasing this rem sum until I find the element in hash map.
Okay,
Like
let's talk about this for a second. Let's go back to the
okay.
naive solution. What would be the naive brute force solution to generate this?
Okay, naive solution would be three for loops, and then we can certainly add them up, which and store it in a sum variable, and then we could like keep a buffer which would store the minimum difference between the target and the resultant sum, and
Yep.
we could we could search on this difference, like we could keep a counter for minimum of this. Like let me make some. Like we could make a variable sum. Sorry, nums I plus nums j plus nums k. Hopefully
Mm-hmm.
this is clear. And then I would find a difference which would be target minus the sum.
Yep.
And then I could check for, I could iterate for the minimum difference that is available in the
Yep.
entire traversal.
That makes sense. Okay. What's the slow part here? What's causing it to slow down?
The third loop, I believe, like,
Okay.
uh, and then we have to iterate for the
Okay.
difference to be minimum also.
Okay. Pretend that I was just looking for a specific target. Let's work on that first. How would I speed it up? Like I was just looking for one target. I
Uh,
was looking for the
just
exact
one.
target. Pretend let's just do threesome for now and we'll expand it if we need it.
Okay, okay,
Like pretend
makes sense.
I was just looking for the exact target then. How would I
Uh,
optimize this N3 algorithm and how good would it get?
okay. Uh, we can certainly account for this third loop and reduce it to an order of n squared solution. Like we could add these two elements and we could search for the third element in the hash map. If this element exists, then we have found our triplet.
Okay, how would
I
that look
think I'm,
like?
uh, how would that look like?
Yeah,
So
can you
do you
explain
want me
further?
to pseudocode? Okay, let me
Yeah,
dry
just
run through
okay.
the
You could
example
just you
itself.
could just yeah. Let's dry run it through a very simple example. Pretend
Okay, let's copy this example and run it here itself. Okay, so in the first iteration, we say we have -1 plus 2. This gives us +1, right? And then we could look up for 1 in the hash map. Since we already stored each of the elements in hash map, our hash map would look like this. We would have 2, and then we would have 1, and then we would have -4. Okay, so our hash map would look something like this. And then we could easily look up for 1 in the hash map. And if we find that we have found a possible triplet, which would be uh, -1, comma 2, comma 1. So we have found one of our,
but how do you know that it's not one of the elements that you're already looking at?
uh, by accounting for the indices, I think.
So
Instead
for
of I.
example, okay, let's run through a very small example. So we
Okay,
have -1, -2, and then pretend we have -4. -1 equals 1. Pretend the target is -3, right?
-3. Okay,
So how would you
okay,
run your and then generate me the hash map as you're doing this. So we have a hash map. Generate me the hash map or the solution. You're gonna and also show me how the pointers are gonna behave.
okay, certainly. So first of all, we will start by populating our hash map with the value and the index it is found at. So it would be -1, 0, since -1 is found at first index, then 2, 1, then 1, 2, and similarly -4, 3. So this would be the hash map.
Mm-hmm.
Okay, so now let's account for the pointers. In the first pass, we would have, yeah, certainly like this. And then we would have second loop, which would point to 2.
Mm-hmm.
Then the sum of these two elements would be -1 plus 2, which is
Okay.
1. Okay, right? So now we have to find our element such that so we need 1. So we need -1 plus 2 plus something which is x, such that the target becomes -3,
Yeah.
right? So
Mm-hmm.
we can rearrange this equation, form it -1 plus 2 plus 3. Sorry, we could keep x here. This would be -3 plus minus of -1 plus 2. Okay, hopefully I'm clear. So
Yeah.
we can find the remaining sum. Like the remaining sum would be something x, or better
Okay.
I
You,
call
you
it
just
x.
rearrange for x and that will
Yeah,
equal
I just find for the elements, and
-4, right?
then I can look for this element in the hash map if it exists, and I will make sure. Let me just type it in. So it would be -3 and minus of my this would be +1, and -3 -1 would be minus of 4. And we certainly have -4, as we can see. So we have lookup for -4 in map. Okay, so we looked up, and now we will examine the indices for each of these elements. Since these two indices would be already taken care of for, this I say is I, and this if I say is j, which would be, start from I plus 1. So these two certainly can never meet in a single iteration, right?
Mm-hmm.
And then I can check if map of x is not equal to I, and map of x is not equal to j. Then I can certainly assure that a triplet exists, and then I could just report the answer.
If I
So in this case, map of 4 would be map of -4 would be 3, and -1 was 0, and 2 was 1. So 0, 1, and 3. So we can easily
yeah. What
report
what
the
if, what
index.
if there's multiple -4s? Would that cause issue?
If there's multiple -4s,
Because here you're only
no,
storing.
it won't cause an issue, I believe, since it would update the hash map to the last index of occurrence in the array nums.
I see.
Uh, like for example, if we have nums -4, -4, and -4, and we are looking for something like -8, -12, right? So the map would look something like this: -4, and it would automatically update to the last index of occurrence in this. And then we can apply the similar algorithm, and it will take care of itself.
Okay. Yeah. Go ahead and implement that code then.
Okay. Uh, okay, let me go through once what I have so far. Okay, so let me just, I think I would need to import, yeah. So I have imported the library utils. Okay. Okay. I can make a solution class for solving this. We are pretty far from the actual problem, if I believe
It's
still.
okay. We'll just work with this one, and then we could just move on to a different question.
Okay, okay. What does it want me to return? The sum or uh, what does it want me to return? The indices of occurrence or the elements or
Yeah,
the sum?
the just the indices.
Just the indices. Okay. I can take in the target element. Okay, then I can solve for it. Okay. So first I would start by preparing my hash map, which in this case would be an unordered map. Okay. So I have my hash map and then I would populate it with all the values inside the nums. And map it to the index of occurrence. Okay. So I should not do this. Should do.
Yeah, I think it makes sense. So let's move on to the next question actually, because I think I got a good grasp of your understanding there.
Okay.
I'm gonna switch it to the next question.
Okay.
26. So this is like a more of an interval one. Kind of like a real world question, but pretend that we have a bunch of meeting intervals where we have the start time and the end time. This is the start
Okay.
time and the end time. What are the number of conference rooms that you need to have to handle all these meetings? So this one you need two meeting rooms because we have um, pretty. I think because these two over or we need to create a new meeting room because some of these overlap. Let me see. So if
Okay.
this, pretend this one takes from 0 to 30. That's fine. Then we have 15 to 20. So what we can do is we can have a meeting room for this guy from time 0 to 30, and then 5 to 10 needs to overlap with them. So we need a new waiting room or new meeting room. But this person will be done at time 10, so we could go from 15 to 20 with this. So these two can share the same meeting room, and this can just do one.
Yeah, makes sense. Okay, so this is like scheduling problem.
Yeah.
Okay, so we need to schedule our meetings so that we use the minimum number of conference rooms, right? Okay. Given an array, meeting time intervals, where intervals is start to end. Okay, return the minimum number of conference rooms required. Running through the example, we can see 0 to 30, this would occupy the first room. And as you said, these two meetings could be accommodated in the second rooms. Okay. Let's see how about this 2 to 4. Okay, so this would take one room and then we have 7 to 10. Okay, this could be accommodated in a single room and hence we have the answer one.
Exactly.
Okay, okay, so this is like a practical problem. resource allocation or meeting scheduling. Okay. Looking at this, just by reading the minimum number of conference rooms, I think this is a greedy problem. If I'm going through the correct path, please do tell me. Just by looking at this, okay, greedy. Let's see. We have 2 to 4, and then we would have 7 to 10. Okay. So the first thing that comes to my mind is to sort the given intervals based on the start times, so that we can just account for the start times, like which meeting should be adjourned or scheduled first and then followed up by others.
Sure.
Okay, let's see. We have 2 here, and then we have, okay, more like 2 is not of use. We have 4 here, and then we have 7. Okay, let's see if they overlap. No, they don't. So we can accommodate them in a single set. Like these intervals could be accommodated in a single room. And hence we could report the answer to be 1. We could just keep a counter, and then we could increment it in case some meetings overlap. Now let me run through the second example, I believe, or more like the first example.
Yeah, the first example is actually more complicated.
Yeah. So we would sort based on the start times, as I said. It's already sorted. And then we would have 15 to 20. Okay. Let's say we have a variable name meeting rooms, which will be initialized with 1. Of course, we need a single meeting room first. Then let's see. We can go through 30, and then we see it's 5. Since 30 is greater than 5, we do need a meeting room. So we would need to add one more meeting room to our like inventory or something, we can say.
Sure.
Okay. Then similarly, okay, let me copy this. Now we would have this implies that meeting rooms are now okay. Then we can check for this. Now here is the case. Since 10 is less than 15, so the later meeting could be scheduled in the same room as the previous one. So we won't need another meeting room, and then we could accommodate the same meeting in the same room. Okay. So there would be no effect on meeting rooms right now, and hence we can report the answer to. Okay.
How do you know there's no effect on meeting room though? Like how would you look back to figure out if there's a open meeting room?
Like I'm checking the like for each interval, I'm checking the end time with the start time of the next one. And if I see they overlap, or if they overlap, then I would need to increment my count for meeting rooms, and else the meetings could be like scheduled within the same room. That's my like thought
Okay,
process.
wait.
In case there's something
Let me
I'm
backtrack here. So we're at 15, right?
right.
So I need to figure out. So what am I gonna do? I'm gonna look at the one right behind me to figure out if I need to introduce a new meeting room.
Right.
What if there's 5 and 16, right? So I look behind me. I know that I need to, or like 10. So
Okay, 10 and 16.
yeah. So I
Okay.
know, yeah, like, I look back on here? It's like, do I need a new meeting room? I can't take this one, but I don't really need a new meeting room to introduce a new meeting room because this meeting room is going to be empty.
This would certainly be emptied, but if we look at this condition, like 5 to 10 would be the slot for this meeting, and then 10 to 16 would be accommodated for this, right?
Okay,
So
let's do
these
this
two
then.
meetings could be
Six.
in the same.
So now we
Okay.
have three meeting rooms, and then um, if we run your algorithm, you're gonna produce four.
Okay, let me check. Since 30 is less than 5, yeah, we would need 2 here. Since 30 is greater than 5, 10 is greater than 6, and 16 is greater than 15. Okay, but we can certainly accommodate these two in the same meeting. Oops.
Exactly.
That's what you are saying, right?
Exactly.
Then the answer would be 3, but according to my algorithm, it's 4, which is wrong. Okay.
Yeah. Exactly.
If 5 to 10, then we have 6 to 16, and then 15 to 20. Okay. So I think I would need a data structure to store these meetings, and then I can evacuate the room in case a meeting has ended. I'm correct.
Mm-hmm. Exactly.
So I could use a think. Let's see. Suppose I have first meeting room for this meeting, and then second meeting room for this meeting, and third meeting room for this meeting.
Yeah.
Okay.
Exactly.
Now, in case of fourth meeting room, I can check if there exists any meeting whose end time just like is just before the starting time of my current meeting, right?
Yeah.
And then I can evacuate that room, and then I could report the size of this data structure as the answer.
Yeah.
So, okay. So I'm thinking of using a set data structure right now.
Okay. What would be the runtime? Like how would you find that room? If you search through all the rooms, that would be lead to more of an O(n) squared solution, right?
Okay, let me think about that. So we are using a single pass for populating. Okay, so suppose we have this inside the room 0 to 35 to 10. Okay, I think it won't take uh, long if I use n times. Okay, 5 to 10, 6 to 16, and 15 to 20.
Like searching for a room to evacuate is gonna take O(n) time,
Yeah, that's
right?
what I
Like
am
you're gonna
thinking.
be looking
How
through.
can I
Can I
optimize the
evacuate
search?
this? Can I evacuate this? Can I evacuate this? If you can't, you need to
Yeah,
do something.
that's what I'm searching. Like, what could be used to optimize this? We
So
need an order of one lookup time so that
doesn't need to be
it's
O(n).
on.
It just should be just be what okay. In this data structure, what are you looking for? You're looking for
Any meeting which has a end time less than the start time of
okay.
my current meeting.
Okay. So which meeting would that be? Would it be so like if you're looking for one specific value, what value would that be? Like what meeting would has the highest chance of being smaller than your current time?
The one with the end time being so you were saying I can like store based on the end times of the meeting, right? Okay.
So okay, wait. I'll tell you this. Like so, we have this data structure, right? And it's telling us the end times of each of the rooms. We want to look for the end time that's smaller than our start time, right?
Yeah,
So,
totally.
so if we find the if we find the meeting room with the smallest end time, or yeah, with the smallest end time, like the earliest end time, that's probably gonna be the room to freeze up for. Like we're gonna look for the room to freeze up first, right? Because if that
Yeah.
room doesn't freeze up, if that room frees up, then we could use it. If that room doesn't free up before we have to start, then none of the rooms will free up, right? So how can we find the smallest end time in that data structure fast? Do you get what I mean there?
Yeah, I understood what you mean. You were saying based on the end times, and I was thinking about the start times.
Well, okay, we pretend we have a bunch of meeting rooms, right? We don't care when they started. We just care when they end.
Totally.
So if I just pretend I'm gonna go to a meeting room, I just need to know when is like what's the meeting room that's gonna end the earliest. That way I can try to go there. I don't want to wait for like one that ends after that or another one that ends after that because I'll be waiting too long. Like I'm just gonna look for
Makes sense.
what's the meeting room that ends the fastest or just ends the earliest, and I'll wait outside of that. Waiting if we think about it conceptually, right? So how would we kind of implement that?
Okay. So earlier I was thinking about merging based on the end times, which was somewhat correct, but it had wrong intuition. Okay, so I could use like something which makes this to the field. Okay, it sounds like sorted data structure such that the meeting with least end time is selected, and then no other meeting would be freed up, as you said, right?
Yeah. Well, I don't know
Would
what you mean,
be
but no other meet reading road free.
no. Uh this is like the crux of my thought process right
Yeah.
now.
Go ahead. Yeah.
Okay, so something like min heap or max heap. Okay, heap data structure. Okay, I think mean heap could be used so that we could place our meeting intervals based on the end times,
Heap
based on the
basic.
end times. Okay, okay, let's see what it does. Min heap to account for meeting with least end time. First, we sort based on the starting intervals. I think that's okay. Then we would push each sorted meeting into the min heap. Then it would account for the meeting with the least end time. Okay. And then I could check if my current meeting's start time is like is in range of is okay, more like is less than or equal to the top of the heap. Then I could be certain that I would need more meeting rooms. Okay, this is just my notes. I would just go through a dry run real quick.
Sure.
Let's get. So going through the dry run again. Should I go through with this example itself? Okay, let's go with this. So we have this sorted, and now we would start with iterations. We would first, our min heap would look like 0 to 30. And then in second iteration,
I
it would
think
look like
since we're
5 to
short
10
on
first,
time.
since the end time of
Sorry.
second meeting is less than the first.
Or I'm gonna say sorry, I was muted. Since we're short of time, just try implementing it. I think you have the crux of the problem. Let's just see if you can implement it.
Okay, okay. Uh, so just to be sure, like, is my thought process along the right lines now?
Yeah, yeah. Use a heap. The heap should be on by end time.
Okay, let's say
Yeah, go
we
ahead and
make,
implement it.
yes, sure, sure. Okay, we don't have that imported. Okay, let's see. Running through the example itself, and then 15 to 20. We have our data structure ready. And then we could make a function int solve, which would take in this array. Okay. And any constraints of the interval I forgot to ask. Excuse me.
Constraint. Sorry, I had to do something. No constraint. Just implement.
No constraints.
Yeah, no constraint.
Okay. 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 Just sorting the intervals based on their start time first.
Yeah, just keep implementing it. It's like just grabbing
Okay.
something.
Then I could make priority queue, which is the main heap in this case. Then it would store the vector, the interval for each of this data structure. Okay. Then I need to make sure this is like organized based on the end times. Okay. So I need to make sure. Okay. So the greater of the later parts should be used. Like, this simply means that we are arranging the main heap by based on the end times. Greater end simply means that. So we have this data structure right here. Okay. So we just begin by pushing the first interval of the interval set. Okay. Then I could iterate over the remaining intervals. And here I need to make sure that start time of current meeting, if less than the top of min heap, then we would need additional meeting rooms. Okay.
Yep.
So I could just check for the counterverse of this, like for the start of each meet is greater than or equal to the top. Okay, so the counterverse of this means that I won't need additional meeting rooms, so the meeting room could be freed up.
Mm-hmm.
Okay, so I can simply pop from the queue, pop from the min heap, I mean to say. Okay, then I need to push the current interval end time. Okay, so the end time of current interval. Okay. Okay, so we have this, and then After popping, whatever is the size of the data structure, as I said earlier, would be my answer, I believe. Okay, let me just. Okay, I have not invoked the function here.
The heap at the end.
Yes, please.
So you we're capturing just the min size heap at the very end.
Yeah. This would be like the size of the data structure after we have popped up all the intervals from the min heap, that from like those would be the rooms which could be freed up, and the remaining would be the number of rooms we would require.
Yeah, that makes sense. I'm just trying to think. Do we need to track it? Could we just return at the end, or do we need to track it while like during in here?
I think we could track it with a additional variable. We could keep a counter while popping and make sure. But according to this, I think this would make sure.
Nice. Yeah. Yeah. That makes sense. I was just trying. I didn't. I used for this one. I just tracked during the thing. Yeah, we're at
Okay,
50 minutes. How do you feel? How do you think you did?
uh, not good, man, not good.
Really?
I think I fumbled a bit. In the first question, I was totally like dodged. I have seen that threesome question. Uh, oh, I have not run it.
Yeah. I think you
Okay.
came up with a good threesome solution,
Uh,
but like,
I was thinking
yeah. Go
about
ahead.
tracking the absolute, more like difference between the closest sum and the target.
Yeah. Yeah.
Then we could track. In this question also, I think I was going through the wrong paths. Then you gave me a hint. Then I sort of started thinking along the right lines.
Yeah. Honestly, the what I would say here though is you did really good at talking about your solution. I understand it where you're going the whole time. Like I understand it where you're going, and I was able to give you good advice. Cause I wouldn't say you were necessarily going the wrong direction, but you you just required help to get to the final solution. But you're moving slightly in the right direction. I was kind of just like nudging you and guiding you a bit. So I think as like for a junior candidate, I think you're gonna be applying for junior roles because you're still in school. This is a perfectly fine interview, and I would probably pass you on to the next interview, or I might have not would have not asked you something. Some of these were kind of hard, right? So I think things you did really well. You clarified the question really well. You were able to come up with various approaches coming from brute force to like somewhat optimal, but couldn't get to the optimal, which is fine in this case for your level. I think you obviously wrote the code and it worked. You understood heaps. You understood like sets. I mean, there's a lot of positives that came out of it. Honestly, I don't. I think you did a pretty good job. I don't know if I would pass you or not. It would more depend on how did the other candidates do. But I think you would have done better than a lot of other candidates at your age and level. But yeah, that's kind of my feedback. I think yeah, just I think when you come up with the solution, right? Or when you come up with the brute force, which you did well, try to figure out what's the bottleneck and how do I optimize it. So
Yeah.
I think that's where you're stuck on. You came up with the brute force and you're like, what's the bottleneck? Oh, the bottleneck is I have this solution and I can't find the next meeting room that is open. And then when I gave you that advice to think about it, you thought about it and then you came up with a solution. But I think your approach is good. Come up with a if you can't think of the optimal algorithm right away, and most of the time you probably won't. Come up with a naive solution or a solution that definitely works, and then try to
Okay.
optimize it and see if it could optimize from there. How do you optimize it? Look for bottlenecks in the algorithm, and then try to solve it in the same way that we did it now. Even in the three sum questions, like how do we like kind of broke it down a bit better. But yeah, what do you think?
Hmm. Uh, yeah, I think that sounds about right. But I have noted a pattern in these problems that sometimes the optimal solution is like totally different from the naive solution. Like you have to think out of the box, and that's where I like kind of get stuck on.
Yeah. What? Why would you say you have to think out of the box for these ones?
Uh,
I guess so.
like for instance, like there are some problems in how do you like I was solving a linguist problem like last week or so.
Mm-hmm.
Then there was this problem like find the length of the cycle or something, and
Mm-hmm.
I was thinking like going through it once at a time, one time, like using a simple pointer and going through one at a time. But the solution, when I looked on tortoise and here and fast and slow pointers, I was like, how am I supposed to like think of these
Yeah.
during the interview?
Yeah.
Like, so it depends. If you have seen the problem, certainly
Yeah.
you would
It's
be able
huge.
to.
Yeah. That's why I can't get. That's why I still think you did really well. You, like you're. It's more that you just didn't see the question and you couldn't think of the solution. So the only way to solve this is by solving more questions and just exposing yourself to more questions because there's a
Yeah,
lot of questions
certainly.
like this. Like there's a lot of scheduling problems that involve a heap. I know a few.
Makes sense.
So so yeah, like just have that in mind. And yeah, the three sum closest one is a little bit weird. So that's why we kind of moved on, but I still think I got some signal from that. But yeah, other than that, thanks for taking the time out to interview it for this one.
Okay.
All right, catch you. Peace.
Thanks a lot, man.
No problem. Good luck. Okay, I'm gonna grab a real something from. Shit, did I even record that? Damn. Damn, I didn't even record that. Oh shoot. Oh no, I did record that. I'm gonna. When does big tech start? You should start applying for big tech. Probably expect stuff. Probably August, September, even as early as July. Okay, I'm gonna quickly grab like a coffee or some food. Enjoy. We're gonna do a replay of John debating or the vibe coding debate. I'll be back in like 10 minutes. So we got a
We're building
vibe.
the future.
Somebody came through. A vibe coder came through to defend all vibe coder. I think you said, "Let me get on here. I need to defend all vibe. Let me defend the vibe coders and the AI spammers." That's exactly what you said. I'm gonna pin this. So
Yeah.
okay, and chat, keep me honest because my our whole chat read this paper. So we're just gonna quickly describe what the paper is in less than 5 minutes, and we're gonna get into a very um, like we're just gonna talk about it. And John, and we're gonna see his take on it. He's a vibe coder traditionally. He's somebody who was born,
Yeah.
whose
Show.
software engineering career was born in the age of AI. So he just from inception, he was pumping out AI code like asking GPT. Versus I'm more traditional and I started with pen and paper and moved up to using AI tools. That's kind of my journey. But
Yeah.
okay, John, this thing is saying your brain on ChatGPT, an accumulation of cognitive debt when using an AI assistant for essay writing tasks. So I know people will probably get sick of this, but I'm gonna explain in less than 5 minutes. There was three groups in this study. There was this group that had an LLM, a group that only had a search engine, and then a group that had brain only tools. And John, fix your camera. You went sideways.
In my bed. I'm just checking if I have a meeting. I'm at work.
Okay,
I had
so
to get on this. I'm triggered right now.
they had three groups of people. Turn on your camera, bro.
Yeah.
The LLM group, the search engine, and brain group only. Basically, they made these groups perform a specific task, and they noticed that the group with the using the LLM, their brain activity and their like the amount their basically their brain activity was way less than the people using their brain only, and that's kind of obvious. But what they also said is when they had two groups, they had a group go from brain only to start using an LLM, and then a group using an LLM to going back to just using a brain, or sorry, yeah, the people using an LLM go to use their brain, and then the other way around, people going from brain to using LLM, and they noticed the people who is using LLM and then they moved to only using their brain was still not using their brain the same way as people who went from brain to using LLM. So basically, they're saying that this is this could be an issue, that not using your brain when like performing tasks, and they're just raising concerns about the long-term educational implications of LLM reliance, and like basically what its role should be in learning like AI. Okay, any thoughts?
My thoughts on this is how are they using the large language model and what problem are they solving, right? So let's say they're solving a really easy task. Of course, if the task is really easy, they're going the person that's using the large language model versus the person that's not will obviously use less brain power to solve the same problem.
Mm-hmm.
It's just that simple, right? Imagine you're taking a test, a math test with a calculator or without a calculator. Of course, the person with the tool is going to be solving the problems with less effort, right? But that's not what humanity is about. Humanity is not about solving problems that are easy. We're about solving problems that are hard, that push our limits with regards to our performance. And right now, honestly, like there's some problems in the world, like for example, cancer, that can't be solved with just human tools. Like humans have been working at this problem for a long time. If we empower those same humans with cutting edge tools, and they apply the same amount of effort and energy to solve the problem of cancer, don't you think that with the tool, they can solve that problem even quicker?
No, like this. Okay, okay, yeah, okay. Paul's saying CFA. Like the point in the paper is not about is AI gonna advance the humans. It's more about are they gonna hinder the learning of people and make people dumber over time, and that might
I don't
affect
think
us.
it. I don't think it will. It depends on the reward function of it. It depends on what the human specifically is trying to achieve when using AI. So let's say you're facing a problem of let's say your reward function at university is getting the highest GPA possible. Of course, when you use large language models to that end, you're going to be using less brain power. But what if your reward function in university is actually to be as smart as possible during your time in university? When you use large language models for that end, you will literally be using the tool to learn, and you will learn even faster than somebody that's using traditional methods like going to like a lecture, right? Like here's an example. When you are a first year university student in a weeder course, there's 300 students in there with you. Could you ask, could you increase or decrease the level of the lecture to your knowledge base? You can't. There's 300 other people with you, 299 other people with you. When you're directly using an AI to learn, you can literally increase or decrease the complexity of the concept that you're learning to your level of understanding, and that will help you learn faster. Like traditional methods don't allow this.
Yeah. No,
Do you understand what I'm trying to say here with the reward function? Like obviously, like most humans, and it's an obvious fact. Like most people, literally, their reward function is not getting better. Like especially in university. Like once somebody hits a 4.0 GPA, do you think that they're trying to max out their education even more? Or like those I don't know. That's my opinion. Like
okay, so what determines our reward function though? That said,
yourself, you're a human. Yourself. You have to decide. That's the power of being human. You literally have to you say, Nat, what are my values? My value is like friends, family, profit. Okay, those are my three things that I love about this world. Okay, my reward function is that. Don't let some other random person tell you what your reward function is that doesn't even care about you.
okay. Patrick expand okay. Will LMs help us change oh okay, so but like right now, what you're saying is like a lot of how school is structured for learning is based on that sort of reward function of okay, you have it, we're gonna give you tests, we're gonna make you write this essay, for example, then we're gonna judge that you created that essay correctly and that you like built a good essay, and that's kind of how they test it. So
Yeah, yeah.
like pretend
Like,
so what are you saying?
okay, so
Wait, okay, let
I
me ask you this:
I
is should kids be using an AI? Like what
of
age?
course, 100% at literally age 0. Okay, so imagine if I had AI at 5 years old and I didn't know how to answer math, right? Like okay, James, you and I, right? Where were our parents when we were 8, 9, 10, 11, 12? Dude, our dad was working hard. Our mom was working hard. Could they afford a tutor still? No. For 3 kids, no. They can't even be there to babysit us watching doing our homework. Imagine if you have an AI doing that, teaching us as a
Yeah.
kid.
Okay, but you're
Obviously, we're
thinking
gonna
you're
dominate.
yeah, I see. I know. You're like obviously like the AI is there and you build this technology and people are going to use that technology in the weirdest ways and different ways that you're possible, right? Like people are using this AI literally to offload their thinking. That's kind of what this study is saying because they're giving these okay, they give did this I didn't read the full paper, but they're telling these people to write an essay, right? So you're saying if your goal is to write a good essay, there's two ways you can go about it. It's the same way as you want to write a good software. There's two ways you can go about it. You could just use the
Yeah.
AI to generate your whole essay for you, or you can use
Okay.
the essay, or you can use the AI to help you figure out how to build the right essay and then go from there. Like kind of like using that like it all depends on how you use the AI. And then like what Paul is mentioning, it's people are humans are just naturally lazy, and humans are
Yeah.
gonna just do the thing that's easiest, which is
Sure.
just like you could use the AI to be your personal tutor and teach you, or you could just use AI to just finish that essay for you just there and then. You don't have to worry about it. You can go play Call of Duty Modern Warfare.
Yeah. Yeah. I think you'd be surprised. I think you'd be surprised. Like in competitive field, in competitive places, maybe because most of your people are from North America, right? Like you live really easy lives. In China, you don't like those people are working 24/7 with AI. And then we wonder why a company like DeepSeek can like release a model on par with ChatGPT for $6 million. Like like people are just surprised about this.
CFA tried to not to mention China challenge. Yeah,
right?
but like,
And honestly, like if like at the end of the day, oh man, Paul, the deep number, dude, I can literally build an AI that replaces an equity research analyst, and I did it in like 6 months. And those guys get paid like $200,000. John, did those kids in China choose that for themselves, or did society nurture that mindset? Honestly, like the way that I think about it is, let's say you have like a population and they all have AI. Do you think like right now the distribution will change? Like, do you think the percentage of lazy people with AI is the same as a same percentage of like a society with AI? Do you get that question? Like before AI, are there more lazy people as a percentage of the population? I don't think so. The distribution is always going to be the same. And the people that don't use that use AI are just gonna like be better. I don't know what to say about that.
I don't like, but they're just what this paper is saying that it limits people's learning. So they didn't tell people how to use the AI. They just made people. They just gave a group of people using AI, and then people not using
Yeah,
AI. And then this is
yeah,
the outcome of this, like objectively, was that the person using the LLM was not using, like, there was less cognitive load and less, like, they use the EEG to track literally brain
yeah,
activity, and there's less brain activity. And then when
yeah,
they made that person working on the LLM switch to actually working on, like, just using their brain, like, it still wasn't working well for them, and they had like lower recall and stuff like that. What else? They underperformed on
yeah.
other things. So that's kind of like they
Yeah.
just did an objective study. I think this is going to be important moving into the
Maybe
future.
maybe the sample size is too small and large language like the users don't actually know how to use large language models. Like I think I think you have this perception that like anybody could vibe code. Anybody could use AI to write an essay. Have you ever seen like an equity research report from somebody that just used the Chat GPT UI? It's trash. It's literal garbage. Versus somebody who actually knows how to use like the large language model at like the really at the fundamental level, like calling the API, controlling everything about at like a lower level function. It's not the same. It's really not the same. And definitely like when I first started using ChatGPT and like using AI heavily, I thought about like, hey, anybody could do this. But then as you get better at using AI and Cursor and all those tools, you realize that like over time you can be a better prompt engineer. You can be a better fine tuner. You can be better at retrieval augmented generation. The base models aren't just the base models. You could actually make them even better than what they are.
That Yeah, that makes sense. Let's
Right?
take a
It's like saying a human without a car can get to from point A to point B. Okay, a human with a car can also get to point A to point B.
Okay, but
And
okay, what they're talking about is like most people aren't writing equity research reports. This is like super scoped. So yeah, like I think we need to think about it in a more general sense. Like writing equity research reports, pumping out good code is not the only thing that humans need to
yeah,
be doing, right?
yeah,
Like
yeah,
using their brain and learning how to write an essay, they're learning how to like they're learning grammar, they're learning how to structure sentences, they're learning how to tell a story. These are things that they learn, and when they go to interact with people in the real world, they need to use, because at the end they were humans and we need to be talking to each other. So if
yeah,
as humans it takes away from some of those like things, how will that affect
yeah,
us?
yeah. So is the question like, since AI is abstracting away a lot of the way, like a lot of the things that we do now as humans, will we get dumber as a result?
Yeah, that's one thing. It's like our population gonna
Okay,
become dumber?
all right. Okay. Largely the stuff that we used to do as humans, like like we used to be hunter gatherers. Hunting, gathering, building a home, um, those have all been abstracted from us. And because of that, we can really apply a lot of our knowledge to like doing things like things like building AI. Isn't that like did we get dumber from that? Abstracting things in the past? I don't like as
Well,
a
okay,
race, like
okay.
we've literally evolved.
Well, what made the human species more like powerful and survive better than other humans? Right? It's our isn't
Ability
our
to
brain.
adapt.
Isn't it our brain?
Yes.
Like we are the smartest species, and that's why,
Yeah.
right? That's they even had different humans. Like basically that's what I read online. They're saying this is why humans are we are today compared to other animals is because our brain, right?
Yeah.
So
Like
we
if our brains are so good, wouldn't we use like AI to make ourselves even better?
it depends. Like the like the brain is the muscle at the end of the day, right? You need to train that muscle. You need to use that muscle in order to keep it good. Like it's still a muscle. You know that if you keep training your brain, you have a more powerful brain. There's other studies on that. I don't know the exact scientific terms, but um, pretend that like what people are worried about is that this AI is taking away from us actually having to use our brain, and if we as a human species do not use our brain properly or do not are not like using our brain to the best of abilities, like
Yeah.
what will that do for us?
Yeah. Honestly, we'll be solving harder questions at a younger age. So like, okay, right now you could just use AI to write an essay when you're 18. Do you think a 5-year-old could write an essay at 18 with AI? Just
Okay, yeah,
just
yeah, no,
make
no,
the
Paul,
bar
Paul
the
makes it.
make the bar even
This is
less.
something like I mentioned, like yeah, abstracting things that you mentioned, like the hunter gatherer stuff. It did make us weaker on a physical sense. Like there's even stuff on our body that used to be there because of us of like before, like wisdom teeth, for example, right? And like certain things about the human
Yeah.
body that are no longer needed, and they could just straight like take them out. It's not needed no more. It's like because we weren't using it. Imagine to the point that this thing is so good it could think for us. We don't need to use our brain, and that like the brain is no longer the
Yeah.
most like no longer
Yeah.
needed essentially. Think about that.
Yeah. Like what I don't understand. Like when people use AI, I just have a hard time like grasping the concept of just because I have a tool, it means I think less. Like literally, because I'm still gonna apply 100% of my time. Like
Yo, okay,
I'm
okay, John. Let
gonna
me say this.
I'm
Like you're thinking about it in like a psychological and like psychological sense. Like I can't grasp it, but let's think about it in like the most scientifical way possible. How do we check that? That's what they're doing. Like they're not just they're trying to actually measure what you're saying here, and by they're measuring that by actually making them do a specific task, measuring their brain activity. Like they're trying to quantify it. You're doing it more like qualitative, like how are they not using it? Like, but isn't that something we can quantitatively measure?
can't you improve can't you change the way you measure things?
What do you mean?
So like in this specific report or like the specific study, two like they okay, maybe I'm just hitting a block here, but the test somehow shows that two subjects, one with AI thinks less than the other person to solve the same problem.
Yeah.
Is that right?
Is thinking less. Yeah.
To solve the exact same problem.
Yeah. Chat, and just say like if that. Let the chat answer real quick, cause they were reading it while I was on this thing the whole time. Yo, Sidar, I got you right after this. 5 more minutes. 5 more minutes.
Oh
Unless it's
man.
late for you. We're having a juicy convo right now.
Like the situation should be, okay, two subjects have the same limit on time and energy to solve as many problems or the hardest problems possible. Who solves more? The human without AI or the human with AI? And
Okay,
I think like 99% of the time it's the human with AI.
okay, let's talk. Let's read a couple bullet points here, and we're reading a This paper is 207 pages out of context, so I'm literally reading stuff completely out of context. I'm reading two paragraphs out of a 207-page thing. So like, MIT, don't be mad, but basically, I think I'm in the conclusion, or I'm somewhere. It says early AI reliance may result in shadow encoding. So LLMs groups poor recall and incorrect coding is a possible indicator that the earlier essays were not internally integrated. So that means they have trouble actually internalizing it. So you generated all this. Let's take it to the equity research or coding. You generate this equity aid research, but you're kind of regurgitating, or you're not really internalizing. You don't understand what it generated. You kind of just shot it out. All right.
Okay.
Another thing, withholding LLM tools during early stages might support memory formation. Brain brain only groups stronger behavioral recall supported by more robust EEG connectivity suggests that initial unaided effort promoted durable memory traces, enabling more effective reactivation even when LLMs were introduced later.
Yeah.
So what they're just trying to do is I think they're just trying to see the Paul saying is kind of dumb.
Like they're just so they're saying early AI reliability can result in shallow encoding. And if your reward function is learning, you are going to adapt. You're gonna realize like, hey, over time I'm using AI, I'm not learning. Like for example, me personally, right? Like, okay, when I used AI to literally learn how to write Python. Like right now, like would you say I could code Python?
Yeah,
I would say I can,
yeah,
right? Obviously, like I got to a stage where I could literally develop scripts without knowing some certain things. And then when I realize that I don't know that certain thing, I'm just gonna use large language models to learn that certain thing.
yeah,
Like
yeah.
like I'm not the type of person that just like literally doesn't grow over
Okay,
time.
I
Like
see.
I'm gonna identify gaps because I'm using a tool, and then I'm gonna use that tool to fill those gaps.
Yeah,
It's like imagine if you're vibe coding a website, right? Okay, once you get the feature out, do you stop there once like let's say you have two people, one's a vibe coder and one's not. The one that's not will get to a solution maybe 3x the time of a person that's vibe coding, right? Like to get a feature out, a non-vibe coder would take 3 hours, a vibe coder would take one.
yeah,
And this is like empirically something that you see in real life. People honestly say like I do something in an hour that would have taken me three. Okay, that person that that made the feature in 1 hour can now spend 2 hours doing unit tests on their 1 hour of code, like on the feature that they made. Who do you think will have the more reliable code when it goes into prod, given the same time constraints of 3 hours? I would trust the person that vibe coded 1 hour and spend 2 hours testing their vibe coded
okay,
work
but
versus
how would you test it if you don't understand what's going on? By just keep
Okay, yeah, that
reprompting it.
I mean, at that point you have to know like how to unit test. But what I'm saying is like they both have the same level of skill.
Yeah.
And one just has a tool, that person will the person with the tool will naturally just like produce better code. Like let's say they have like the same time,
Okay, but
the
at
same
some
amount of
you're saying
energy, the same amount of skill.
at some point you need to
Like,
use your
oh,
brain. What if you don't like you did at some
you
point
are
you
using
need
your brain. You are using your brain. Like when you're prompt engineering, you're just mindlessly telling the AI, "Hey, unit test this." Oh, the unit, like how, like you need to have some level of taste and some level of understanding to identify like whether or not the unit test or the feature that the AI made is actually good. Like I don't know about vibe coding where you're just not even looking at the code.
That's what vibe coding is,
Like
isn't it? You
no,
just
it's
spam
not.
the AI
It's
to
not.
generate.
It's that's not it. That like people who produce that, people, okay, like do you remember when you were making thumbnails with AI? Every single thumbnail looked the exact same.
Mm,
Do you realize that? Did you notice that?
yeah.
Okay, when you look at my website, do you think that it's AI generated? It's freaking doesn't look like any other website that exists.
Because you didn't use
It's
AI
like
for your front end, didn't you?
I did use AI. It's just I literally I have human. I also applied knowledge. Like I literally I didn't just mindlessly prompt the AI, hey, like make this better, make this better. Like that's super. That's not what vibe coding is. There's like levels to vibe coding, and I think people just like look at it from the inside looking in, thinking that it's easy. Of course, it's easy to get like a simple app. It's one like imagine vibe coding a 1 million a 1 million line code base. You literally need to be good at vibe coding to do that.
Yeah, but then now you're like taking the vibe coding way out of context. Like
No, vibe, but
you're no
like
longer
what?
vibe coding when you're doing all this manual stuff when you're not using
Okay,
the
then I
AI.
can't. Then all
Then you're
right,
not
then
a
I can't
vibe.
identify. But I can identify as a software engineer at this point. Then
Yeah, you can probably identify as a software engineer at this point.
that but I don't
Bro,
even know what to say. Like it's so hard. It's so hard to like I
okay.
don't even know. Maybe my definition of vibe coding and using AI to like write essays is completely different than like what most people do,
I guess you can
right?
vibe. I guess you're still vibe.
Like I mean I feel like I am still a vibe coder, but maybe I'm just like looking down on like
Like
I
how
think
many
vibe
times
coding
did
is a
you
derogatory
how
term.
many times did you like actually just go into the code and make changes for yourself and try to read documentation to understand what's going on there? Like how many times in your day?
Um
Like out of like does that happen at least
like
more than 10 times in a day or no?
yeah, it
Exactly.
happens a lot.
This guy
Like it happens a lot when when you
like you
look
were
at my but like okay, but 90% of my code base wasn't written by me typing into the text editor.
what? Say it again.
Like 90% of my code base isn't me writing into a text editor. It's me interfacing with the AI chat, which the AI chat writes in my text editor. I read the text editor, and then I revert or accept what's in the text editor. I still look at the code. And even like when you prompt engineer, like the stuff that I'm working on right now, like
You're never just like going in the code editor just like typing, going ham. Okay. Okay, yeah,
hell
you're
no,
still
you
vibe coding
can't.
that.
Like even right now, like when okay, ask ChatGPT, ask Gemini, ask anything about model context protocol. It literally doesn't understand like how to even deploy that. You literally need to read the docs yourself and prompt the AI UI AI agent like Windsurf or Cursor to like you literally need to prompt the AI with knowing the code base. You can't just like build it. Oh man, get France on the
Yeah,
call.
it's all
Let's
good.
see the website he built.
All right, okay, I have to hop
Let's
on to
see
the
like
next coding
oh man.
interview, but I know you're at work. We talked for 30 minutes. Go work your job and
Yeah, yeah.
be
No,
productive.
man.
All right,
I'm gonna bounce from this
okay,
too
catch you,
with the
bro.
help of AI. Okay, peace.
This guy's attacking the chat. Oh shit, I was muted. That's so funny. Okay, we're back. We're back. We got more. We got. Oh shit! Someone had to dip. Oh, someone had to reschedule. It's okay. I can work on my website. Who's in here? John, Paul, you want to talk about it now? Let's see. John, you got time at work? We can all hop on the Discord. Oh no. Paul's parents is leaving. Is it? I'm just gonna work on the code then. Somebody flopped out. Oh wait, let's see. Yo, my main problem is I didn't even read that that paper properly. So I'm just gonna look so stupid talking about it. But we did read the we did read the TLDR. No one's gonna just read that whole paper, bro. That's just crazy. Okay, let's work on my authentication, cause this part is important too. I've struggled with data structures, failed it twice. Any good resources you recommend to self-learn? Any good resources? My whole channel is dedicated to sharing this stuff. If you want to learn, if you want to understand how I would do it, I have a series on that. I'll share it here. Check this out. So we're gonna work on authentication. So let's just read this. Yo, any good leak code questions that y'all saw recently that I should try? Actually, what I'm gonna try. We're gonna do one of these assessments live. That's what I'll do. I'll try the Uber one out. Give me a second. I'm just gonna grab something. Hey, I'm from India, going to start my BTech in CSC core in less than 2 months. Any suggestions for what to learn beforehand? I'm kind of intermediate in Python as I learned in my 11th and 12th standard. The one thing, honestly, what I would do is just look at the first year courses and try to get ahead on them by just reading a little bit. But when you go into university and you learned how to code before, the first thing that my professor told me when I first got into university was, if you already knew how to code, throw all that out the window. You need to come to your university and throw everything out the window and learn from the basics and learn from scratch. Learn everything brand new and treat it that way. You don't want to let your old like habits and biases and stuff carry into university, because they might have been wrong as well. Like the university just, it might be it yeah, like when you self teach yourself, you'll learn different things. So yeah, just keep an open mind essentially. I got my first internship this summer and I'm a rising junior. Am I cooked? Why would you be cooked? You just got an internship. You're set, bro. Okay. Let's knock out this interview. Where's this one? What should one do with no experience? Well, if you don't have experience, you should try to get experience, and there's multiple ways to do that. One way is to just get a job, one way is to do research, one way is to work on your own projects and create your own experience. Actually, let me work on my auth. So Next.Auth is a complete open source Next.js application designed from the ground up to support Next.js and serverless. Check out the example above to see how it is used in the Next.Auth for authentication. John, you're going to be using authentication yours too. Designed for flexible built-in support for many popular sign-in services. Supports email, passwordless. Call my friend. I'm gonna call my friend who took a neuroscience degree. I want to talk to him about AI. He also has a software engineering background, so. Yo, wake your ass up. Why are you still sleeping? That's crazy. Yo. Oh, what? There's work today for you? There's no way. No way. No way. That's insane. What the hell? Why is there no day off for you? It's off for literally everyone else. That's so funny. What? Oh yeah. That's insane. I was gonna say come over and talk about AGI. Like they keep moving this term. So ASI. I was like, I want you to come and talk about the term when you first told me back in 2018 and like the very raw primitive form of AGI that we were talking about before. Because right now it's getting so annoying that they keep moving the goalpost. So like what? Yeah. Okay. Yeah. Come over. I'm free. So what we're gonna do is we're just gonna talk about AI. Remember how you described it to me before? It's like we have a specific AI that could do good at one thing, and then it's slowly expanding, and then the general intelligence, like Spiel and how the doom and gloom, and also how maybe it can make us prosperous. That stuff. We should talk about it. Damn, that's crazy. They got you working. I'm actually so surprised. Yeah, stock market is closed. That is crazy. That's so funny, bro. That's what he said? Good. That's crazy. He said that himself? That's toxic. That is toxic. Okay, man. What time are you off work? Okay, but yeah. Okay, catch you, bro. Let me know. I have like coding interviews up until like. Well, I have a free slot at 6. Perfect. Okay. I'm gonna book it in. Yo. I'm gonna send you the calendar link. Actually, I'll just book it off 6. One sec. Yeah, 6 is good. Okay. Peace. Yo, this guy's so funny. This guy had work on a federal holiday. Is that criminal or what? I literally thought this guy was just sleeping. Yo, chat, who's in here? Oh, shit. You had work too? That's crazy. Supports stateless authentication with any backend. Supports JSON web tokens and database sessions. Designed for serverless but runs anywhere. I like it serverless because my thing is serverless right now. My whole setup. Nat's still in here. Patrick. Yo, Patrick's still. Nat and Patrick is still in here too. Why are you... Yo, what's up? You're stuck on Nextauth? My Nextauth is working. Let me just log in. My Nextauth is working. Let me just log in. I just need to start protecting some routes. I'll show you. what is next auth? It's just how you authenticate with the website right here. So, or just it handles authentication. It handles authentication. I think it does it using a JWT. With this. I think it does it with a JWT. So you can see it sends a cookie. I think the cookie has a token, and the token is encrypted. I think, how do I grab it on this? I want to grab it on my side. So we have this page. Where's my auth login? Oh no, API auth. So what is this doing? It has a session, it has the pages, it has the providers, it has the session. Let's see. This is callback whenever a session is checked, like when you use session or get server session. Cyclops, what's up, man? Nice to see you. I'm just working on my website. I'm building more of the authentication features. So what I'm gonna do is I need to protect certain pages, and also protect some of my backend routes. What is the session? It's just returning the session as is without any modifications. You could use this to add custom data to a session, transform user data. Okay. JWT callback. This callback is called whenever JWT is created. Yo, thanks. It's coming together. Yeah, next auth does auth for pages too. So for example, I have this analytics route that should only be limited, but right now if I log out, it should be, I'll show you, I'm gonna limit it, but if I go analytics, I can get to it. Right, that's the problem. If the user condition is only true when the user first signed in. So what does this JWT do? User. Token.userid return token. When the user signs in, JWT callback returns the user object, adds the ID token on subsequent request. JWT callback runs without just returns token. When session is accessed, session callback runs, returns session, which includes the token data. Okay, let's just console.log the session and see what we get out of the session. Okay, in the session, we get the name, the email, and the image. That's good. Oh, it's basically the JWT. And do we get the same thing? Okay, it returns the user. So I guess here we could kind of inject a role too. let's say, because I want to introduce like role-based access control as well. So if we have the role here, I think this is only on the server side, or I mean we could like we can grab it from the session. Okay. What if we introduce something random like session dot user dot or a role here, right? We'll give everyone the role of admin, but soon this might be like a database call or something, or maybe from here, or let's go like this. Maybe in the JWT we can inject it. So we do token dot role equals admin. And now when we destructure the session, we should get the token. Or we should get the role. Oh shoot, I need to log in and log out. User. What? Dude, where's my... I mean, obviously this is gonna work at this point. Let's see. What's complaining about? Okay. We do use session, right? We do a use session. Okay, what we're gonna do is with the analytics route. Okay, there's difference between use session and use server session though. Okay. You can use the session callback to customize the session object if you need additional data in the session object. Okay. Yeah, that's what I'm doing. I'm adding extra stuff. The session object is not persisted server side, even when using database sessions. Only data such as the session token, the user, and the okay. Alpha, this is stuff that I know we're always talking about authentication. You can use the access token return for the session as a key. Okay. What if I'm using JWT? Can I encode it in the JWT and then I just decode it? Isn't that what the JWT there is for? Whatever. I'll just go by like email and image there. Okay, how do I use it? What is it talking about? Next API exposes a REST API that is used by the Next.js client. Display the built-in unbranded sign-in page. Okay. Okay. Okay, use session. Use session's React hook in the Next.js client is the easiest way to check if someone is signed in. Okay, I'm already doing that. What about in the server side? Okay, this is the interesting part. Why is there a client API in the REST API portion? So the next Auth.js client library makes it easy to interact with sessions. So the first one, use session. Client side, yes. Server side, no. The use session React hook in Next is the easiest way to check if someone is signed in. Make sure that you have that session provider is added to the pages. Yeah, we just have to do a session provider and then we can call use session. What it means by that is, let me delete some of this stuff. Where are we? Yeah, we have the auth provider. And then from there, I think we just have to wrap our page right here, or our layout, with the auth provider, and then all of a sudden all the children could just have access to this hook. Data, this can be 3 values, session, undefined, or no. When the session, okay. So due to the way Next.js handles server-side props and get initial props, every protected page load has to make a server-side request. To check if the session is valid and then generate the requested page. This increases server load. And if you are good with making requests from the client, there's an alternative. You can use a use session in a way that makes sure you always have a valid session. If after loading the initial state there is no session found, you can define the appropriate action to respond. The default behavior is to redirect the user to the sign-in page, from where after successful login they will be sent to the page they started on. And you could define an unauthenticated callback. Okay. So use session required true. What is it? There's so much random stuff. Due to the way Next.js handles get server-side props, get initial, every protected page has to make a server. Bro, I read that. Okay. Assuming a basic strategy JWT. Get session. Client side, yes. Server side, no. Browser gets which should be called client side only to return the current active session. On the server side, it's still available to use. However, we recommend using get server session going forward. The idea behind this is to avoid an additional fetch call on the server side. When this helper is useful in the case when you read the session outside of the context of React. Okay, so this is helpful in our API functions. Let's go here. Or get session. So this is how we can sort of Protect our API routes. What route is this? Videos. Tweak. Yo, no. What? I have a session there. What is it talking about? How do you not have a session? Interesting. How did I not have a token? Securing API. Get. Oh, they're saying get server session. Get server session. Okay, and then you pass the request. Why do you need to pass the response? This is weird. What? Is this deprecated? Oh, because we're not using sessions, we're using the JWT. So get token. Oh, wait. Yo, Cyclops, what's the information overload here? Oops, issue. Is not a function. Dude, it's like lying too. Oh shoot, it's just next off. Wait. Bad import, bad import. Okay, get token. What's the params? What? Oh, I have to go like request. Let's go like this. Update that. Update that. Delete this. Delete this. Delete this. Cyclops, are you the one from New Jersey again? Request. Yes, sir. Dude, see, I'm remembering. It's hard though, because I get so much people on here, but I remember pretty well. How is this null? What? How's that null? Decryption failed. Oh, so I guess it's right here. Okay, maybe I'm just not specifying my codes properly. Yo, what's up? What's up? Thanks for joining in. How you doing today? Okay, I'm not the JW. I'm gonna be implementing a bunch of different features on my website related to, like, I want people, like, I'm like, one of my friends is gonna be helping me build thumbnails and stuff. So I want him to, like, use my website, and it's just more practice, honestly. It's literally just for fun. Like, like, authentication is important. I just need to make sure I have it on my website, and after that, you can add, like, roles and stuff, and you can just build out the thing even further. Thank you, man. Appreciate you. Hope you have a great day as well. No, this shouldn't take that long, but we'll see. Harold, where are you based? Any tips for the process? Rippling away? What are they gonna ask? Wait, give me a second. Boston? I would just say, if it's front end, focus on learning, like, the React fundamentals. Let's see. I don't really work there, so I can probably give advice. So give me a sec. Let me just populate this end variable. Let me log out. Log in. Nice. I decoded the user. How am I always communicating and replying? The YouTube app is good. The YouTube app tells me exactly who I haven't responded to, and I try to respond. And not all my 109K is active, but a good, like, probably 1,000 of them are really active. Like, people just be messaging me stuff all the time. Honestly, a lot of my user base is actually from India. I have 40,000 subscribers from India. But I have like 20 something thousand people from the US. And I've been approached a couple of times in real life, which is funny. I don't know, I didn't look at the stats for other countries, but US and India are my biggest subscriber base. I got subscribers in O Block, I hope. Let me check. So what I'm doing is, let's just do something super simple right now. We'll just define the roles of everybody else. We're gonna do this. We're gonna be like, no, I don't think they'll ask you leak code for front end online assessment. I think they're gonna ask just understand React. So in the front end interview, understand React, and what that means is build a simple React component, introduce state in it, understand how rendering works, understand like the ordering of the renders, because sometimes the first render your thing might just bug out because you don't realize that all of your hooks run first, and then you render. Or dude, I'm kind of rusty, but they're gonna be testing your simple knowledge like that, and then you also just need to. I think the biggest thing people don't really understand is how to use state and how state works. That's the biggest. A lot of people know it, but then that's where most people mess up. So simple things of using state, and what I mean is some people actually straight up just use a variable inside of their code. When you pretend you tell them to use a counter to build a counter, then they'll add like const integer equal 1 or something like that instead of using state, and then they don't understand how the state kind of works. Different things like that can easily like suss out if someone's good at React or not. But yo, I decoded the session here. So I'll say do you have any knowledge on entry-level ML AI for new grads, or is it better to spend time on getting my foot in SWE? It depends. Honestly, a lot of SWEs, if you look at a bunch of machine learning teams, what I notice is a bunch of the machine learning teams or the teams working in AI, like 80% have just a traditional SWE background, and only a couple are just straight ML, traditional sense of only knowing machine learning and diving deep into that modeling area. What I learned is pretty much that's the goal. Yeah, exactly. Like I talked to, if you look at, I know a bunch of people who are working in machine learning that were just software engineers a few years ago, and now they're machine learning engineers, but they're trained as SWE, but they picked up on that stuff because they have a technical background. I would say learn software, but also take a little bit of machine learning classes. Understand like optimization and different things like that. Understand the different statistical methods. Nice. Don't they mostly? Yeah, I'm not selling no course. Well, that's because I have a job that I make money off of, so I don't need to worry about selling a course. I literally could just focus on. Yeah. If I ever, what I tell my friends is like, if you ever see me selling a course or a crypto course, just know that I'm really close to bankruptcy. And yeah, I appreciate it. Thanks. Like I hop into this because I just like to share my experience, and it's easy to share. It's easy to just keep talking, and I'll be transparent and stuff. The only thing is now that I'm working at a bigger company, it's kind of like more things I have to worry about. When I was working at smaller startups, I could literally just say whatever comes out of my mouth. But when I decide to switch out and start working on my own company, I'll be letting loose. What tips would you give if it was a back end role instead? I would say if you're focused on a back end role, just look at what back end engineers. What was Harold's question? What was Harold's question? Like what to study for back end interview? I think the most fundamental thing for a back end interview is, do you understand REST APIs and APIs, and then I think a lot of that is foundational, because when you're building a backend system, 90% of the time you're building a REST API. or some sort of API. So I think understanding APIs is fundamental in order to do well in a back-end position or a back-end role in a back-end interview. And a lot of the times they're going to be testing you on your knowledge. Do you understand HTTP? Do you understand the different verbs, the REST verbs like get, post, put, right? Do you understand the theory behind it? As in, you shouldn't be writing to a database in a GET request, even though you can technically do whatever you want, but that's not following REST principles. Patrick, what's up, man? Nice to see you back again. Dude, Patrick, we need to get you on here. Dude, Patrick, when I come back, we're just going to have so much philosophical talks. I think I turned the corner when it comes to philosophy, and I'm starting to like it a lot more. So I need you to just tell me what to read, and we could start discussing it. Patrick, bro, can just turn the corner. Cause, Patrick, I literally have like 7 mock interviews that I'm gonna be running in the next like 30 minutes. But then at 6 we're gonna be we have somebody coming on. But what's it called? What I was thinking, Patrick, this is what in chat. This is what I was thinking about recently. Is that I was just watching videos on sort of the Renaissance times and how people really came up with new crazy ideas during the Renaissance time. And I was trying to think about if we're in the same situation now. And I honestly feel like we're not. We're more in sort of like an industrial revolution phase where everyone just focusing on optimizing certain processes and just like working on optimizing, driving efficiencies, etc. That's sort of like what happened in industrial revolution. Like keep trying to improve productivity versus coming up with new profound ideas of like how we should like live and how we should I don't know. I feel like the Renaissance period came up with a lot of good ideas, and I'm trying to think if these days people are coming up with the same good ideas. I don't know. What was your favorite moment in time? Basically, what I think is right now, a lot of focus is on optimization and driving growth or driving like efficiencies. Same way when during the Industrial Revolution, that's what they kind of focused on. So let me do this. Let me look it up. Let's just GP that thing. So that's like what I've been thinking about in my head a little bit. Dude, I explained that bad, but what was the Renaissance time known for? Okay, I'll tell you what the Renaissance time was known for based on GPT's accounting. And another thing that I found so interesting is that I think GPT and AI is like the 21st century author. You can just ask it questions and it is spitting out ideas based on what it knows of the current time right now. Like now we have a snapshot of time because it's pretty much trained on the whole internet. So pretend GPT 3.3, right? It was trained on data in 2021. Now it has a snapshot of all of that. Imagine 100 years from now and somebody's prompting GPT and asking it questions and trying to understand what GPT thinks of the world is actually crazy. Because if you think about it right now, or if you think about it before, what I was seeing with a lot of these philosophers and stuff, and people back in the days, they were like looking through. Yeah, your message is going through, Paul. But what I saw a lot of them were doing was they were researching or reading a ton of different things, and then they're coming up with their own accounts and books and their own snapshot of how things exist. Like they're consuming a lot of the different things around in the world from them, and then they're like producing content. Bro, I started snatching someone block shit. Wait, let me blow my nose real quick. Okay, let's read what the Renaissance time. Okay, let's talk about like what. Let's read a little bit about what the Renaissance time was, and then let's talk about the industrial time, and then let's talk about what, and then let's have a thought experiment of what age are we in right now. So, the Renaissance, which means rebirth in French, was a cultural, artistic, intellectual, and economic movement that began in Italy in the 14th century and spread across Europe in the 16th century. It is most commonly associated with the period between 1300s and the 1600s. So what the Renaissance was known for, and this is based on what GPT is saying. We're getting an account of, this is from GPT. I don't know if it's hallucinating. I'm not an historian, but let's just correct GPT, correct if anything is wrong. But this is GPT's account of what the Renaissance times was. So, revival of classical learning. So, in the Renaissance, there was a renewed interest in literature, philosophy, and the art of ancient Greece and Rome. Scholars studied classical texts and emphasized humanism, focusing on human potential and achievements. John, what we're doing is we're just discussing like what age are we in right now. There's like the Renaissance period back in the days, and there's like Industrial Revolution, and now they say we're in the information age. The thing that I'm trying to explore is, you kind of touched on it in our conversation, but these days a lot of focus is on optimization and just productivity and improving like certain aspects and like optimizing. It's more like the Industrial Revolution kind of, instead of something like the Renaissance period. So I'm trying to figure out, like, I liked the things that came out of the Renaissance period, and I wonder if we could bring that sort of thinking back when it comes to exploring these areas, instead of focusing on just productivity, or efficiency, which I think is happening a lot these days. And it's a whole different way of thinking, and there's different winners and losers. Let me see. So let's figure out so what happened in the Renaissance. There's a renewed interest in literature, philosophy, and the art of ancient Greece and Rome. Scholars study classical texts and emphasize humanism, focused on human potential and achievements. There is artistic mastery, a golden age of art with realistic perspective, human emotion, and anatomy. Iconic figures include Leonardo da Vinci, Michelangelo, Raphael, Donatello, and others. Scientific advancements, beginning of the scientific revolution. Thinkers like Galileo challenged old beliefs. Emphasis on observation, experimentation, and inquiry. Inventing of the printing press in 1440. Okay. So, in short, the Renaissance was known for a profound transformation in art, science, culture, and thought, setting the foundation for the modern world. That's what was cool about the Renaissance period, because a lot of people refer back to the Renaissance period, because a lot of the ideas that we've built on right now was born in the Renaissance period. So the reason why I was thinking about the Renaissance period is I was wondering, are we in a very special place in time where like people 1,000 years from now are gonna look back at this period in time and be like, that was a really transformative time in history, if we make it 1,000 years from now, right? That's what I'm thinking. So yeah, basically like a new Renaissance. It doesn't have to be the same, but is it similar to 1,000 years from now? Are people gonna look back at this point in time as this point in time, like like was this era very transformational for how humans live 1,000 years from now? And that's what I was trying to think. So let's look at the Industrial Revolution. I don't know if I'm making sense. Is that you see like what I'm trying to think about right now, or no? Pat? Okay, so the Renaissance ended around 1700s. But let's talk about the Industrial Revolution happened between 1750 and early 1900s, where society shifted from mostly agriculture and handmade production to industrial and machine-based manufacturing. So this is when really people shifted, or we started introducing all of these automations. So what was the Industrial Revolution known for? The Industrial Revolution was known for the rise of machines and factories. Introduction of machines that could produce goods faster and more efficiently. Factories became new centers of work, replacing small workshops and farms. The textile industry boom, one of the first industries to industrialize. Inventions like a bunch of things. Transportation revolution. They developed a steam engine, railroads, and canals, and now it's even like now we have those combustion engines. Urbanization, massive migration from rural areas to cities for factory jobs. Cities grew rapidly, often faster than infrastructure could handle, leading to crowded and poor living conditions. Like, are you asking if we're in a new renaissance? I'm asking if we're in a new renaissance period, or are we in a new period that's actually gonna actually important, I guess, and it's gonna shape generations beyond us. I mean, obviously AI and computers have changed a lot, but yeah, or caused things to change a lot. But I'm just trying to look at it from an empty mindset right now. Because it's easy to be like, oh, right now we're the more advanced. How the industrial period is an evolution of the Renaissance? What do you mean by evolution? Rise of capitalism and industrial economies, growth of the middle class, and the rise of wealth among factory owners, but also harsh working conditions for laborers. So you could see that, like with the Industrial Revolution, there was some downsides, and obviously there are some downsides to the Renaissance period as well that we didn't get into. But let's talk about it. In simple terms, the Industrial Revolution was a turning point in history where machines replaced manual labor, factories replaced farmers, and cities replaced villages as the center of life, shaping the modern world as we know it. So it still changed things like crazy, right? Okay. How did the Industrial Revolution grow out of the Renaissance? Okay. What's the best model to auto categorize stuff like an image? Trying to stack what's the best what you can do is you could actually try using LangChain. And then also try to just use like a LLM that categorizes stuff, and you can you can make the output so that it puts the output in very specific categories. So you can now do classification with an LLM, and then you pretty much use LangChain to help you run the classification. It builds some stuff around it. So Patrick, let's talk about humanism, because that's apparently a very important part in the Renaissance period. But human is a way of thinking that emphasizes human potential, individual achievement, and the value of human life, especially through reason, education, and creativity. Humanism is the belief that humans can understand and improve the world through thinking, learning, and effort, without just relying on religion or tradition. I think that's was like the profound part, because before that, people didn't think like that. I mean, right now it's pretty obvious. Like we're humans. We understand the world. We can think and we can change the world by thinking and learning new things. So became humanism became popular during Renaissance. Renaissance humanists look back at the classical texts of ancient Roman Greece, focusing on subjects like philosophy, literature, history, and art, in what we now call the humanities. Key ideas of humanism: humans have value and dignity. People are capable of reasoning and critical thinking. Education and learning help people grow. This life matters, not just the afterlife. Art, science, and literature are important for understanding the human experience. So this is what stuff grew out of the Renaissance. Before that, these ideas were happening less apparently, and we could prompt that if you want. But that's humanism. So, how did... Yeah, exactly. So people would just be like, yeah, basically what you're mentioning right there. The Exactly. So if someone told you you're gonna be a peasant and you're a peasant and you just believed it, versus all humans are created equally, and yeah, that's literally, I think that's in the Constitution. Like, all humans are created equally. I think that's also one thing that came out of Renaissance too. When they're questioning, they tried to question a lot of those things, and that all humans are created equally, and if you learn, you could become like you could advance, you could socially advance. Yeah, exactly. So right now, in these days, that's more of like an obvious statement. But back then, you had to push down a lot of walls in order to get that idea forward. And that's not, it wasn't just a given. Now it kind of is, but in the Renaissance times, that's when they were like focusing on humanism, reasoning, and learning. So I think that's what helped them started to focus on things like science and math and learning. So it revived science, mathematics, and engineering, encouraging people to question old ideas and explore new ones. This spirit of curiosity and problem solving would later drive inventors and scientists in the Industrial Revolution. So that's one way. So scientific revolution grew from the Renaissance. So Renaissance thinkers laid the groundwork for the scientific revolution. Scientists like Galileo, Newton, and Kepler made discoveries that reshaped how people understood the world. New focus on experimentation, observation, and logic replaced superstition. That's an important part of like actually the scientific method of experimenting something, observing it, and then coming to conclusion. Like, what do we do when we were in school all the time when we were running our science experiment? We were running an experiment, we were observing it, and then we were writing down the findings instead of having a bunch of superstitions about how things worked, right? And then that's how they're coming up with all these other things using this sort of method. So these methods eventually led to technical breakthroughs that powered industry like the steam engine, the printing press, and the spread of knowledge. More people gained access to education, including future inventors, engineers, and entrepreneurs. So that came from the printing press. Now they could distribute information everywhere, and now that's the same thing now, but on steroids. We're on information overload, they say. So rise of individualism and entrepreneurship. Renaissance humanism emphasized the power of individuals to shape their own lives in society. This idea encouraged the growth of inventors, innovators, and business-minded individuals who would later fuel industry. The mind shift helped create a culture of invention, progress, and capitalism. I know, Patrick, you just wanted to talk about that. Renaissance Europe saw the rise of global trade, banking, and merchant classes. These developments created capital, money, and demand, two ingredients for industrial growth. So basically, the Renaissance planted the intellectual culture and the seeds that eventually bloomed into the Industrial Revolution, right? Okay, what age are we in right now? Okay, yeah, what age are we in right now? So right now, we are in the information age, only known as the digital age. What is the information age? The information age is the period in human history where the creation, sharing, and use of information and technology became central to everyday life, work, and communication. It started around the mid-20th century with the inventions of computers and internet and continues to this day. Key features of the information age: widespread use of computers, smartphones, and the internet. We have instant communication these days. You can literally reach anyone from any side of the world in seconds, milliseconds. Data and information economy. Business thrive on collecting and analyzing data. There's an increasing use of AI, artificial intelligence, robotics, and machine learning. Jobs often involve creating or managing information, not physical goods. That's interesting. The world is more connected than ever before. Quick timeline of the ages. So these are, damn, we're in this new age. So Stone Age, early tools and hunter-gathering. Bronze Age, metal tools and early civilizations. Iron Age, we have stronger tools and empires. Then we have the Middle Ages, which is feudalism and religion-dominated society. The Renaissance is the rebirth of learning and art. And then Industrial Age has just happened before us when they were building all these machines in factories and urbanization. And now we're moving into this world of just everything being digital and the digital revolution. What should we ask it? Like, how are we closer to the Renaissance times or the Industrial Age? I feel like we exercised our creativity more in the Renaissance times. Is there a way we can get back to that? Patrick, wouldn't it be cool if everyone was focused on their creativity and things like that these days? Not saying that they're not. I mean, everyone would if they could, but obviously there's a lot of factors. That's exactly why I was thinking, Patrick. Like, why I feel like we're more in the Industrial Age than the Renaissance Age. Where the Renaissance Age, people were focused on it, but I mean, there's a lot more people living in poverty and things like that. I doubt. Obviously, a big portion couldn't even like do what they wanted to do, but maybe we can get back to those times. Yo, what's up? Yo, send it, email it to me. So, are we closer to the Renaissance or the Industrial Age? Technologically, we're closer to Industrial Age. We live in a world shaped by machines, factories, mass production, and now automation. Our systems, education, work, economy are still heavily influenced by Industrial Age values, such as efficiency, productivity, specialization, and scale. Yeah, that's a lot of the big buzzwords you'll hear working in the private sector. Culturally, there is a case to be made that we're longing for something more like the Renaissance. People are rediscovering creativity, art, and self-expression through platforms like YouTube, TikTok, indie games, online art, and more. There's a growing interest in interdisciplinary thinking, like how the Renaissance thinkers blended art, science, and philosophy. So why the Renaissance feels more creative? Well, the Renaissance valued curiosity and exploration, art for art's sake, learning across disciplines, and individual expression and beauty. While the industrial age, in contrast, prized efficiency, standardization, productivity, and uniformity. What do you mean by the change of ownership? Sorry. You got more water. So, I agree with this a lot. You'll hear these words more than these words. 100%. And that's because people are trying to make a living, people are trying to get rich, people are trying to do all that stuff. Understandable. Can we get back to the Renaissance mindset? Yes, and in some ways we're already starting to, but it takes intention. Here's how we can shift our lives and society towards a more Renaissance way of being. Reclaim curiosity. Stop learning just to get ahead. Learn because it's beautiful and exciting. Take the time to explore art, philosophy, music, and science, even outside of your job. Follow rabbit holes and make connections between seemingly unrelated ideas. Create, just don't consume. Renaissance people made things like paintings, essays, inventions. These days, draw, write, build code, compose, even if no one pays you. Not everything has to be monetized. Some things just for the joy. Value the humanities. The modern world often favors STEM, but the Renaissance was about balance. Philosophy, literature, ethics, and history helped us understand what it means to be human. These subjects ask us the why behind the how. So embrace interdisciplinary thinking. The Renaissance genius wasn't specialized, he or she was well-rounded. So I think, that's how we can all tap in back into the Renaissance way of thinking and just not focus on efficiency and productivity. But the main problem with that is just how the world works right now. It's hard to make a living out here. You can make a living, but if you focus, but then if you really just pretend, if you just focused on art the whole time, you could get left behind. And it touches on philosophy, history, economics, and psychology all at once. Here's a breakdown of how human ideas have changed over the time as the concept of ownership evolved across different areas. Okay, Patrick, we're getting into this. So, what I think about AI agents, they're cool. Like, what do you mean specifically? Shit, my neck's hurting. So, Alpha, we're about to, I think I have Alpha next, so I'm gonna run this and I'm just gonna finish this off. So how have human ideas shifted with ownership? Prehistoric times. Shared resources, little private property. Community and survival was central. Food, shelter, and tools were collectively used. Identity was tied to tribes, skills, and cooperation, not possessions. I survived because we survive. So that was in the hunter-gatherer. But then these hunter-gatherers are fighting with each other to kill each other for their resources. Agriculture revolution, 10,000 years ago. Land becomes ownable for the first time. Land equals power. People began settling, creating surplus, and protecting what was theirs. Class and hierarchy began forming, landlords versus peasants. This is my land, my crop, my family. Okay. Ancient civilizations. This is interesting thought, Patrick, though. Ancient civilization, hierarchical and centralized. So we had kings, pharaohs, seen as divine owners of everything. Then we had laws, like formalized rights and property. We had slavery and tribute systems emerged. Some could even be owned. Cozy, I'm gonna read first. Yeah, I don't know if I'll have time to look at it honestly, because I have somebody coming on next. My worth depends on my class and what I'm allowed to own. So that's what in the ancient civilization word. Feudal era, Middle Ages, ownership, land controlled by nobility. Peasants worked it. Ownership was tied to birthright and divine order. Yo, see ya. Ownership was tied to birthright and divine order. Most people never expect to own anything of substance. Identity was tied to duty, religion, and rank. Okay, the Renaissance period. The rise of trade, private property, and individual rights. Humanism. Focus shifted to the individual. Property became tied to freedom and personal dignity, especially in Enlightenment thought. Early capitalism began to shape. Patrick, is this getting at where you wanted to go? Industrial revolution. Shift from land to capital. Machine. Ideas about life. Work equals wage equals survival. Ownership became more concentrated. The working class had less control. Karl Marx and others criticized the imbalance. Those who own capital rule. I sell my time to survive. Others profit from my labor. That's like the thoughts in the Industrial Revolution. In the information age now, shift to intellectual property, data, digital goods. Increasing focus on personal branding, ideas, and identity as assets. Owning stuff, cars, houses still matters, but ownership of data, attention, and creativity is a new frontier. Social media, NFTs, and algorithms reshape what ownership even means. I am what I create, post or control online. I don't. Interesting. All right, that's our little spiel on on Renaissance stuff like that. It's kind of true, Patrick. Like right now, you could see people. Their whole identity is they could be living the worst life, living in a very bad, in like a bad situation, but online they have this persona online. Maybe there's posting pictures like good pictures of themselves. Maybe they do pictures when they go out, and they have like their whole life online that makes them happy. But in real life, there's nothing, and you'll see a lot of people prioritize showing off versus actually owning stuff. Like owning cars and houses, it's more about like who has the fanciest car, who has the fanciest house, who's gonna have that and post that on social media, versus just having somewhere to live, right? Because now with social media you can show it, and you could show it to a lot of different people. So I think I agree a little bit of that's kind of where we are right now. Yo, Alpha, you ready to go? Holy crap. Dude, we're just talking about... Yo, Patrick, when you... Talking about random stuff. Dude, there's so much like different topics. Okay, we're gonna get Alpha, and I think I could actually get him with a question today that he can't solve. Dude, my neck hurts. Patrick, that's what I'm saying is GPT allows you to find information so fast. It's just because what I saw is there's people back in the days, they would look everywhere, and like they'd never leave no stone unturned looking for any book that they can read, and then they read the book and they find information, and they're just like going everywhere trying to find like the best information so that they can have the best ideas. Like these are like the philosophers back in the days, but now they don't have to search, or the way that they can search, the way that they can find information these days is way faster, and they can find things so fast. Like imagine Einstein had had access to LLM, and then he could have the AI verify some of his work or come up with new ideas for him to work on or to explore. Like imagine it just kept running and keep giving him new ideas, was verifying all his work, was doing all these different things. Imagine what he would have came up with. Or maybe he would have just stopped using his brain. You never know. That's like was the whole thing. Alpha, you're not. You don't have the Google invite on Google Cal. Yeah, this generation's Einstein might be you, Pat. You're the expert at GPT. That's where I was trying to go at with, or where I was trying to get to with John is. We should use the AI to help us learn faster and learn new and discover new things besides just generating the stuff for us. Because if it just generates the stuff for us, we don't get to use our critical thinking. And yeah, we're like offloading a lot of the things that are good that our humans are good at. Or we should just use it as a tool to like understand how things work. And yeah, pretty much that. Yo, Alpha,
Hello.
what's up? What's good?
Hey, dude, I'm falling asleep to the AI lectures, not gonna lie.
You want just straight coding interviews?
Nah, I just feel like there's not a lot of, I mean, A, I don't like the philosophical stuff, and B, I feel like if people just read GPT stuff, like I can just do that myself. It's just not like very entertaining for me, you know?
I see. So, for you, what's it called? What do you think about the AI stuff? Are you a fan of it?
I mean, it has pros and cons. I definitely think people are very, like, just thinking about their own use, and like the Einstein stuff, I disagree completely, because like even if you ask like reasonably difficult like leak code stuff, it can like do the wrong stuff. So if you're making something like that isn't there, and you're relying on the AI to tell you if it's right or wrong, like it can just completely lead you into like who knows where, right? So
Yeah, I see.
yeah.
So what's it called?
Pros and cons though.
Yeah. What kind of interview do you want to do today?
We could do a coding one. You said you can stump me with some stuff. That's fine.
Okay, give me a sec. Got some water. Wait, you have work today or no?
Nah, dude, I'm not. No, I mean, in tech, yeah, you actually do have the federal days off, so.
I just called my friend. He's the one working at my previous company. He has work.
At Rippling?
Yeah, it's crazy.
I guess that's what they pay you for, right? I don't know.
I don't even know. Yeah, I always forget that because when you start making X amount of money, you automatically adjust to it and you don't care. Like it's like you adjust to things really fast.
Yeah, I think people definitely scale up their like expenses to compensate and stuff. Also, I think if you make a lot and they make you work a lot, then you can kind of be like, yeah, but it's fine. I think the other end would be pretty bad. If you don't get paid a lot and you gotta work these days, then it's like, well, what the fuck?
Yeah, this is the worst. But that's most people's situation, honestly.
That is most people's situation, yeah. So no, I took Friday off as well because I was just like, I don't want to.
You have unlimited PTO, right?
I mean, what does that mean? You know, is it unlimited?
Who says it's not unlimited? I always don't understand that debate. Like, what?
I mean,
why is it not unlimited?
I mean, to go to the extreme, what if I just take like every other day off?
Yeah, exactly.
I'm sure I'll get something.
Like the part that I think is unlimited is still better than having a fixed day, because you can still get more than pretend that people really only have like 20 days of vacation. Everyone that I know who has unlimited has taken more than 20 days off in a year.
Yeah, I gotta do better, dude.
Yeah,
I'm only at 6 so far.
That's crazy. Yeah, you need to take way more days off.
That's what I'm saying. I was really paranoid in the beginning because it was my first job. I was like, I don't want to fall behind and stuff. But so last year I took like 5 days. This year I gotta definitely hit like at least like 25 or something. So gotta take more days off in the. Yeah, because I was looking, you can see people's calendars and days take off, and I'm like, damn, these people are taking off like so much. What's
Yeah.
going on? So yeah,
Someone's asking in the chat, where do you work?
work at Blend.
He works at a fintech company. But also, taking time off, there's a trade-off as well, right? If you take too much time off, you're gonna push out less projects, and if you're trying to get a promotion, it could hinder your promotion. That's what I still think about that portion of it.
Yeah, well, I just got promoted too, so I think
Yeah.
the next one's senior, and no matter how well I do, that's not happening for like a few years. So
Okay, let's get into this. When's the Alpha 75 list coming out?
I think I'm gonna make some algorithm thing in Java and actually try to have like better video quality and stuff instead of just making random problems. So I'll make some stuff. And I figured out a bunch of stuff that isn't like very mainstream, so I could share some of that. Like I think there's a lot of topics that people don't really talk about or have content on. So yeah.
Yeah. There's so many things I want to get into, but then I got stuck in this leak code thing, which gets a ton of views. Obviously, people like it.
It's the dilemma, you know. If you talk
But why do
about
people-
things you want to talk about and you get no viewers, is it worth talking about? Or are you stuck in leak code?
Dude, people love the leak code content.
Yeah.
People also
People-
hate leak code, or people keep. So everyone always telling me leak code is dead.
Can you send me the link?
Yeah.
Yeah, it's funny. They're always saying leak code is dead, but they're always like signing up for this stuff and watching it. So
I was like,
which one
leak
is
code is dead, but why is all my videos on leak code the ones that get the most views? How is leak code dead?
Yeah, I don't know. You should just get Cluely and do it with Cluely. You know? Dude, I literally saw on LinkedIn like there was a dude who was making like an anti-cheating thing. It's just gonna be like companies making anti-each other products.
Yeah.
Very funny.
People have been caught using that interview coder and have got blacklisted, and I seen it in Google, or sorry, yeah, in like Reddit. People are like, I got blacklisted.
Yeah, they're like, what the hell? It's so unfair. I laugh at that stuff, to be honest.
Yeah, you got caught cheating, bro.
Like, if you sign up for this thing, you're kind of like accepting the fact that if you get caught, you're blacklisted. What are you complaining about?
The lead dev of Cluely went to my high school. I don't know how he did it. I just remember he was kind of on the spectrum. No offense.
I mean, you definitely have to kind of be like some kind of something to make your company like make cheating everywhere thing, right? It's not most people. Like most people would be like, this is unethical.
Yeah, I agree. Yeah, we could talk about that for forever, but I'm gonna start up the video.
All right.
Hey everyone. So today we got Alpha, and I have some better questions. Hopefully, we can have him struggle a little bit through these. So what language are you gonna be using?
Oh, let's do Python this time. I'm too tired for the Java.
Let's see.
Probably rusty on Python, so it'll be good.
Yeah, you can never forget the best programming language on earth.
Yeah, I mean,
I'm just kidding.
at this point, it's basically just like writing a prompt and feeding it into cursors. Basically, Python, right? Close enough.
Side questions.
Dude, we should try that. Like, you find some crazy hard stuff, we try to feed it into the LLM and see if we can get
Yo,
use the AI as-
there is some hard ones. Have you seen Advent of Code?
Yeah.
Have you heard of that? Some of those later ones are really hard.
Yeah. I think I did last year. I did the first half, and then they had some stupid one with some tree thing, and I was like, okay, what is this even testing? And then I just like quit. But yeah, I think I did the first half, and
Nice.
it definitely started getting challenging.
Yeah. All right. So we're given an integer n. Return the number of structurally unique BSTs, which has exactly n nodes of unique values from 1 to n.
All right. Okay, so just to define structurally unique, let's see. So, guess we can. Where's the drawing thing in here again? Do they even have it? All I see is the AI. Oh, there it is. Okay, so structurally unique just means they're the same shape or something. Like yeah, is that correct?
Same structurally unique.
Yeah, can you pronounce it?
Yeah, I can't pronounce it. Let's go like this.
All right, so
So
like
that's structurally unique.
yeah, so these two are structurally unique, but if I had it in like this way,
If you had 1, 2, 3, and 3, basically go back.
oh yeah, okay. Okay, so the are those structurally unique, or are they
This
the
is not
same?
structurally unique. They're exact same, right? But like this is
Got it.
structurally unique.
Okay, I
Right.
think I gotta zoom out or something. Okay, got it. Yeah.
This right here is structurally unique.
All right, got it. So essentially, all we care about is the connections. We don't really care about the numbers, so we can just use like the number of nodes we have.
Yeah.
Yeah.
So okay, pretend we have 3. Let's just make sure your understanding is correct. What are the
Right.
different structurally unique nodes, and then we can work from there.
Right. So there's these two. Then there is this the other way, right? So this would be if this was the left instead.
Or just draw them out, like from here, from N3. Can you draw
Yeah,
each one out separately?
okay.
Just so we have.
Sure, yeah. So one would be like this, right? One would be that. Is there any other one? Yeah, I think there's more, actually. So if I had this, that, right?
Yep.
And then the other side. Actually, no,
You
we
already have
already
that.
have that one. Yeah.
I think
Okay.
the other one is just
The right, right?
Just
So
go
it goes
this
right
way.
and then left?
Yeah.
Yeah, okay. So this way. Okay. Let me zoom out here. So what is that, like 5?
Yeah. Answer there is 5.
Okay, cool. Alright. So I think because we don't care about nodes, basically it just comes down to like ranges. So essentially we can have like, I don't know if this is DP or something, but our base case here can be yeah, I can start writing in the thing. Our base case can be if n is 1 or 0, then there's only like one way to do this, right?
Mhm.
Because one node can only be made in one way. And 0 nodes can only be made in one way as well, just like null. So
Mhm.
that is the other one. And then for the other cases, so let's say like n is 2. Basically, we have to pick like what node we pick to be the center, and then the rest of it is like a recursion. So if we have 2 nodes, we can either pick like 1 to be the center, and then whatever we pick to be the center, like everything to the right will go in the right subtree. So meaning like if I have like left root, right? So I can either have like 1 here, and this is 1 node, and there's nothing, or I could do I could pick the root to be, or I guess, yeah, let's just actually say what node we pick to be the root. So let's say for 2 we have nodes 1 and 2. So this would be like root 2. We could also do it this way, where there's 1 node here and no nodes here, and so on. So basically, for whatever node, so the like I guess the pseudocode would be like pick every number from 1 to n to be the root.
Mhm.
Then recursively call left and right.
Mhm.
And then for that root, number of combinations is just left times right? Like whatever way we could structure the left side and whatever way we could structure the right side. And we could probably have some caching here because we're gonna have like our DP function, I guess, is only going to take in like one number and just calculate this thing. So we can have some caching for sure. So I think we can just do like a top-down DP with a cache, where we essentially break this down. And yeah, our base case, like when
Is
we
this the
know,
one?
yeah. So the way we could do this is, yeah, basically like whatever number we pick. So if n is like 5, and we pick the root, like let's say n's 5 and the root is like 3, that means we know there's 2 nodes to the left and 2 nodes to the right. But if we pick like the root to be 4, then there's like one node over here, and what was the other one? 3 nodes over here, and so basically just like our deep top-down DP recursion, and we just sum it all up and return that thing. Does that make sense?
So every number, pick one to the left, or pick a number and then figure out how many nodes are into the left and nodes into the right.
Exactly. Yeah.
And pretty much. Okay, when we get down to like the bottom of the tree, we're gonna be saying the bottom of the recursion. We're just returning like 1.
Yeah. If we have one node, it's 1. If we have no nodes, it's 1, because there's only one way to do that. And then everything else is just a recursion.
Let's see. Will that work for like a simple, like try it for 3? For 3.
Sure. So for 3, so our thing for 3 will be, so we pick 1 as the root. So left is 0, so there's only one way to do that. Right has 2 nodes. So for 2 nodes, that's also a recursion. So for 2 nodes, we have to calculate what that is. So right is like n equals 2. So for n equals 2, I think thinking about it, there's 2 ways to do that, right? Yeah, there's 2 ways to do that. So here, there's 2 ways here. Because essentially, you can make a node with a left or a node with a right. So there's 2 ways to do that. So in this case, with 1 as the root, there's 2 combinations. Then we pick 2 as the root. So if we pick 2 as the root, there's 1 node to the left.
Cache this? We cache this, or go
yeah, we cache. Yeah, we just cache them all. So that way it's like
right always has 2.
No, I mean like we're gonna have the same calls a bunch. Like if we have like 10 nodes, like as we go down, we're gonna have the same numbers we're gonna call. So that's what we want to cache. But yeah, so if we pick 2 as the root, there's 1 node to the left, 1 node to the right. So there's only one way to do that for each of those. So this is 1 total. And then if we pick 3 as the root, that's just going to be the reverse case. So left will be 2. And wait, actually, here this is 0, right? If we pick 1 as the root, there's nothing to the left. So this is just the reverse case of the same. So there's 2 here as well. And then 2, 2, 1 is 5. Is that what we had in the picture? I think.
Okay, yeah. So if we pick 1 as the root, and then the left is 0 and the right is 2. Okay.
Mm-hmm. Yeah, I mean, we could show the recursive case for n equals 2, but for...
Try it out.
Okay, yeah, cool. Okay, so let's see. So def, we can call this like count trees or something. N. Okay, so we just need a DP function. What the heck? Autocomplete. Don't do it. No. Stop. Enter. Okay. I think this is from here. Okay, and you can definitely do this bottom up as well. But yeah, we'll just do it this way. Okay, so pn. So if n is less than or equal to 1, we'll return 1. Otherwise, so we basically have to go through all of the numbers in here and then make that the root and then count the left and the right. So that will look like this. I in range. I guess to make it easier, we can just 1 index this. So we could do this. So this is going to be so whatever number we pick is going to be the root. So the number to the left will be, let's see, I minus 1. Number to the right will be n minus I. Yeah, okay. And then we just do actually, so this is a little bit wrong. So this is dp, right, of that. dp of that, dp of this. Okay, this is how many numbers we have. And then this is just that.
I minus 1, okay.
Yeah, so like if we have 5 nodes and we pick 1 to be the root, then there's 0 on the left. If we pick 2 to be the root, there's 1 on the left.
Yep.
And then the other one should be correct as well. So like if we have 5 nodes and we pick node 5, there's none on the right. If we pick node 4, there's 1. Okay, so basically we just do that. And then we just return DP of whatever that thing is. Yeah, and I think this should work. Can I test it?
Yeah, let me see.
Okay.
I'll test it.
Okay, sure.
Actually, let me just send you an invite.
Oh, to that thing? Okay, sure. Did you put it in the meet or? Okay.
Shoot.
Okay, cool. All right.
Nice, solved it.
Okay, nice.
Okay, we'll move on to the next question.
Definitely refreshing to do Python because it's just like, wow, I just wrote like 5 lines and it worked. It's nice.
Yeah. Okay, we're gonna do a fun one.
Fun for you or fun for me?
Fun because it's more realistic kind of thing.
Okay.
Damn, 10 minutes on that question? Holy crap, I thought that would take you longer.
Yeah, I'm giving myself more room to fail, you know?
So there are n people in a social group labeled from 0 to n minus 1. You are given an array logs where the log timestamp is a timestamp that indicates when xi and yi will be friends.
Mm-hmm.
Right. Friendship is symmetric. That means if A is friends with B, then B is friends with A. And it's also transitive. Or there's also acquaintances, right? Person A is acquainted with person B if A is friends with B, or A is friend of someone acquainted to B.
Yeah.
Return the earliest time for which every person becomes acquainted with each other. When I give you the logs, so we just need to know the earliest point in time. Then people are all.
Okay, got it.
Wait, let's go back to your algorithm. Come back to unique binary search tree. I forgot to ask you time and space complexity.
Got it. Yeah. So, let me look in the. Okay, so the DP is n time because we're getting to every point once and solving it, and everything else is cached. So I think this is just. Oh, let me actually think about that. I don't think that's. Wait. So we are looping as well. So like, yeah, I don't know if it's actually n or it might be more than n. Yeah, I think it has to be more than n, right? Because like even when we call it the first time, it'll loop. Yeah. Yeah, I feel like it's n squared for time, and then space would be n, because we have the loop in here. Yeah. So even though that like this is n and this is n, and then yeah, I think that makes sense to me. Does that make sense to you?
Yeah. Okay.
Okay.
Cool. Let's hop back onto this one.
Okay, sure. So there's n people. Okay. Return the earliest time where every person. Okay, got it. Okay, let me just draw. So I have an idea. Let me just make sure it works. So I guess I don't need to draw the circles. I'll just have the people. So there's like 5 people here. So let's just say we have like 0. Zoom in or something. Can I do that?
You don't like to do like just freeform?
Oh, the circles? I mean, yeah, I could draw the circles. Oh, yeah, I don't know.
Like you like to use these like things like this.
The built-ins? I'm trying to use the hotkeys because I'm using this thing for a lot of stuff, and a lot of like everyone uses this now. I think it's like the standard. I think learning the hotkeys might be worth something. I don't know. Okay, so we have like 6 things here. So let me just zoom out of it too. It's also kind of annoying when it's like in a platform because then I can't full screen. Like normally I just have it full screened.
Mm-hmm.
Okay, something like that. Okay, I just spread these out. I'm curious if this works. Not 100% sure. Okay, so let's say we have these people now. So this is like what 0 to 5. So 0, 1, 2. Not very. Okay, sure. Okay, so in this example, are these logs in order always?
No. We're
so-
in time?
Yeah, in time.
Oh, okay. Oh, you're saying is it sorted by time?
Yeah.
Let me check. Yeah, all the values in the timestamp are unique. All the pairs.
If they're not, we definitely want to sort by time.
I don't think it's sorted by time. It doesn't say. Wait, let's see.
Okay. In your example, are they? Yeah, I think so. Okay,
Let's
so
just
first
assume
thing.
they are first, and then I
Yeah,
think that's
yeah.
a very. I mean, all we need to do is sort.
Yeah. So there's not much there. Okay, so my idea here is use union find, and basically we can just try to connect them, and then when everything's connected, then we return that time. I just want to make sure this works. So with union find, pretty simple. First, everything is its own component. So we have 6 components to start off. And then every time we were able to make a successful connection, that means that these groups weren't connected before. And so that basically connects 2 components into one. And then when there's only 1 component left, then it's successful. So let me just make sure that works. And if there's like an edge case. So we can say we connect this in the beginning. And so now there's 5 components and this would work. Let me see here. Can I just write bigger? 5.
Fine.
Okay, yeah. Yeah, I guess. Okay,
yeah.
so then we connect 3 and 4. That also works, so now there's 4.
4.
2 and 3 also works, so now there's 3.
But
1
every
and
time
5
we connect
also...
one, we reduce by 1.
Yeah. But with union find, if you connect and things are already connected, not directly, but in some way, it doesn't count, which is kind of what we need here. So like, if I have like lower down, if I have like 1 connected to 2, connected to 3, and I try to do this will say invalid, which is what we want because they were already connected. Because we just need to care as long as they're acquainted, right? We don't care about like directly connected, right? So I think union find is kind of like perfect for this. So yeah, so where was I? 1 and 5. Yeah, so 1 and 5. So we reduce another 1. Yeah, so now we have 2 things left. 2 and 4. So 2 and 4 are already connected, so this will be rejected.
Yeah, so if it went like
0 and 3.
we wouldn't reduce the edge count.
Exactly. Yeah, union find only connects when they're in separate components. So this.
How would you know they're in separate
return
components?
false.
Like what in the algorithm is going to tell you?
So in union find, everything in a component has a shared parent.
Mm-hmm.
So let's say for this, the shared parent is like 4. When you try to connect 2 points, you get the shared parent, and if it's the same, you just don't do anything. So like this would return 4, this would return 4, and yeah, you just wouldn't do anything.
Makes
So
sense.
for 0, 3, that would also be connected, and then yeah. So now that we were able to make n-1 connection successfully, then we're done. We can also, we don't even need to keep track of how many components we have. We can just, like, if we know how many people we have, we can just try to make n-1 successful unions, and then that would always reduce it down to 1. In which case, yeah, so that would be that.
Sure. Yeah.
That would be that, and then we just reduce whatever time that was. Which in this, is that the answer there? The 20190 something? Like on line 14?
Yeah.
Is that the answer for that one?
Yeah. Answer.
Okay, and then as far as not being connected, so if we try to run all the connections and we never get n-1 successful unions, then we can just return -1. Okay. So yeah, the step would be like sort in timestamp and then do that. And yeah, I think that's pretty easy to code and pretty easy to do. So I'm gonna go with that if that works for you.
Sure.
Okay. All right, so union find. Yeah. And I coded this a bunch, so I can do it pretty quickly, hopefully.
Last time you were like, you didn't do it in a while.
So usually what I do with this is, and I think that works for me, is like maybe a third of the time I get this problem, I code it myself, and then the other times I just paste a template because I don't want to have to write it. But it takes like 5 minutes. So union find has a roots and a ranks, and ranks just means like the depth of the component, and so everything's just 1. And roots is like what's that root of the component that I talked about, the top level parent. And here it's just let's see, I for I and range n. So everything is its own root in the beginning.
Mhm.
And then find. So find recursively finds the parent, and then it makes it so the connections are as short as possible. So if self roots x does not equal x, then self roots x equals self find. Yeah. Let me think about this. Yeah, I think it's like this. And then we just return self roots x. Hopefully I'm not too rusty with Python syntax. Okay, so the union xy. So basically for the union, first we call find to get the top level parent. So x equals self find x, find y. So if they're the same, we could just return a Boolean value to let us know if we connected. So if x is y, that means they're in the same component. So we don't need to do anything. We can just return false and say this failed. Otherwise, the way this works is you basically connect the smaller component to the bigger one because that makes the paths shorter. So if self ranks x is less than self ranks y, then you make y the top level parent. X equals y. Return then else ranks. Or I guess yeah, it was fine. So self ranks x is bigger. Then you make it the other way. And if there's a tie, you just pick one and then you increase the rank of that one. So we can just say make it x self roots y equals x and self ranks x. Okay, and we just return true, meaning this was successful.
Mm-hmm.
Right. So that's that. And then we can just run our problem now. So this can be like find earliest. Yeah, I guess in Python probably want to use camel. So I think classes are still Pascal case. Yeah, so find earliest time. So this will be like logs. So first we want to sort the logs. Then we want to, are we actually given, by the way? Yeah, I guess. So we're given logs, but do we know how many people we have total here? Are we given that in the input?
Yeah, it's given n. We're given n.
Okay, cool.
That's a parameter.
Nice. Okay, great. So n is 0 to n minus 1, right?
Yeah.
Like okay. Yeah, so that's what you want in union find because it's basically 0 to n minus 1. So you just use union find. Whoops. N. And then you do, yeah, so you just go through the logs. So for timestamp xy in logs, we can keep track of connections here, I guess. So we can do a connect. So we can do if union find union. If this was successful, that means we have another connection. And if the connections equals n minus 1, that means everything's connected. So we just return timestamp. Timestamp. Otherwise, if we never get it, then we just return -1 here. Yeah, and I think that's it. So do you want to try it on this one?
Connections equals 0.
Yeah, so union find prevents cycles. and it basically turns everything into a tree. And so in a tree with n nodes, you have n minus 1 edges. So if you have n minus 1 edges, that means everything's fully connected.
Okay, let me grab the question. Where's this question?
Okay.
Let's run it on some of those cases.
Okay, yeah, sure. So we can say print find earliest time. Let's take this logs here and do it. Logs n. Okay, let's see if we get an error. Okay, so it's 2019-031.
Okay, I'm gonna
Is that
run
correct?
I'm gonna run this code in my
LeetCode?
yeah. It's a premium question, so I'm just doing it on the side.
Okay, got it. Oh yeah, you don't want to share premium questions, so they ask you like take down the video.
I've never had that happen yet, but
Not worth risking.
Not for LeetCode. It feels like it feels those other guys.
Yeah. Well, I think those other guys, I like. Yeah, I don't know. They're also kind of smaller. Like LeetCode, I don't think they care because it's like massive. Like if you show a premium question on stream,
Yeah, everyone has
they're
it.
not gonna care.
Tests have went green. Holy crap, we're getting through these.
Yeah, I gotta slow down, dude. Otherwise,
No,
I'm gonna get
it's good.
too hard of a question. I'll get stumped.
Let me see. Let me come up with one more question. We still have time.
Okay.
Damn.
Yeah, that's what I was saying. You know, you're saying like DFS or something, but there's times where Union Find is really good.
Yeah,
This
I
is
like
one of
Union
those
Find
times.
as well.
Yeah. Definitely makes some problems very easy.
Yeah, for this one, I would never do DFS. I don't think it'd be efficient. To do
I
a
think
DFS
most
here.
Union Find you can do in DFS in a reasonable amount of time, but honestly, when it's this kind of like, yeah, connection or that kind of, I just go straight towards Union Find. And then, yeah, like I said, I code it maybe 1 out of 3 times and then just copy paste the template the rest. It's not that hard to like remember, like it all logically makes sense.
Yeah. Like it's easy to make it work too, but some people mess up the ranking part. Well, like for me, sometimes I accidentally put like the rank. I accidentally put like roots or something like this.
Oh yeah, I got
And
it.
that's,
Yeah.
like, just by accident, because you just have to really carefully look at these.
Yeah, yeah.
And then even this part, for example, you're saving the root. This part is very important. This is like how it compresses it, where you do root x equals that guy.
I mean, to be fair, like in an interview, even if you didn't do the compression, I think people would maybe say it's okay. I don't know. Like you're never gonna test it on like a million entries, you know?
Yeah.
They're not gonna put it in their LeetCode and test it or something. So.
But that's the part I would look out for if somebody is compressing it or is using. Otherwise, I mean, it's fine. It's a very niche algorithm.
Yeah, I think the compression makes everything run in like O1 amortized, which is like the benefit there. So.
Okay, let me get this. Okay, let me find you a question
Okay.
that I at least have somewhat.
Yeah, you can't be giving me stuff you don't know how to solve. That's cheating.
Bro, there's nothing I can solve that you can't solve.
I mean, I don't know. I think I struggle on some stuff. Like that emails one was like not super, especially when you said like, I think the way I struggle for something is if I say like I'm gonna do it this way and you're like, yeah, I know you can do it this way, but like try this other weird way that you would never do it, then I think that makes it harder for sure.
Yeah, only reason I said it that time was because you said that you wanted to look up Union Find, so I was like, I don't know if we want to look up
Oh yeah.
anything.
No, I don't think I needed to.
But now you have it at the back of your
Yeah.
finger.
Yeah.
All right. Video's going.
How much time have we done so far?
Dude,
Kind of
like
curious.
you're doing less than 15 per question.
Okay.
So you're given a string S and an integer K. How many questions start like this? You can choose
Like every
one.
single one.
Yeah, you can choose one of the first K letters of S and append it at the end of the string. Return the lexicographically smallest string you could have after applying the mentioned step any number of times.
She's one of the first K letters of S. Okay. And append it to the end. Oh, so you're removing it from the front?
Well, K is 1, right? So the range is you could only, if K is here, you can only take anything from the first K, which is you could pretty much only take the first character and move it to the end. So you get C, and then you throw B to the back.
Oh, I see. Okay. Yeah, maybe this one's not so simple. Okay, so the first K. Okay, so you can either. Let me just make sure I get it correctly. Maybe overcomplicate. Yeah, I also have a tendency of like misreading the problem and then massively overcomplicating and then
What I'll
realize.
say is this one is actually a little bit harder than the other one. So if you think it's hard, or if you come up with an easy solution, we'll have to think about it a little bit.
Sure. Alright, so you're given a string. You can choose one of the first K letters and append it to the end. Turn lexicographically. Okay, so the first move, we take the character B. Okay, so the one thing I noticed is, like, yeah, we can remove from the first K. Okay, so let's just go to example 2 because I feel like that's a little bit better. So in the beginning, we can only choose the B or the A, right? And move it to the end. So they chose to move the B. And then, okay, so they chose to move the B. So let's just do this like step by step. So in the beginning you have this. So they chose to move the B, which makes sense.
Mm-hmm.
Then, yeah, there definitely might be like a lot of edge cases here. Okay, so then they have this. So now, can I pick from the first again? Like, does that first change? I guess it does, right? Like,
It does change, yeah. You can.
okay.
It changes what you can do.
Okay, and I can do this as many number of times. Okay, I got it. So in that case, I would want to do it because I can move a C to the back. So I guess then I have AC. So it's basically just like, do I want to do it or not? And then at a certain point, I'm guessing you want to stop doing it. Okay, so now again, we can, yeah, okay. So now we again want to move the C. So now we have A, B, C, C. And now, if we move the B, that's not good for us. Okay. Okay. Now the other thing I'm wondering is like, how many characters would we have to
The constraints.
no, not the constraints, but like imagine we can move every character. Can we always make it in lexicographically like best order? Probably. Like no matter what way it's in. So I'm just trying to think of like if I have some random thing like, you know, this. Is there always a way to make this just completely, I guess let's keep it simple in terms of like A, B, C, D, E. So if you're like this, is there always a way, like in KS5 here, is there always a way to make it just completely like graphically good?
Well, if you
And
can
I
pick
want to
from
say
anything,
yes. Huh?
Yeah.
Yeah, I want to say
Just-
yes, right?
You can pick the smallest one, or you can pick like the
biggest
biggest
one.
one.
Or
Go ahead.
yeah, I probably wouldn't want to. Actually, yeah. So I'd want to pick the B here. I mean, there might be like some efficient way, but I'd want to pick the B here. So it'd be like D, C, A, B, and then next I'd move the C. Next I'd move. Okay, so if K is the length of the string, then there's always a way to make it completely in order. And
What about if it's less?
right. So what if like K is 3? Like, what's the best thing to do here? Or even 4? Like now, can we make it the best? So is there like some best operation to pick? So we definitely would want to take a character and move it to the back, but what's the best one to pick? I'm thinking. So like, would we want to move the B this time? Or that something else? Like, I think moving the B actually like if we move the B, because ideally we want to get A, B, C, E, that. So if we do this, then we can then take the C, and then we can take the D, and so on. Yeah. So here, so like for example, 4 is still small enough to make this whole thing like completely in order. Okay, what if we had 3? Or like, yeah, what if we had 3? So then we'd like, would taking the B still be good? I think so. Yeah, because yeah. So in that case, we'd still do the same thing. What if we had 2? Yeah, so in case of 2, we might not want to do that because we can, like, we might not be able to access everything. Let's see. So here, yeah, if we have 2, like, which one do we pick? Do we pick the B or the D? So let's say we pick the B. So then we get D, E, C, A, B. And then we'd pick the D. Or actually, A, B, C, D. Yeah, so then we pick the D, I think. So this would be go here. Then we pick the E. Yeah, and I don't think we can make it completely in order now, right? Unless I miss something. Like, there's no way. I don't think.
What would you choose here, C or A?
Yeah, so then I'd pick the C.
Okay.
And I think this is the best we
What'd
can
you choose
make.
here?
Then you just wouldn't choose anything.
Or go back. Go back.
Yeah.
What if you just chose A?
Okay, so if I chose A, then we get C, B, D, E, A, which would be worse, right?
What if you chose B?
Oh, we can't, because K is only 2.
You could choose B right there. B is the second element there. Or no, choose B next, not in this next one.
Oh, choose B next? Oh, I see. Okay, so C, D, E, A, B. Oh yeah, so we are able to actually get it completely in order again. Huh. So that's what I was thinking, like, is it always just like, if K is 2 or more, we can always get it, like, the best? Like, can we turn any string and make it completely sorted? That might be like a trick question, I guess.
What's
It looks
the-
like this one we actually can.
This one we
Sure,
can.
go ahead.
Like what? How would you? Okay, what would we do now? Like how are we gonna get this in the order?
Yeah, so we can move the C next. So that would give us and that would be kind of simple if there's like a trick where you can always make it in order. Yeah, so this would be like this. And then we'd move the A, B, C, D next, and then the E, right? So it would be, yeah, A, B, C. We'd move the D next, and then we'd move the E, and then we'd get it in complete order.
Mhm.
So I don't know if that's the case. Like, can we turn any string into the right thing by just
What
doing
would
this
be a
enough times?
counterexample?
Right. So I guess that comes down to the problem is like, is there a counterexample where we can't do this? So let's say KS2 again. And if we can prove that there is no counterexample, then the answer is always just a sorted string. So let's say we have like the same example of like, let's just take some random letters. So like G, I, A. Yeah, I don't know like exactly what would be a counter. That's where you would just do like the leak code test cases to kind of like cheat your way out of it. Let's actually do numbers instead, like 1 through 9.
I think let's just think about it. I think what you said makes sense. Is pretend I have 2 at least, right? Then I'll just maintain. As soon as the lowest comes into my window, I'll shoot it to the back. But like if we can perform that process, always, I don't see a counterexample.
Yeah, actually, yeah. Thinking about it, yeah. So no matter what we have, right? Let's say we have numbers. We can always just keep moving things until 1 is here. And then we just keep moving everything else. So we can rotate everything else until our numbers and yeah, so thinking about it that way doesn't make sense. So like what we can do is essentially we can rotate this part. Like we can always just take the second guy and keep moving it until the second number is in well,
Or still
not in
reverse,
this
right?
yeah, it'd have to be some other thing. So if this was this, we wouldn't want the first 2 numbers to be in place here. We'd actually want to have yeah, like I'm not like yeah, so it's not as simple as I thought. Like you don't want to just have the first guy in place and the second guy in place and so on. Maybe do you want like the last guy in place?
Let's see. Where were you? Okay, pretend we had the 1, right? We find the 1. We shoot the 1 to the back.
Okay.
Now, when do we... Okay, now we see the 2. That's the second lowest. We shoot the 2 to the back.
Okay.
Okay, now what do we do? Who do we want next after the 2?
So we want the 3.
So then the question becomes, is it possible to get the 3 after the 2?
Is it possible
in
to
any
get the 3
case.
after the 2? Right.
Yeah. Like, is there ever a case where we can't do that? And if we could always do that, then I think...
Yeah, I'm trying to think. So yeah, I mean, I guess you can in some... Yeah, so basically you would... Yeah, I guess what you would do is you would rotate everything else, and then once you get to the 3, you would like move the 1, and yeah, I guess you could. It's just like not super easy to see the exact order,
Yeah.
but yeah, I think that does make sense that it
Yeah.
is possible. Okay.
Okay, that would be k equals to 2. Anything k
Right.
over to 2. What about if k equals to 1?
Right. So if k is 1, so that's our problem, right? So if k is anything bigger than 1, it's just always sorted completely. Okay. Yeah, so if k is 1, what would we want to do? So if k is 1, I think what we want to do is we have to maintain exact order here, right? So if we have this case, we can never really move things in another order. We're kind of doing like a queue, and we're just like looping and looping. And in that case, we would just find the smallest character, and that would be the answer. So in this case, we would just have the smallest one at the front, and then everything else would be behind it.
Smallest one, yeah. Smallest one at the front and everything behind it. What if there's multiple smallest ones?
Oh, that's a good point. God damn it. Okay. So yeah, I didn't think of that. So like duplicates. Okay. So what if there's multiple smallest ones? Okay. Well, I guess one way to do it, not sure if it's the best, would be try all combinations and then just like store the best, right? So that would be n squared for k equals 1, because you have to like build the string over and over and over, right?
What does that mean? Like try to place 1.
Yeah.
here,
So what I
and
mean
then-
is like, we'll take this string, we'll store it as a result, then we'll move the 9, and then we'll just do a string compare on this to our other one, and we'll store the best. Then we'll move the 8, and we'll just do this over and over and over, and then we'll just keep doing string compares. So essentially, we're just kind of like looping. We loop n times to get like every combination, and we just take the smallest one. So for every single one, we have to like build a new string, and we have to do a string compare.
Let's
So
look at a
that-
simple example. This one's getting too large.
Sure.
So,
Okay, so
you-
So
yeah,
basically
go
what we do here is we'd say like, this is our current best.
Yeah.
Okay. Now we are gonna move the b to the end, and we're gonna compare that to that. Is that better? This is better. So this is now our current best. And then we're gonna do it again. So, oh whoops. So CC ABA, is that better? No. So we're gonna keep the old one. CABAC, is that better? No. And then ABACC, is that better? Yes. So now this
Just
is our
keep
best.
rotating.
Yeah, so we just keep rotating and we just compare, and then after that we go back to original, so then we just stop. Yeah, so that's our answer. Essentially, we just keep rotating. There might be a way to better pick like the best thing in some more clever way, but definitely n squared would work. Are we looking for like better than n squared?
No, n squared is fine here.
Okay.
That would be n
Yeah.
squared.
Yeah,
Yeah,
because we're
because-
rebuilding the string every time, right? So.
Yep.
Yeah. So do you want to go with that approach?
Yeah, let's go with that approach.
Okay. So def find smallest.
Finally, a good one.
Yeah, I feel like with this one it's just kind of hard to realize that with k being more than like 2 or bigger. At least that was like, yeah, maybe I need a little bit of guidance, but it was like at least I kind of went in the right direction. Because I feel like if you don't think of that, then you're gonna get some really complicated stuff, right?
Honestly, I didn't know the answer either, so I was just like, I didn't give you really guidance. I was more like,
Fair.
I was like, oh, that sounds like an
Like
interesting concept.
that's
Let's try
like
it.
that one. That one. What I would honestly do in LeetCode is I'd just code that because I'd be like, maybe there's a counterexample, but I don't see it, and it's kind of hard. And then if it gave me an error, I'd do something else.
Yeah.
So I mean, it's not the best, but yeah. Okay. Okay, so we have S and K. Okay, so essentially we have to do so if K is greater than 1, oh by the way, if K is, can K be 0?
No, K can't be 0.
Okay, so if K is greater than 1, then we do S equals S split, or I think we just do list. Just do sorted list that join. Okay. There's that. Now the other case is we're basically just comparing. So we're going to say res equals s. And then what we need to do is we need to, yeah, just go through the entire like string and try to do joins and stuff. I guess that's fine. I don't think it matters too much like how you do it because you're going to have to use a substring and add them anyway. So we'll just, okay, so we'll say for I in range, think s. So essentially we'll say this is the, I'm trying to think of like how we'd want to do it. So if we have like this ABC thing, I mean, I guess we can always just make it a queue and just loop around as well. It might be easier. So yeah, we can just say like queue equals deck, and then that, and then for car and s queue append car. All right, and essentially we're just gonna loop through this, like whatever, for this in range length s. So we're gonna just take the first character and move it to the back. So q append q pop left. Okay, and then we'll say cur equals join q. And then if cur is less than result, I think that'll work. Yeah, so essentially we're just always doing the same thing and then just return result here. Okay, so do you want to try it on these examples?
This question on these examples, yeah. Let me just write it. Let me just run it in the code. Pretty sure you're good.
Okay.
Submit. Perfect.
Okay, nice.
Yeah, it's a hard one. That one's like hard.
I feel like just coming up with the intuition is kind of hard. But I don't know if there's a linear time also. Maybe.
No, like the solution is your solution.
That was my solution. Okay.
Yeah.
Okay, yeah, and I will say I haven't done this one before, so
Nice.
or at least if I have, I don't remember it at all. So that's kind of cool.
Cool. Thanks, Alpha. Thanks for hopping on. Good
Yeah,
luck with
no
all your
problem.
stuff. We'll do this again. We need to like
Okay.
do more system design ones too.
Yeah,
I
yeah, we
think
could do more of those.
What I'm gonna do is I'm gonna do a long stream where I just ask people system design questions. That one, so I can.
Yeah, I
get
feel like
more-
that'd be good because there's you have so much coding stuff. I think
Yeah.
it also kind of would show me like where I am in system design relative to other people because no one does system design.
No
on
one
here.
wants to hop onto the system design. Only you're the only one who's like asking. me to
People
do
only
system
want to
design.
get interviewed and stuff they're good at, you know.
Yeah, they don't want. They don't want to see.
It's all good though. Happy to fail on stream, you know.
Yeah. All right. Thanks, Alpha.
Yeah.
See you around. Peace. Alpha destroyed those questions. Vanilla, you want to do one? I need to do a stream where I get people that who know system design. So if it's easy for you, you should hop on. We need to get a bunch of. I want to do a bunch of system design ones. Neon, what's up?
Yo, can you hear me?
Yes, sir.
Yes, there we go.
What's up? Have you been on this stream before?
Have I what?
I feel like you've been on this, like we've been on a call before.
Yeah, about maybe a week and a half ago for
Nice.
career advice, and then I said I was gonna hop on the next coding thing because I've been
Nice.
grinding this summer.
Sick. What kind of career advice were we talking about?
I was so I just swapped to computer science and I was trying to get an internship for next summer, so I was just like working on like resume stuff and like what specifically to grind out.
Nice. Cool. So, yeah, how many LeetCode questions have you solved? And could you just give a quick background of yourself? What school you went to? How many LeetCode questions? Maybe your work experience, etc.
Yeah, so for work experience, 0. And then for college, I'm transferring to Cal State Fullerton this fall.
Nice.
And I've been grinding out LeetCode since the summer started, so beginning of June.
Mhm.
I've done about 40-ish questions, maybe 45, 46. I haven't gone into like all the topics yet because I'm trying to, I guess, have more of a DFS approach than a BFS, where like I'm grinding out the arrays, two-pointer, sliding window, binary search, hashing, that type of stuff first before I get into like backtracking, dynamic programming, stuff like that.
Okay. So
so-
right now,
Yeah.
okay. So you're going to Cal State Fullerton. What year are you in?
I'll be entering my junior year.
Junior year.
Yep.
So you've just been focused on arrays so far?
I mean, let me see, because I've been following like the neat code kind of like roadmap. Let's see, arrays, hashing, two-pointer stacks, binary search, sliding window, a little bit of linked list, and a little bit of trees.
Okay. So anything arrays is kind of fair game right here?
Yeah, for sure. I'd be disappointed if I'd completely bomb arrays.
All right. Perfect.
I'm by no means the GOAT, but I think I'm a little confident in them, just like a little bit.
All right. Let's get it. So this one is easy to think about conceptually, but what we're
Okay.
doing is we're given an array of numbers with n objects colored red, white, or blue. We need
Wait,
to.
am I supposed to see something?
Oh, sorry. Are you? I sent you the coder pad in the
In what?
in our Google chat.
Oh,
Or
okay.
Google Meet.
Oh, I see it. Okay. I was about to say, holy. Okay.
So we're given an array numbers with n objects colored red, white, or blue. Sort them in place so that objects of the same color are adjacent with the colors in the following order. Basically, we just need to sort the list, right? But we need to sort the list. Let's say yeah, we essentially just need to sort the list. Let's see where you go from there, and we'll talk about other stuff.
Okay. Let's see. I just logged in. Let's see. Okay. Given an array of nums with n objects colored red, white, and blue, sort them in place so the objects of the same color are adjacent. Objects with the colors in order red, white, and blue. Choose 1, 0, 2 to represent color. Add a library. Okay. So 2, 0, 1. 1 goes there. Okay. So 2, 0, 2. Okay, without sort functions. Okay. So let's see. Yeah, so like normally when you do because this is like my first mock, you're supposed to like really like talk out the process first, right? Like what you're thinking, the possible approaches, and like kind of explaining what you think to the interviewer, right?
Yeah.
Okay.
Or just clarify the question. First
Yeah.
step, clarify the question. Let's make sure you understand.
Yeah, okay. So, I mean, it seems pretty straightforward. I just have to be able to sort the array without a sorting function, pretty much, or without like a library or sort function using the library. Yeah. Um. Let's see. Are there constraints for this problem besides the library sort thing?
No other constraints.
Okay. Yeah. Okay. Um. Yeah. I mean, the problem seems pretty straightforward. Um. Let me think. I'd. eh, Hmm. How to sort function. Oh wow. Okay. I'm kind of drawing a blank, but I think I'm.
This is why we do these mocks.
Yeah. No, I know. Like, this seems really simple. Maybe it's just I'm just fumbling right now. Okay. So iterating through 2 0 2 1 1 0. I mean, with extra space, my first thought is to be able to use like another data structure to store the material as I iterate through, or the data as I iterate through. Like for example, I could iterate through once, using like a hash to count frequency. Then I can just return the values. Oh no, but that wouldn't be in sorted order. Because then I would have to sort the values of the hash if I did the keys being 1 0 and 1. So like if I did like hash at key 0, and then in the first example, iterating through, that would be, I would see it twice, right? And then hash at key 1 would be 2, hash at key 2 would be 2 again, but the issue is with this is I couldn't return. Oh, well, hash at key 0. No, I could do that. But that seems like not the right approach though. Hash at key 0, and then I could create an array, and then I would go like hash at key 0, and then I could basically create like another array the size of the input nums. But that's extra memory, and I think you can do it without extra memory for sure. But I'm kind of drawing a blank on that. This seems kind of silly.
So what would be the solution you're proposing is O of n space and how much time?
Yeah, so the time should be O of n as well, because I'd just be iterating through the array once. Well, I guess like 2n, but like simplified to n. And then I would just be iterating through or I'd just be looking up into the hash. Well, yeah, I'd just be looking into the hash really. So yeah, it would be O of n as well. So O of n space, O of n time.
Okay.
But
yeah.
yeah.
Is there a way that we could do this without using extra space?
Yeah, that's what I was thinking. It seems silly to use the extra space. There's definitely a way to do it, but I'm drawing a blank on it right now.
What are some ways that you think like? Yeah, just try to come up with some stuff, and then we can work together to see how we can improve it. Like, what are you thinking right now, or you just have no idea so far?
I mean, because my first thought is to like count each time I see an element, but let's see. Okay, the array's unsorted. Let me think of another test case. Let's see. Yeah, I'm definitely drawing a blank on the extra memory, or not being able to solve it without extra memory. I know it's 100% possible looking at it, like it just seems like the most logical approach, but I'm definitely drawing a blank on it.
What are some possible different approaches that you could try? Like maybe one more. Or I guess you're just saying you can't think of anything anymore right now.
Yeah, wow, I can't
So
believe I'm drawing a blank.
if we
Yeah,
think about it like this, right?
yeah,
So you want the 2s at the end.
yeah.
You want the 0s at the start. So is this a way that, like, we see a 2, we just throw it to the back?
We see a 2, we just throw it at the back. I mean, yeah, if we used a 2-pointer approach. So that's my first thought. Let me see. Okay, so this left pointer here. Oh, why did that? Okay, left, right, and then we can use a 2-pointer approach, I think, and then whenever we see, I mean, I guess a 2, yeah, we could swap it with right if it's if right is less than left, we can swap it, I think. So then this would become, we can swap the elements of right and left, so that would be that 2, and then we'd want to move right, as long as it's not 2. That could be one of the conditions if the right pointer isn't 2. And let's see, for left, obviously we'd iterate it once since we moved it. It's annoying. Okay. Let's see. Left is less than right, so then that's fine. Then move right again. No, because then we lose track of this for the 2. Okay. Oh, maybe we don't move right then. So we move right originally the first time, and it's we left on 1 here. Let's see. Move left. And then we could swap that 2, 1, and then that's sorted. So yeah, I guess it would be a 2-pointer approach then. And that would be well, we could do it all inside the original array, so it would be O of 1 space and then O of n time complexity because we'd have to iterate through.
Okay. Try. What if it was like this?
Okay. Let's see. Left. Okay.
Yeah. Try.
Okay. Like that. Okay. So. Okay.
Let's make it more complicated.
Okay. Yeah. Let me write down some of the conditions. Let's see. If right is if right is 2, if right equals 2, then we'd want to move right because there's no point. Move right. So then, okay, so right is 2. I'd want to move it over 1. And then for left, since left is oh yeah, left is greater than right, we'd want to move left because we know since this condition above that if right can't be 2. So if left is greater than right, oh wait, if left is greater than r, left is greater than r, oh, swap. Okay, we want to swap left and r. So then for this condition here, swap data left and r. So then this would become left would become 1 and r would swap to become 2. And then we'd want to move L once. Okay. So then R is 2. Let's move R.
Okay, but how is it?
Yep.
What's gonna happen here? This is gonna now with your pointer.
Oh, yes, I understand. I see the issue. Yeah, because then left would be moved and okay. So then Yeah, because we need to keep track of left there for the 0 when we want to swap the zeros. I mean, I guess we could just keep moving R, but okay, let me go back then.
Well, R makes sense there because it's telling us
Ye-
where's the next place we should throw it to. That's essentially what it's telling us, right?
Yeah, we want to move the R here. Okay, yeah, so we wouldn't want to move left in that scenario after we swap.
So here. Then you swap the 1 and the 2. Now what?
Yeah, so I don't want to move L because then I won't be able to put the 0 there. So I'd want to move the R in my head. I'd want to move the R to here, and then swap the R and the L.
What if it's a 1? Okay, we swap the L and the R, it's just 1. Nothing happened.
Well, I guess if if the value at left isn't less than R, we don't have to swap. Because then we should know that these are the same values. They have to be 1 if the condition is we're going to move R every time it's at 2. So then we know R is either going to be 0 or 1. And if L is not less than R, then they both have to be 1. So we can just keep moving R because we know these are 1s and the ones after it are going to be 2s. So that will be sorted on the right. And then we can just keep moving R if R is the same, if like they're both 1. And then R will be left on the 0 here eventually.
Okay. How's that
where
final
R-
2 gonna get all the way over there?
Yeah, he got me again. Oh God, he got me again. Okay. 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 Let me think. Okay. Yeah, we need to keep track of both because okay.
So 2 pointers is not working.
Yeah. Okay. Yeah. I guess 2 pointers not working. Okay. I got squat then.
What about a 3rd pointer?
3rd pointer. Yeah. Yeah. That in my yeah. Okay. Let me see. Oh wait. Let's just go back to what the original thing was. Oh.
This is good though, like this solution.
Oh, okay.
I mean, let's just go from here. What about a 3rd pointer?
Yeah. So. 3rd pointer. So I'm trying to think if it'd be at the beginning or the middle. I guess I'll just think about it in the beginning as well with L and C. So okay, because the issue is when I move, I can keep on moving R as long as like this is 2, and then once I get here at the 1, I can't move it again because I need to keep track of this spot specifically because I need to move the next 2 here if there is a 2. So same thing with L is if it's at a 0, I can keep on moving L until it's not a 0. So in this scenario, L is at 1, so I don't want to move it, and then R is at 1, so I don't want to move it either. So I would want to move C until I find a value that's less than L, because that's what I want to swap. So I can move C until I find 0, and then I could swap L with 0's value. So this would be 0, and this would be 1.
What about
And
that
then-
2 right there?
Oh wait, did I skip over 2? Yeah. Oh, okay. Oh, I mean, yeah, I'd want to move the 2 all the way to R. So I mean, I guess if C finds a value that's greater than, oh, why is it color? Okay. I could just swap R. I mean, I guess I could do it that way. But then I run into the issue of if this was a 0, then I don't want to move that way. I mean, I guess I could swap it like that, where if I find a value, I find a value that's greater, I could swap it with R's value. But let me see. So then C is here, I swap this to be a 2. Swap this to be a 1. But then I move C. I find a value that's less, so I swap it with L. And then I'd increment
I think
L.
you should just think of it in terms of like the right pointer is like where we should position the next 2, and the left pointer is where we should position the next 0.
Yeah, I mean, that's what I was thinking. Was the approach wrong? Let me think.
Let's get back to
Yeah, go back to another test case.
two.
Okay, so yeah, so I'd want to, yeah, the next 0 would obviously be where L is, and the next 2 would be where right is. So I see a 2, and I'd want to position it where R is right now. So yeah, so then I'd want to swap C and R's value. I mean, is it I'm swapping C's value? Yeah. Okay, so then let me just really go through it. So I'm gonna swap C and R's value is what I'm gonna do. And then let's see. I'd want to. I mean, in my head, I'm thinking that like when L is 0, I'd want to keep incrementing it until it's not 0, because that's where I want to place the next 1.
Sure.
So, so over here, I'd move C here, because then I'd move L to be here where C is again. And then again, I see a value of 2, and then R, since it's at 2, I want to move 1 left. So then I'm gonna want to swap these values again to. Wait, what was that before? 1, 2. Wait, what the fuck did I just do? 2 and then 1. Okay. And then again, I'd want to move R left 1, because that's where I want to place the next value. I mean, in this example, I'm not really using C though. I'm feeling like I'm not using C. Like I could do everything with just L, but.
You do everything with just L.
Yeah, then I'd swap it again. Yeah, but I didn't really use C in this. I get the point of C though, because I can't lose track of the spot where I need to place the next 0 or I need to place the next 2. Yeah, that makes perfect sense. Okay.
Okay, yeah, maybe try writing something out for a few minutes. We're gonna move on to the next question after.
Okay. So where do I just code it here? So like, then, oh, why am I getting an error? It's giving me like a red error here. Am I doing something wrong? Def solution.
Oh, you're good. You're good.
Okay. So L, I would have started. Oh, right, 0. 0. Length of nums -1. I guess I could do C at 0. And then while left is less than or equal to right. Maybe it's not equal to, but I'll see in a second. Because I'd want to stop. I mean, I think I just want to stop when they're on the same spot. If R is equal to 2, if R is equal to 2, I decrement R, L equals 1. And then if L is equal to 0, I would increment L plus equals 1. Okay, so this is where it comes in, let's see. So I would have C here. All right, okay. So I would move. Well, how do I keep track of C? Because I'd want C to be. It seems like C is what I'm comparing, so I would want C to at least be where L is. Um, so C is equal to 0, L is equal to this.
I see.
Yeah, because C is what I'll be using to compare. So I want C to at least be where L is. So let me run through this. Let me just change
Okay, let's
these.
move on to the next question because I still want to save time for that.
Okay.
It's better to get some breadth over depth now, just to see
Yeah.
where you should go. So we're gonna be given a palindromic string of lowercase English letters. We're gonna be given a palindromic string of lowercase English letters palindrome. So sorry, messing up my language. We're gonna be given a palindrome. We need to replace exactly one character in it so that the resulting string is not a palindrome anymore, and we get the lexicographically smallest.
What does lexicographically mean?
Yeah. Okay.
I've never heard of that word before.
So lexicographically means sorted in the alphabet. So AABB. It's basically alphabetical ordering. So AA comes before BB in lexicographical ordering. Right. If we're just looking at two, what about AB comes before BA, right? So it's basically in alphabetical order, which one comes first? Which of the strings come first?
Okay, so yeah, the left one. Wait. Okay.
So this is the definition. So string A is lexicographically smaller than string B of the same length if in the first position where they differ, A has a character strictly smaller than the corresponding character in B. So you see that in the first letter that they differ, A is smaller than B.
Yeah.
So it's basically just alphabetical ordering. It's just like the more computer sciencey term. You should get familiar with that term, honestly.
Okay.
You'll see a lot.
Because I'm just reading the first test or I'm just reading this paragraph. For example, ABCC is lexicographically smaller than ABCD because the first position they differ in is the fourth character, and C is smaller than D. Okay. Oh, so it's the ASCII value then, right?
Yeah.
Well, yeah, okay. Yeah, I mean, yeah, we'd use an ASCII value. Okay. Okay, let's see. Yes, let me look at this test case. Example 1. So AB. I guess I need to replace one character with a lowercase English letter, so the resulting string is not a palindrome, and it is lexicographically smallest one possible. Oh wow, okay. So it's not a palindrome.
So we just need to find a letter here and replace it with some other letter to break it to turn it into not a palindrome, but we want to replace it. We want to turn it into the smallest.
Yeah, so I get mixed up with palindrome and anagram. Is palindrome the one where you can't in any order or how do I guess
Palindrome reads the same way frontwards as it does backwards. So A B B.
Oh, okay.
Reads the same frontwards as it does backwards.
Okay. So then, okay, that means that we're given anagrams. Okay. For example, ABC's left. Okay, so in the first test case, the B would be swapped. Okay, there are many ways to make. Okay, so is the lexicographically smallest?
Exactly.
I mean, what it like my first thought is I'd always want to replace it with an A, unless I'm not understanding something, but um it's okay, in this we delete. Oh, okay.
No, we
For
just
replace
returned the
one.
output is not. It said if there's no possible way, return an empty string. So there's no possible way to get something smaller than that.
Yeah. Yeah, okay. And then if this test case, if this instead of an A, it was a B, then we could swap it with an A, right? Okay. Okay.
That's what we're thinking.
Okay. Since this was as long as it is not a palindrome. Damn. Okay. So. Okay, let me look at a test case here. So if I just had ACA, and then I wanted to swap it, I would make that A, but that would make it a palindrome. Okay, so it is possible to swap something and still have it be a palindrome after. So in this scenario, I would make C into a B. So I'm thinking I would need a way to how do I implement both at the same time? That's kind of what's throwing me off here. Because I would need a way to be able to make sure that it's not a palindrome, and then also do the lexicographically thing, make it the smallest. Yeah, I'm a little stumped right now as well. Little stumped right now as well. Not 0 for 2. Yeah.
Let's see. So, what are you thinking right now? Like, where are you stuck?
So I'm honestly like
Just
I
write
can
down
I
your thoughts. That's the main thing. When you're stuck, just be like, what are some things you know about the
yeah.
problem right now? So let's just write those out. What are
Okay,
some things
so
like? What are your ideas?
yeah, I mean, okay, so it's possible for a character to be replaced and it still be a palindrome. Replaced and still be a palindrome. So that's kind of important when you're solving the problem. And then also because you're trying to find like the min, I guess like my first thought is in order to do that, you would need to be looking at like the ASCII values of like the characters. But okay, let's see. Like how to check if something's like a palindrome in the first place. Spelled the same way forwards and backwards. Well, that would be a 2-pointer. I think in my head. So I wonder if there's a way to implement that while also doing the lexicographically thing. So okay, let me just look at this test case here.
Yeah, I would try to work through an example.
Yeah. Okay. So then, okay. So L is at A, R is at A. So I guess in this scenario, wait, be the same length. Wait, lexicographically smaller than a string, be the same length. It's the first position. Okay, so in the test case that they gave, where they changed the first character B to A, would it also work if I changed the last B to A? Would it be the exact same? Like, are the answers unique, or is there something about lexicographically I'm not understanding?
Wait, let's see. If you're here.
Yeah. So no, not the R's and A's. I'm saying for this example, it was previously I think like oh wait, let me just copy it. So this was the first test case, and they changed this B to an A, But I'm saying, would it still work if I changed the last B to an A?
Like which one's bigger than the other, or which one's smaller in the alpha, or if we ordered them alphabetically, which one comes first? That's what lexicographical is. So which one would come first if you ordered in the alphabet? You have two options here. You have this one or this one. Which one would come first in the alphabet? Like if you're comparing these lexicographically or alphabetically, let's just say alphabetically, because
Yeah, it would be the top one since it'd be AA.
yeah. Why would it come first?
Because A is the order of A is less than B.
Yeah. So on the first time that they differ, A is larger than it. Yeah.
Oh,
That's
okay.
that's what it means to be lexicographical. But
Okay. Yeah. Okay, that makes sense. Um, let's see. So with that in mind, okay, so then it'd be L that I care about. So if it's A, I guess it doesn't matter because I can't do anything with the A's, besides remove them, to have the answer change. So, like in my head, it doesn't matter if R and L are an A. I still don't know what to do with R. I'm trying to think about that. But so B right now, I can do something with B. Like obviously, I could change that to an A to make the answer different. And since L and R aren't equal, well, then it wouldn't be a palindrome.
yeah, you'd break the palindrome.
Yeah, I'd break the palindrome since L and R aren't equal. I mean, then it seems like every single time I'm either swapping it to an A or I'm not swapping it at all.
I
Because
agree.
I can't think of a scenario where I'd be like, oh, let me swap it to a Y or a W. Like that doesn't make any sense to me.
because you could swap it to anything.
Yeah, because I can swap it to anything. So if it's an A, I don't care about it, and if it's not an A, let me swap it to an A. That's my first thought. And then I can use the right pointer to validate if it's a palindrome or not. That's my first thought. And then that would be an O of n time complexity, because I just have to iterate through. That's my first thought, or that's I guess my only thought.
Okay, run that on example 2.
Okay, so on example 2, yeah, let's look at it. Okay, so example 2, L and R are obviously at the exact same spot. So L is an A, and I'd want to move on, but obviously, I can't since the array is too small. So then, since I never made a change, I would just return an empty string, but I would need a way to like, well, because let's see, so I'm returning a string. I mean, would I be building the string as I go through, like creating like a new string variable? That seems kind of silly too.
Keep exploring. I'm taking a call real quick.
Okay. So if I had like a res array, it seems silly to be building out the string like one by one with like L and R. Well, no, that would actually make 0 sense. I'm kind of stupid. Well, I guess I could just do it just with L. So I'd be A, C, C, B, A. That's kind of dumb. I'm kind of dumb. Let's see. So I move L until then. I move R until then.
I think your solution will work. You're just having trouble handling the last case when.
Yeah, because in my head I'm thinking like it'd be silly to be building out the string using the left pointer the entire time. Like building out a new string. That just seems kind of silly. For the like the memory and stuff. So I'd want to do it like in my head I'd want to alter the original string that I was given. So I'd want to just change that to an. I'd want to just change the B to an A directly, so I would just be appending an A to the B. But in this scenario, I don't want to return if I return the original output array, then obviously it wouldn't work.
Yeah. Okay.
So
So what would happen? Okay, we know this is an A, right?
yeah,
So we can't switch it. So what would happen in our regular algorithm? We just move the left pointer.
yeah, but then it goes.
Like this. Then what? Should we just return empty at that case?
If if L ever goes over R, we can just return empty.
Mhm.
Yeah, I mean,
I mean, it's done at that point, right?
Yeah,
With the loop.
yeah. It would just be done.
So yeah, explore that.
What do you mean by explore?
Or
What
yeah,
do
I
we
guess like write the code. I think your solution works. Let's just make sure it works.
Okay.
Go ahead and implement that. I'm gonna grab something. Just explain your solution.
Okay. Okay, so we need to set up the. Let me pull this down here. Okay, so we need to set up obviously the left and the right pointer. Left, right equals 0. Length of S minus 1. So while left is less than or equal to right. Okay. So I'm trying to think of the conditions of what I would want to do for the left and the right pointer. Obviously in this first test case, I'd want to move. If it's at an A, if L's at an A, then I'd want to move it. And since it should be a palindrome, R should already be at A, so I would need to check R as well. So if L is equal to A, L plus equals 1, R minus equals 1. So then I would move the left and the right pointer by 1. So then next time L is going to be at B and R is going to be at B.
Yeah.
And since we know that L is not A, and that by logic, R would not be A if L is not A.
Yeah.
Then all we would have to do is just change L. And then it would make it not a palindrome. If we changed it to A. Well, because in the test case, this is where I think you'd run into an issue. R, and then L and R would be equal after one iteration. So I guess we could just do a final check if L and R aren't equal after the swap. Then it'd be fine, because this would change to A, and then if L and R are equal, then we know they were at the same spot. Or, I mean,
here we just do if left is
if less, okay, that makes sense. Okay, so then it would just be an else, and then we could just append, I think, that's to append. We'd want to append L. Wait, no, S at L at index L dot append A. But in the scenario where it's just one string,
this resolves to a character, right? Can we do append? No. If we ran this, it probably would. See. Or does it like sneak it in there? No.
Oh, you're saying the append?
Okay, just keep going. S of L dot append A.
Okay. So well, and then we'd want to just return, or like we'd want to break out of this. Well, because we don't need the loop to keep running if we ever append A. Like we're only changing one character, so I mean, well, we would just return S at that point.
Sure.
But the issue obviously arises when we don't ever, well, like when left is less than right. So then I guess we could just return an empty string, I think. Yeah, I mean that's A B. So am I getting error? Like what's happening on the right here? I'm confused.
Like when you're returning and you're returning the wrong value, you're returning A, B, C, B, A, and still a palindrome.
What was the input?
Oh shoot, I didn't run it. My bad. So okay,
Okay,
that's
so
what I
the
mentioned.
append.
String object has no attribute append. That's where I was getting at earlier.
Okay. Oh really? You can't do this? Okay. Wow, I feel silly. That's a pen. Well, can I just like equals? Is there a method that I'm missing here?
Mhm.
I can't just do that?
You could do that. You could do that. But,
Oh.
oh no, it's actually, yeah, you can't do that. String is immutable, so you can't just change it. Do you know what it means by being immutable?
Yeah. Yeah, so yeah, you can't change it. Oh, so I would really need to create an entire variable, like a new string for this? So I would need to create a new string for this then?
Yeah, you'll need to create a new string for it.
Oh, okay. Oh, okay. Okay. So yeah, so then res equals string, and then basically what I would just be doing is I would just be adding the left character in the entire time. So I would just the left pointer's character, I would just keep adding.
How
But
do you add the rest?
yeah. When the code ends though, I would need to add the rest. So if I'm creating a new string, oh, that's really annoying.
Do you know how to do string slicing?
Slice, is that like
Like when you go S, what does this mean? S to I.
S to I? So this should be the right. So usually like I've seen this syntax where it's like from this. So this would be like in the string like ABA. So this will add like if I was here and J was here, it would add this portion.
So it would return this portion as a new string.
Yeah, I think it indexes off 1. I forget
Yeah.
if it's inclusive or exclusive. I'm definitely not super familiar with the syntax.
Okay. But yeah, your solution looks like it works. Like just learn the string slicing is important. So you can move
Okay.
S to L. That like S to L right here. That means 0 to L. So if L is here, it's gonna return you pretty much everything up until L. So it's AB. So if you just do this plus A plus.
And then I need the right portion. Yeah.
If you go L plus 1, so that will take you, because you're already changing L, so it'll take you for the rest of it. So this says from L plus 1 to the end of the array.
Plus L plus 1. Oh, okay. Yeah, that makes sense.
Yeah, something like that. Oh shoot. Yeah, you can't change it. What? Return. Okay, we're returning this. Oh, now I'm already slowing down. We're not printing here. There, you see like A, B, C. If the L is equal to A, continue. If it's not equal to, we need to convert it. So we go S to L. You see where we're going here? So we're going here. Why is this not converting? Let's debug. You go from S to L. You're adding the A. Do I have to do S to L plus 1?
Because this is what you're returning, right? The A, B, C, D, A, and that's like the original thing.
Yeah.
It's not
this is
changing
what
it,
we
right?
have to debug it. Yeah, it's not changing it. So it's A. Oh yeah. Okay, S to L. I think we have to do L plus 1 here. Something like that. A. We do S L plus 1 here. Wait, let me see. Line 54. If SI is not line 54, if SI. Yeah, you're right. Okay, so this was the problem. Is if S of L.
Oh, yeah. Okay. Yeah.
Damn,
That's
cook
silly
two.
me. Yep.
There you go.
Yeah. Okay. That makes sense.
Baconator, thank you.
Yeah. Okay.
As well.
Yeah. This was tough.
Thank you. You got this. Holy. Okay, how was that?
Yeah, I mean, I definitely fumbled, right? I definitely wasn't proud of that, but I feel like at least on the second problem, I was able to like sort of get there, sort of. I need to get more familiar, I guess, with the string slicing. That seems really important. And then the other problem, yeah, I mean, I don't. That seemed like such an easy problem. Like I know when I look at the solution later, I'm gonna hit myself in the head.
Which
'Cause that
problem? The
seemed
first
really
problem?
easy. Yeah, the first problem. Yeah, when I go over that solution later, I'm definitely gonna feel pretty disappointed.
Yeah. Go try it out. It's called like sort colors or something like that.
Yeah,
I
yeah,
think,
but I mean, yeah, for the first mock, I mean, I don't feel good.
Yeah. No, I mean, that's the first time you ever did an interview.
Yeah,
I think the main thing is when you get stuck is just writing down things that you know to be true, and
Yeah.
then working through the examples. I think working through the examples, if you just look at the way AlphaCode did it in the one before, he was really working through some examples to figure out why the solution becomes the solution it is. So for this one, you work through the palindrome and you try to figure out why is the answer A, C, C, B, A. Oh, because like you just work through the example and really try to figure out how you'd convert the input to output or why that
Yeah.
output is specifically that result.
Yeah.
I think that's what got me better at LeetCode. That's sort of it's hard to do, like walk through all the examples and work through it. You just want to jump straight to coding. You maybe have some thoughts you want to start going through, or you just look at the question, you're totally overwhelmed. But I noticed if you just take the time to walk through some examples, you might think of ways to unblock yourself. So that'd be like my main advice here. Is to
yeah.
just-
I normally draw it out on like XeCal, but like on the first problem, like I genuinely had like no thought.
Yeah.
I felt lost.
And then the other thing is familiarize yourself more with the Python functions. So
Yeah.
understanding the slicing and all of those different string operations and array operations, just make sure you know those ones front and back. And that's a lot of just practice though. So
Yeah.
once you practice, you'll learn the string manipulation and different things like that, and it being immutable. Because at one point you did like dot append instead of changing it, and then when you changed it, it complained because it's immutable, and then finally we led to this approach of just recreating it. So yeah, I think small things like that, if you went into an interview and you're messing up on that, it would be more of a negative signal.
Yeah.
Because
Yeah,
it
for
would be
sure.
like, oh, they don't understand the language that they chose, kind of thing.
Yeah.
But
Yeah, I get that.
I think with the algorithm stuff, you're making good progress. You're coming with some good approaches. More of the red flags would be like some of the like the language related things.
Yeah, for sure. I mean, I get
Yeah.
that.
But once you handle that, you should be good. But yeah, overall, I think you followed a good process. I would just like work through some examples to just figure out, like, have a clear idea.
Yeah. Hopefully I do better on the next one.
Yeah. Cool. All right. Hit me up.
Yeah. Thank you very much. Thank you. Have a good rest of the stream.
Thank you. Let's see. Who do we got next?
Yo,
Yo, what's up? How you doing?
good. How about you?
Doing good, doing good. So we're been streaming 8 hours now. You're pretty much.
It's kind of
We're
crazy,
four
dude.
people. Yeah, you want to give a quick introduction on yourself?
Yeah, sure. I guess I did this about last month ago. Like I did a mock with you, but
Oh, really?
I'm a student. Yeah. So
Oh yeah, I
I'm a
remember you
mo-
now.
Yeah, the SpaceX kid.
Oh yeah.
Yeah. So yeah, no, I'm a more CS math student, recent grad, and I pivoted from pre-med to CS and math.
Hmm.
Yeah, that's kind of it. I interned at two tech places, John Deere, and then recently Samsara. Yeah.
Yeah. Oh, this is cool. And you said that you wanted to. How was the SpaceX interview or whatever? You end up doing that?
Dude, yeah, they flew me out. It was on site. I can't disclose
Yeah,
like
you-
specifics.
Yeah.
But yeah, because of the NDA. But I mean, what I can say, it was hard,
Yeah.
and that's kind of what it's like online too,
Yeah.
or what most people say online. But yeah, no,
Yeah.
it was a hard on site, and it was kind of long.
Yeah.
But yeah, it was fun though. It was fun.
Like
They asked
how
me
would,
some-
how would you prepare for it again? Or would you study more data structures and algorithms, or would you study other things?
Dude, I think the only way you pass SpaceX is if you just do a lot of projects and know a lot of technologies in depth. Like it's not even like lead code. I feel like the lead code is like the DSA stuff they test you on is not too difficult.
Mhm.
So if you just paid attention for like one semester in your like course, you'd be fine. But like they asked me a lot of questions on like technologies and stuff like
Yeah,
that.
I see.
I wasn't prepared for that.
Cool. So for this one, you want to do a system design interview?
Yeah.
Nice.
Yeah.
Finally, something different. This is gonna be fun. 'Cause I was spamming the leak code, and this is gonna be somebody different than Alpha doing the system design. I'm gonna do another stream where I just get people doing straight system design because I feel like that's where people have the most gaps, and we can learn.
Yeah.
We can actually have the most juicy conversations.
Yeah. How will I?
I sent
I'm
it to
sorry, I
you in the Google Meets.
Oh, okay. Sorry, I wasn't looking at the chat. Cool. Thank you. Appreciate it.
So just tell me up front, like, what system design questions have you already solved?
Dude, I haven't. I've looked at the URL shortener one. That's it.
Let's see. Okay, so let me think of one. Okay, let's just go with a classic one that a lot of people should start off with. But let me think. Let's do. Okay, zoom in. Let's design Yelp.
Okay. Oh, all right.
So I'll just leave this out there and drive the conversation.
Okay. Let me. Okay. So it's in the drawing tool, right? Okay. Where? Sorry, I'm not familiar with the. Okay. I think I can kind of typing. Okay. Okay. I can type here. Sorry, I wasn't familiar with the
I
drawing.
don't see you typing.
Can you see the text icon?
Yeah, type all the way up here.
Oh, I got you. Oh, okay. I didn't realize I could zoom out and stuff. Okay, cool. Cool. Okay. Nice. All right. So I guess like from what I've seen, at least of how other people recommend to approach the system design is they want you to first talk about like some of the functional requirements. So yeah, and I'm also not too familiar with Yelp either.
Mhm.
So it'd definitely be nice for me to just like iron out some of the requirements. Is Yelp the food rating, the like restaurant
Yeah.
rating thing? Okay, okay.
Let's just talk about it in this case of you just want to find restaurants. It allows you to discover restaurants. It doesn't need to be. We don't need to add the ratings like 4 or 5 star. But pretend
Okay.
we want to look for restaurants around me or sushi or whatever. It just shows me local businesses. It's basically a business directory.
Okay. Okay. Cool. So yeah, okay. So the first thing is that I guess like from a user perspective, you want to discover restaurants, right? So we need, I guess, some way to like catalog, like store restaurants, maybe restaurants nearby, filter stuff like that. But like from like a client perspective, client slash user perspective, you want to be able to like filter plus find like nearby, not even nearby, just like places in general, and then the filtering could take part of the places. Aside from that, so that's like the main thing. Aside from that, maybe there's also like a business perspective too. So like maybe like businesses should be able to add their place to website.
Mm-hmm.
So like that makes sense to me. And then also like the verification too. We don't want a lot of like random verification, like uh verify the business exists plus is real. Like I don't know, is real. Like we don't want a lot of like spam and users. And maybe we could talk about like if like this is still like is this still an assumption? I guess in this problem specifically, would you want me to kind of address that, or would you say that that's like a nice thing to talk about in the
It
future?
might be a nice to have. Could you just quickly iron out what we mean by this? Like, let's be more specific here. So
Oh, the client user perspective. Okay. So yeah. So I guess like a user. So they should be able to like log in to website and kind of how I imagine this is like on the homepage. There's some sort of like feed of um, like places, like restaurants, for example. And then from there, I can imagine like the user like can like continue to filter, right? Based on search, uh, like proximity, and then like type of food. That's kind of what I'm thinking right now. Is there
the users
I
can
guess is there like
filter
a
based on search. Users can filter based on proximity. Okay, yeah. Essentially, just users have different ways of filtering.
right? Yeah.
Or filtering down the data. They have different ways of search. Okay.
Hmm.
Yeah, that makes sense.
And then I guess we don't have rating, so that's out of the picture. Trying to think of anything else that user. I mean,
We could
like
talk
I
about it
guess
if we
yeah.
get there, but yeah, I think for functional that's good.
Okay,
Let's move
and
on to the
then
next one.
yeah, and then the non-functional requirements.
Just write it down here. It might be easier. Down here.
Oh yeah.
Sorry. Thank you. Just for
Yeah. There we go. Bang. Is that good?
yeah, that's good.
Non-functional requirements. I guess yeah, the rating, the nice to have. And let me think like in terms of like like latency? Do we need like super low latency stuff? I don't think so. It would be nice, but like
Well, first
low.
off, what are non-functional requirements?
Yeah, so I'm thinking these are like the functions that wait, sorry. Sorry, I had to close my door. These are the things that would be nice for a user to have and for our app to have, but are not like directly like impertinent to the actual like everyday scenarios
Well,
of
that's the nice to have here, right? Isn't it? What we're talking about? Like,
I guess like
how would you explain non-functional?
yeah, I guess like the one example I'm thinking of is like in the URL shortener, like the non-functional would be like extremely low latency, because there's a redirect happening and you kind of want to make it like as similar as possible.
Yeah.
So, um,
Why is that
I guess like
important?
in the URL shortener,
Or, yeah.
that's because like it's I guess like you want to make it as close to like navigating to the original URL as possible, even though you have the shortened URL. So you don't want your user to like type in this shortened URL and then take forever to navigate. Instead, they could have just like
Yeah, like
done the real
from a
URL.
user, it's not us. Like how I describe it is functional requirements are what does your system actually have to do, right? These are the actual functions that your system has, which is you can view a list of restaurants. You can or business could also add to those restaurants. You can filter, etc. Those are actual things the system needs to do, right? And then
Yeah.
non-functional is more about behaviors or the user experience kind of thing. It's sort of like the ilities they say of like, is it scalable? Is it low latency? Is it reliable? Like reliability, all those different things. This is how does your system behave?
Mm-hmm. Okay. Yeah.
So,
Yeah. Okay. That makes sense. Yeah, that makes sense. Okay, that's definitely a good clarification. Okay, so I guess for non-functional requirements, like how it'll behave, um, maybe like I guess in terms of like I guess the scale, I can imagine like there might be a ton of restaurants or like places that might like add themselves.
yeah.
So dealing with like scaling up from 0 to like all the restaurants in the area, for example.
Okay, let's talk
That-
about latency. Why would it be important to have low latency?
Yeah. So I guess like when a user searches or filters, you want there to be low latency so that way the user's like not like I guess I don't know, like turned away by
Yeah.
by how long it's taking to search.
What would happen if it's too slow?
I think they would just go to another platform or maybe I think they would just go to another platform that's faster.
I mean,
Like Google Maps.
it's a terrible user experience, but worst case is it crashes. Sometimes if some systems, if the API call takes too long, it hangs up. But latency
Yeah.
here is more of, do we really want somebody to go on Yelp and wait 10 minutes for it to show up? Is that reasonable these days?
No, it's definitely not.
Okay, so let's build it so our system has low latency. Can you, but also quantify it. What does it mean for something to be low latency? What do you think?
Okay, yeah, sorry. There's like I remember there's like three terms and they're like all similar to like latency. There's like throughput, latency. I guess like latency in the from a user's perspective is how quickly they get the information they're requesting.
Yeah. So what's a
Um,
reasonable time? Just throw out a random number.
I didn't. I think like under 5 seconds.
Yeah, I would say it's in the
Probably.
milliseconds. Let's say 400 milliseconds low latency.
Okay.
You really want to wait. There's a certain latency that to the human eye, it's basically instant. And it's somewhere, it's either 300, 400. There's a study on it. But essentially, you don't want to say, oh, I want it in 5 milliseconds. But to the human eye, that's not that's not instant. Or that's faster than a human could even perceive it. There's no point in making it that fast. You just
Okay,
need to
that makes
make
sense.
it just needs to look instant to the user. So let's just say under 400 milliseconds. I forget what the exact number is. But if you go on Hello Interview, they'll tell you the exact milliseconds. Okay.
Okay, okay.
Are you familiar with scalability? What scalability means?
Yeah, so I think it's like how much traffic your system can handle, either like users or like through like the amount of data it can process, or like that's how I think of scalability.
Yeah. So, do we want our system to be scalable?
You definitely, yeah, we definitely want it to be scalable. Um, scalable. We definitely want it to be scalable. Why can't I type? And the reason, okay, sorry. We definitely want it to be scalable because like when we add, when we like when there's more restaurants appearing around the area, etc., we want to be able to like properly scale them, and so that way like uh, like we don't want to have to like do like giant data migrations from like database to database, something like that. And also like if there's more clients that are querying our website or our service, we definitely want them to um, we definitely want to be able to support like more users.
Yeah, exactly. We wanted to. So how would we support? Pretend pretend we have, and this is a regular scale. Right? Pretend we want to support 100 million active users, or 400 million active users.
Okay.
So let's just say we want it to be scalable, and then we'll talk about how you're going to design that after.
Uh oh yeah,
Go
sorry,
ahead.
go ahead. Oh, okay. So you want me to figure out like a way to like scale to 400 million active users? Is
Well,
that
we'll
kind
see
of
when you build your high level design, or you build architecture. I'm gonna test you, or I'm gonna test it to make sure that it could support 400 million active users theoretically. But let's just say we want it to be scalable,
Mhm,
support 400 million active users,
mhm.
and then
Oh, okay.
and then are you familiar with availability and yeah.
Oh, yeah, yeah. So okay, yeah, I remember like the 5 nines um of availability, but yeah, like that's like the
What is
amount of
that?
wasn't it like the 99.999? It's like how how I don't know how to say how much like the percentage of time your
Okay.
system is up or guaranteed like to be up and running, like basically it basically doesn't crash or something like that.
Yeah. I mean, that one is, I guess that one's a bit less of an interesting concept because of course you'd want it to just be running as much as possible. But we'll
Yeah.
see when you design. But let's just say we'll talk about this. Of course we want it to be reliable, and there's multiple. I want to just make sure that your system is reliable.
Okay.
We want it to also be fault tolerant. Do you know what fault tolerant is?
Is that either like natural disasters or something happen and then like or like errors, like user prone errors, like can't um can't trigger that? Is that what it means? Like handle those
Yeah,
gracefully?
fault tolerant is, well, you're gonna be designing a system here. One thing would be there's no single point of failures and things like that. So this helps with reliability. That means like reliability, right? What does it mean to be reliable? That means it's always up. It's hopefully you can get to 100% uptime, right? But what does it mean
Mhm.
to be if something's up? You have a distributed, or you have a system. Some things are gonna fail. If
Yeah.
one thing fails and it takes down your whole system, is it fault tolerant?
No, definitely
Yeah,
not.
yeah. And if it's not fault tolerant, if it just breaks, if one thing breaks, it's unreliable as well. So,
Mhm.
yeah, we'll talk about that. And then one thing would be, yeah, we would want it. I'll just say right now, we want it to be available. As in, it's kind of similar to reliability, but I'll just remove reliability right now. We'll just say we want it to be available. We want it so that whenever you go into your, like, whenever we open up Yelp, we want to make sure that it's online, right? We don't want the case where where it's being down. So
Mhm.
let's just say let's just look at it that lens. We want it so that when we open up our app, we always get some results, and we can
Okay.
always use it. We don't want to just show them a screen like we're down, come back in a few hours.
Yeah.
Okay, so now what? Now we have the functional, non-functional requirements.
Yeah. Now I think we would probably go to like some sort of like high level design. Also, like, sorry, this is like a general question of like
Sure.
just system design.
Mhm.
These non-functional requirements kind of seem like generalizable to like a lot of different problems. Would you say that that's the case?
You'll often pick from the same set of 6, 7, or 8 non-functional requirements, but they'll differ. The non-functional requirements, depending on the problem that you're given, are going to be different. So, for example, if I'm designing lead code, some of the non-functional requirements that we'll care about more is we'll care more about security, because we're going to be somebody's going to be submitting code and it's going to be running on our servers. We don't want to be running code that's not good, right? So we want security is more important in that case, right?
Oh, okay, I got you.
Designing Yelp versus designing something like Ticketmaster, people are competing for the same ticket. You don't want to double book. You give the same person the same ticket. So there's different non-functional requirements. So it depends on the problem, but I would say there's like a set of 10, less than 10, maybe even just 6 or 7 non-functional requirements that you would just pick out of those. But every problem is different.
Okay, that makes sense. Yeah. Okay. Yeah. Let me get into the high level design.
One thing that is one trade-off that you have to make in a lot of them is consistency versus availability.
Oh, is this a CAP theorem?
Yeah, exactly.
Okay. Yeah.
So that's one thing. So depending on the problem, sometimes you prefer consistency, sometimes you prefer availability. In CAP theorem is versatility in a system with partitions. In a system that's partition intolerant or something.
Yeah.
But anyways, I'm telling you upfront that we want availability. So yeah, let's just move on to the high level design then.
Okay. Yeah. Okay. Let me see. Can I draw a shape here? Is that okay? Let me draw a different shape. Okay. I guess like the first, like kind of high level, I want like I'm just gonna like we have our like client over here who's like requesting something, and this is like very general. This is still very general. Who's requesting something to our server, and then I was kind of thinking like we can later split up the different actions in the server, but for now I'm just gonna like try it out here. Who request some action, whether it's like filter, populate like the homepage, etc. And then lastly, we need we need something to store everything, right? So and then this we can imagine as like partitioning like both ways, or not partitioning both ways, but this is querying both ways. So we have our like some sort of database here.
Yeah, this is
And
the DB.
yeah. Yeah, and so this is kind of like this is very generalized, right? And it's definitely not like it would accomplish like like some of the stuff, but then obviously we want like it to be available full time, right? And stuff like that. So kind of what I'm thinking here is we can start from the front, like the client perspective, and then we can kind of work our way back all the way to the database, like picking like our database and what sort of like how we want to store our data in that. So starting from the client. So the client has kind of, it seems like from our functional requirements, the client can do kind of essentially like one action. I want to say there's like a filter action, right? So there's like there's the initial load, restaurant load onto the feed, and then there's a client search. So we should have like some sort of like search, um, some sort of like search microservice, or
Yeah.
a service that can handle like straight up just searching and filtering.
Also, one thing I'll say is let's just assume all of the business data is in the database now.
Okay.
You don't have
Yeah.
to worry
Okay.
about
That makes
part.
sense. Okay. Cool. So yeah, we should have one sort of microservice for searching, and then can I copy that? Yes, nice. And then one for like loading. Oh man, loading places onto home screen. So this is the initial render, and then so now our client can do one of two things. It can search, it can filter, and yeah, it can filter, and this load thing will also happen simultaneously, and also these are all querying to this database. I think from my perspective, these are the only two actions I need to account for. I'm saying that I'm assuming that like the search is, taking into account the proximity, the filtering, like all of that. I'm just gonna say is a part of search, and that can be on like one single node.
So we're
What are your
loading.
thoughts?
So okay, can you just let's walk through a client interaction. Pretend a client requests a like a list of restaurants. I want
Mhm.
pretend the client requests a bunch of Mexican restaurants. Can you
Mhm.
walk me through the flow here based on how you architected your system?
Yeah, so initially the client will load onto our Yelp clone, and then we will basically load them, like give them like a set of places, like almost like a feed on their homepage, and then they click the search, and then the search like Mexican restaurants, and that will filter by like name or like proximity or whatever else they wanted, and that should go by the top via the top flow, and then that will like, instead of having like that initial feed, then it'll now be like a
Pretend they
curated.
don't have an initial feed. The first thing that they do is they just have a list and they could just search for. Let's trim down the scope where they just search for food category, right? So they just have a search bar and they or a drop down and they have a bunch of options. It's like Mexican, um, Chinese, etc. And then they
Uh-huh.
just choose one. So what happens there now? Could you explain it deeper? So what happens when they click search? Pretend they search that and then they click like some search button.
Okay. So I see. Is this like do you want me to talk about like the type of request and like what
Yeah,
that's doing,
exactly.
or?
That's important. Yeah, I want to make sure. Yeah, what happens here when you? This is the UI.
Mhm.
Yeah, could you just walk me through that? The server. This is the UI. They
Yeah.
click the search button. What happens in your system now from the client and then to the server and etc.
Okay. Yeah. So I'm thinking that. So this is definitely. I'm thinking like some sort of like REST. This needs to be some sort of like REST API. Um, and like specifically like a get here. I don't think we need like a WebSocket or something complicated. We're not writing to a database either, since that's already populated.
Mm-hmm.
So this needs to be. So we'll send that, and then we also need to send in the payload. We need to send like filter slash type of place. Um, yeah, so this needs to be in our payload, so that way we can on our database, pick like if we had SQL, for example, we could like do like a select and then by restaurant, select type restaurant or something like that. Um, yeah, I think this should be our like at least our API for search or filtering.
Mm-hmm.
Um,
So okay, they
yeah.
make that API call. What happens?
Mhm.
What do they pass into this API call?
This would be like the filter param. So like I guess from the drop down. So what am I thinking? From from the drop down, the setup choices, like the set. It could be either a set. Let's just say one of the choices. Like that should be what's passed in.
Can you be more
I'm trying to think.
specific? Something like this. You want to get REST API, right? So
Yeah.
how do you usually structure a get request? What would that look like? It would be, yeah. Be more specific because right now it's like we have filter, we have a drop down. What's actually gonna? Could you just actually write out the path that we're gonna hit in the query parameters?
Oh, I see. So it'd be I don't know if this is right. So it'd be like domain slash get. Is it domain slash get or domain slash filter slash, and then the payload? What's in uh, food type? Something like that.
Here, one way that I'll show this would be like, usually you'll get the rest, the, you should look up like the format of how to do this, but it's usually like restaurant. Should spell that wrong. Restaurant, right? Should spell that wrong again. Whatever.
Yeah, restaurant's like a weirdly hard word to spell. I don't know why.
Make sure to spell that right. Oh, I messed up with that. Holy, spelled that. Okay, restaurant, right? So we have our restaurant. We have our get restaurant. Restaurants.
Mhm.
Right. And then, are you familiar with like query parameters? So at the end, you write query parameters.
Is it? I know it's in the brackets, right?
Yeah, usually you can just be like food equals like food.
Those are like the dynamic stuff, right?
Yeah. So
Oh, I
something like
see.
that.
Okay, so it's a question
And then
mark.
we could just
Okay.
be like food equals the food type they selected. This, or you could even be like, this is an enum of Mexican, Chinese, right? This tells me clearly that you're making a get request to restaurants,
Mhm.
and you're searching
Okay.
for the food.
Yeah, that
Okay.
makes sense.
Now we send that get request, and it hits the server. What happens?
Yeah, from a server's perspective, I think there should be. I mean, it needs to query like the database, right? So I guess this is where we talk about like if it's like a SQL versus no SQL database. Is that what you're getting at here, or is there like some like should I walk through like actual like script code on like what's
Okay,
running on the server?
walk at a high level. What happens at the server when it gets this get request? Yeah, including hitting the database, but it needs to do other stuff too, right?
Yeah. Yeah, I might here. I might be. Let me. Okay, so the get request hits the server.
Mm-hmm.
The server needs to log like it needs to first out separate like what like the payload needs to take out the payload.
Exactly.
After that, it needs to at least connect to the database, and then it needs to use that payload param to find the specific like tables or like rows that have the query param in there, and then it needs to like aggregate that all to maybe like a list or something, and then return that into a JSON, like into some sort of JSON format, and then return that back to
Yeah.
the client.
Yeah, something like that. I would say first the server gets the get request or gets the request. Like you mentioned, it needs to extract the data out of the payload. So figuring out the food type that they search for. Then in some cases, first off, in some cases they need to authenticate. If it's not authenticated, or if it's good, usually you want to authenticate, otherwise you could just spam your server, or
Mhm.
and if you want to hide other features, but essentially first authenticate if needed. Let's say in this case we don't need it. Take the data out of the payload and parse it. Then you should probably validate that that payload is what they say or is correct, because if it's not correct, then that's an issue. So pretend that it's not correct. What would we tell the? What would we respond back to the user?
I'd probably respond with like some sort of like, oh, there might be some sort of like error code for this. I'm not really sure.
Yeah, are you familiar
Um,
with the different status codes?
I know. Okay, I know 300's reroute just from the tiny URL. 400 is like not found, so we could
Yeah.
return like a 404. Is that what we're saying here? Or like some sort of like
Yeah.
400 something.
Well, there's different status code, and each one has signals to the client a different thing. So there's 404, 401s, 500s, right? 300s. So usually 400s is user error and 500 is server error.
Okay. Okay.
But then
But
there's
in
like
this case,
different ones. Yeah, go ahead.
okay. Oh yeah, I was saying okay, so if we're using like if it's a choice between like 400 and 500, I feel like maybe this should be a 400 just because like it was the client that didn't
Yeah,
select the right
yeah,
place
exactly.
or
So yeah, we'd validate it for 400. So we'll just send 400 malformed request. Why do we send back status codes to the client?
I guess it's so they can debug on their end so that
Yeah.
they don't have to like they don't have to go into the server or anything.
Okay, yeah. So basically, we parse the get request, and then we validate it. We return
Mhm.
400 if it's malformed. If it's formed correctly, we use the payload in order to query the database,
Yeah.
right? And when we query the database, we just return those results to the client. So that's what I would have expected you to say there. That's that, and you were close, but yeah, I'd have to look back on it. But
Yeah, that makes sense. That makes sense.
okay, let's just say we have this, right. We're able to perform this get request and get the type of food.
Mhm.
Um, Now we're handling our functional requirements. Let's walk through the non-functional requirements. What would cause this to be low latency?
Definitely like we definitely won't be handling like a ton of traffic. So if there's like if there's a ton of traffic, all of a sudden our server will be overwhelmed, and then our queries won't be processed as quickly.
Yeah.
So definitely like scaling.
Okay.
And this is either like horizontal or vertical. I guess I prefer horizontal. So we could just build out more. We can just build out more servers literally for this
Yeah.
for the search functionality.
Okay, let's talk about the database quick. How are we going to be storing? Pretend we want to be able to search by food, and we want to be able to, let's say this is what we want to return. Or, yeah, how would we, could you data model this a bit? Like, do some data modeling? How are we going to store the restaurants in a database?
Okay,
This is a
yeah.
hard part to
Okay, I guess like the two things I'm kind of, I mean, so it's like a choice between SQL and NoSQL.
Or no, I'm talking about more specifically, how is the data table going to be structured? Like what is the table going to look like? You know
Oh,
what I mean?
okay. Yeah. So I guess it should be like,
Like design the database schema.
mm, uh, okay. This is where not gonna lie. I do have a little bit of trouble with this, but I guess like from what I understand of SQL, there needs to be some sort of like, or I guess a table. There needs to be like the attributes of the place. So we need to store some sort of attributes, and then we need to also store the name. So I'm thinking like the name. We need to have like a name. We need to have a type of food. Maybe like a location. There's no ratings. What else? Search proximity. So yeah, I think these are like I guess for the three filtering, we need to have name, type of food, like genre of food, and then like
Yeah,
location.
okay. Let's think about. Okay, so I would be more specific here. As similar to like the API, actually do it like this. So what is it? What would be the names of the actual columns? of the database? And what would be the name of the table?
I see. Okay, so I think these should be the names of the columns, like the three things I prototyped here.
Mm-hmm.
Those should be
Okay.
the column names,
Sure.
and then the name of the like table
Mm-hmm.
would just be like restaurants or something like that.
Sure. Okay. Okay. What's the data type of each of these?
Oh, I see. Okay, yeah, this is so name is a string. Type of food should also be a string. Location, we could do like honestly, this should be like a. Could we do like a int like a tuple int of
Sure.
latitude and longitude, something like that?
Yeah. You're writing something?
Okay.
Okay.
Oh yeah. Sorry. Yeah.
Okay. Um. Okay. What about primary keys and foreign keys or any keys here?
Okay. Primary keys are what you filter on. Foreign keys are like what you use for like join statements, right, between tables. Um, do we need that? I guess like if somebody does like two things, then we would. No, I don't know if we need any of that.
Well,
Or I guess
every single table should have a primary key, right? What's a primary? Do you remember what a primary key in a database is?
that's what you like search on, right? That's like how you, I guess, index it, and yeah, I think that's how you like index it.
Well, yeah, like what are some properties of the primary key? Does it have to be unique across
Yeah,
all of
yeah, it
them?
definitely has to be unique.
Okay. So which one would be our primary key? The name? Or no?
No, I think we should have like another thing like ID, and then that's just like some sort of unique int. I think like
Okay.
with like fast food restaurants, yeah, you can have like multiple locations, and then
Okay.
it gets.
So that's going to be the primary key, and the name is just a string. It's not a primary key.
Yeah.
Okay.
Oh, okay. Yeah, I don't know if you could see what I'm typing, but
Yeah, I see it now. Okay. So this is our setup. We have an ID, an int, a name. We don't really care about typing for location right now. I removed that constraint. We're just searching by type of food. But okay, pretend I had 1,000,000 restaurants in my database, and I performed a query on it by food.
Mhm.
So will that at all slow down? Will that at all scale? Pretend people just keep adding restaurants, adding restaurants, adding restaurants.
Yeah. So yeah, that definitely won't scale just because like yeah, it just won't scale.
Why?
Just because we will have like multiple types of restaurants, and if somebody's doing like filtering like one type of restaurant, it'd have to like go through the entire database and pick out those specific ones. Um, I guess like one way to do it is like you could like shard, but like you could do that by like database type or not database type, sorry. Food type. So like you could have like Mexican restaurants, for example, in one database. So you can already pre-sort, and then you could like in the case that there's a complex query, like there's multiple food types, then you could do like a join of those tables.
Mm-hmm.
I don't know if that's one valid.
If I search for, it just adds a bunch of complexity. I think because then we have like 6, 7 different servers, and all of them are only hosting. One's like server for Mexican food, one for Chinese food, and then we can't leverage SQL features because they're not under the same database anymore. Like we can't just be like aggregate me all of the amount of like what the moment we need to search between two of them. Like I think with only 1,000,000 restaurants, we could store it all in the same table. The storage is not a problem. I think the main problem that I'm trying to figure out is, will our query be slow if this is how our database is structured? If this is how our data is modeled? Because what happens when we search the database? If this is our only primary key, we pretty much have to do a full table scan on our database to find all the ones type of food. So we have to read in a million rows and then just pick the ones that are Mexican. What's a way to speed that up?
Like, are you talking about like restructuring the table, or like is there like a way we can cache queries? Yeah, because like, okay, we can't use food type as our primary key, so because it's not unique. Yeah, the only thing I'm kind of leading on is like caching like queries. If
Caching?
we query
Okay.
me, yeah.
Are you familiar with database indexing?
Not that deeply.
Yeah.
No.
So one way to speed up the queries would be to introduce an index on like that on that column.
Sorry, can you say that one more time?
One way to increase to make queries more efficient is introducing the indexes to your tables. So what an index would do is it will essentially allow you to search faster in your database because it keeps the data stored in a sorted order. So it's similar to like an appendix. So it basically builds, it requires more space because now you have this index. But how you could imagine the index is it's sort of like a reverse lookup.
Mm-hmm.
So if you look at appendix in a book, so how that would look like is essentially what I know is it will store the food in order, but in a different data structure, and that allows you to find all of the same food a lot faster.
Oh, I see. So it's like going on back to the Mexican like food. Would it be like my index from like 10 to 15, like that's all like Mexican places? Is that kind of
essentially it will essentially put all the Mexicans beside each other in some sort of data structure.
Oh, okay. I didn't think about that.
Yeah.
Okay, yeah, that makes sense.
Like 2, 3. And now when you look for Mexican ones, they're all grouped together and you don't have to do a full table scan.
Yeah. Okay, that's cool. Okay, yeah. I definitely.
So when you create a primary key, it's essentially making an index on your ID. It's building an index there. And the reason it's building an index there is so that you don't break the primary key constraint of having multiple keys with the same value.
Okay, do you think I should have had like, could I get rid of the primary key and then put it on the type of food, or is that not like you can't do that?
Well, the type of food is not unique. Primary key needs to be unique, so that's one other thing.
I see, but we indexed it on primary key, you know what I mean? So how does that work?
Well, primary key, that was just a small implementation detail that I mentioned. That when you create a primary key, it essentially creates an index on it as well. And most of the time the indexes are B trees when it comes to Postgres or whatever. But when you have a slow query, a lot of times you just need to figure out if I can introduce an index to make that query faster.
Okay, that makes sense. Yeah.
Okay, let's talk about one more part. Okay, now pretend we add an index on the type of food and the queries are happening really fast now.
Yeah.
Let's talk about now the database is not the slow part, but we just have way too many clients using the one server. Now the server is being overloaded. What would happen there?
Right. Yeah. So I guess this goes back to like the horizontal scaling. So you can horizontally scale, so you can have multiple server instances, and then I feel like I've seen this a lot, but a lot of people just say like just put a load balancer in front of those server instances, and so that way it could like route traffic to the server that's like not being used. Yeah, I guess like that would be one possible solution.
Okay, could you augment sort of your system here so that it has a load balancer? What would that look like?
Yeah. We have all of these. Some like this. Like, oh man. Yeah. So go to this load balancer. Oh. And then this load balancer can like route traffic to the different servers, and then those servers can query the database. That would be so something like this.
Okay. So how is this going to improve the system?
I think this makes it more reliable and scalable.
Why?
Reliable in the sense that now like we're not relying on like one single server to fulfill all our requests, and then scalable in the sense that we can like scale the server instances in proportion to our like client demand, so we can always like spin up more, and then the load balancer can always route to like the most available service or server node.
Okay. Yeah, makes sense. Okay, we're running at 50 minutes. How do you think you did? Like, what's your thoughts so far?
I definitely okay. So this is like something I need to get better at. I haven't done a lot of system design interviews, and I guess it kind of showed in like the onsite. But yeah, no, I definitely need to get better at this in general. I feel like I need not really like the high level. I need to get more nitty gritty. So like I think that kind of was clear in the request, like formatting the request that you mentioned, but also in the indexing too. Like I didn't know at all that you could like index. I mean, I feel like I did know, but like I didn't ever use like indexing on like a certain like attribute in the database. So I definitely could have. I definitely just need to like get more nitty gritty so I can explain it at like a still a high level, but like a fairly like technical high level, if that makes sense.
Okay, yeah. I think you need to just follow us when you do these. Probably comes with more practice, but follow a specific order that works best for you. So the way I like to do it is talk about the functional requirements. Then non-functional. So I'll write this. The steps here. You'll see up here. Functional, non-functional. Right. It's been a while since I did this. Non-functional. Then I'll talk about the APIs. So what are the APIs that we're gonna hit, right? Then I talk about the data models. So that's kind of what you're doing here is like, okay, we need a GET request. Oh, and then we need a POST request for them to add businesses, right? And then I talk about the data models. Or I think it depends. Usually I talk about the data models first. So when I talk about data models, I'll just say, oh, so we're building Yelp. So what we need to do is have restaurants. Like we're going to have a table for restaurants. We're going to have a table for users, maybe businesses. So you see what I mean? So I list out the data model. Then I list out the APIs. And a lot of times I list out the data models just briefly like this because we'll get deeper into it. Then I list out the APIs. And you should be very specific in how you list out the APIs. I want to get requests on restaurants. These are my food parameters, or these are my parameters. You need to talk about what's in the request, what's in the payload, right? If it's a post, you need to talk about how the server is going to respond. If it's going to respond 400, 401, 500, you need to talk about you need to actually talk about the response, because those are two important parts. Is it the HTTP verb? The most important parts of the HTTP, I would say, is probably the verb that you're using, the verbs, the paths. So that's the path here. Query parameters. So that allows you to do different filtering. payload. If you're doing a post request, you're gonna have a body that's have a payload, and then like a response, and then some other nice to have is like authentication and stuff. But when you're talking about the APIs, you should list out every single API that you're gonna be using, and then all of these different things. Be very specific.
Okay. Yeah. The auth is that's like authorizing, like checking whether the client requesting the thing is like actually like a real person and not like, so they don't get overwhelmed with fake stuff. Is that what that means?
Yeah. So for example, I tell you to design Instagram newsfeed. How am I gonna
Mhm.
make it so that I see my feed and I can't see any other people's feed?
Oh, I see. Okay. So it's like some user ID or something like that.
So authentication, there's two buzzwords here or words you need to know. Authentication is you are who you say you are. Auth and authorization. So authentication means you are who you say you are. Authorization is how we limit you to exactly what you can see based on who you are. So there's two different steps to that.
Okay. That makes sense. Yeah.
Okay, so I think you just need to follow a good process. I think with the non-functional, you need to just study more on some of the distributed systems theory. So understanding latency and how that affects the user experience. What even is latency? What is the CAP theorem? Why do we have to make this trade-off of consistency or availability? What's fault tolerance? What's reliable? Like understand that theory, because it will show in this section right here.
Yeah. Yeah. That makes sense. Yeah.
Yeah. Yeah, familiarize yourself with the APIs, get deeper in that, as in like the different verbs, how the paths should be constructed, when you should use query parameters or when you should just pass things into the payload, how the responses are the different responses that you're working on.
Mhm.
And then definitely like practice a bit more on the data modeling too. Like be able to
Yeah.
model the restaurants table with a primary key. And you should be very specific too. Like I want an ID and it should be a UUID. I want a name and it should be a string. I want a like phone number and it should just be numbers. Like the format of what you're storing there, because that's important. Like
Yeah.
pretend
Okay,
I'm
that
telling
makes
you to tell and pretend I'm telling you model a person in the database. You should be able to create. You'll be like, oh, I want to model. Like pretend I said, can you write me a data model for a bunch of users in our database? Right. So you need to be able to be like, okay, I'm gonna have an ID for the user, and that's gonna be the primary key. Then I'm gonna have their name. Then I'm gonna have their age, which is gonna be a what's it called? An integer. You know what I mean?
Yeah.
You need
Okay,
you
that
need
makes
to be very specific on those, and then you need to. Our database right here is very simple, but if there's multiple tables, you need to specify foreign keys and. I mean, the primary keys you always have to. I'll always expect you to say a primary key, but if we have restaurants and maybe there's owners, right, and then the restaurant sort of relates to owners, I want you to tell me that there's gonna be an owner field on the restaurant with a foreign key to the owner, if that's the relationship we build. So it needs to be very
Oh.
specific, and you need to get through this fast too. Like we only have an hour.
Yeah.
Let's see.
Yeah.
Definitely understand database indexing and how to speed up databases. So understand how an index speeds up the database, or how an index could speed up queries. So understand like full table scans and how it could be issues and how you can use an index to avoid having to scan the whole table.
Yeah. Yeah, that makes sense. Yeah.
Yeah, I think that would be a start, and then we should do this again some other time. You should message me. Let's do another system design soon. Study up on what I said here. And I think after that, you should be really good for the next one.
Yeah. Yeah. I noticed that like I'm also like kind of slow too. So I definitely need to start running through a bunch of examples so I can get a little faster at these problems.
You'll literally open up an Excalibur and just be like design Yelp and try this again by yourself tomorrow or something, or maybe later today, or take some time off, but just put design Yelp and then try to see where you get to within an hour. That's how I practice.
Okay. Yeah, that's fair.
All right. Thanks for coming up.
Yeah,
Hopefully
thanks. No, that was super helpful. Thanks, man.
All right.
Appreciate it a
See ya.
lot. See ya.
Bye. Bye. Damn, I explained database indexing terrible. Did I get that? Did I explain that right? I'm pretty sure the database index is stored using a B tree. The database index is stored using a B tree, and the B tree keeps things in sorted order. Let's see. I need to warm myself up. It's been so long since I had to look into this. Yeah, okay. Yeah, I'm coming through. So, who was the last person that was here? Yeah. Learn how to learn database indexing to avoid the full table scan. Holy, how long? 8.5 hours? Yeah. It's about to be 9. Yeah, the guy's college student alpha. So, what do you think? What do you think? Is there any coding opportunities in freelance coding, or is it all taken away by AI? As far as I'm aware, 2025 coding is basically full-on startups instead of freelance. Dude, I can't hear you. Are you in the Google Meets? Yo, what's up? How you doing?
Just sorry about that. I'm good. How are you, James?
I'm good. Just grabbing water. One sec.
Damn, this is like an 8-hour, like a marathon, man. You must be exhausted by now.
Yes. I'm pretty exhausted. There's like a couple very small, like I was like a person on the last interview. They had like one very small syntax error, and I was trying to help them debug, and I literally couldn't
No
figure
problem.
it out.
No problem, bro. I appreciate you doing this for the community. I appreciate that a lot about you, James. Thank you so much.
No, like I'm feeling good though. But even like small things like explaining how database index work, I was literally blanking out because it's already been 9 hours.
Yeah, I can imagine. Yeah.
Are you familiar with that stuff?
Sorry.
Are you familiar with that stuff like DB index?
No. So I just finished my first year at Waterloo CS. Like I haven't looked into like horizontal, vertical scaling, etc., and like all the system design questions. Like, is it common in technical interviews, like as an intern?
Really not as an intern, but if you're applying for new grad roles, they might ask it to you, but once you're experienced, they're gonna ask that for you for 100%.
I see. Like for example, like for new grad, like how does it differ, like new grad versus experienced in terms of like the level of system design that they ask you?
So I would say so for new grad, they might not even ask you, but the times that I was asked, they were just asking me very basic, like model the database kind of thing, very simple client server architecture.
Got
For
it.
new grad
So,
and experience, it's more
yeah.
like it's more what you saw earlier. Did you watch the whole video?
No, I didn't
Okay.
watch the entire video.
So the it was pretty much like figuring out the functional requirements, the non-functional requirements, developing the APIs, developing or doing the data modeling, coming up with a high-level design, things like that.
Could I ask you another quick question if that's
Yeah,
all
100%.
right?
Yeah.
Like if I wanted to like pivot towards management, like inside software engineering, like becoming a software engineering manager, how does the ladder look like? Is it like L3, L4, then like how does it go?
You want to be a manager already, or no?
No. I'm talking like 10 years down the line. How does that look like?
Yeah.
Would you know by any chance? Like how does that work?
Yeah. So pretty much when it comes to software engineering, there's multiple levels, and then I'll tell you management. For software engineering, you just start off as a junior, then you go to intermediate, then you go to senior, and then you go to staff. And pretty much at each step, you're just taking on more and more scope and taking more and more responsibility. And
Right.
like you could be working on even harder problems, but usually it's more scope and responsibility as you move up. So for example, as a junior, you probably have very little scope and responsibility. They give you one task and they just want you to execute, right? Then you go
So
to or go ahead.
you're saying post to staff, you become a manager?
Um, okay, actually, let's do the intro and then ask me those questions. I think it's good to have that on video.
Sure.
Okay, hey everyone. So today I have a second year student from the University of Waterloo, and yeah, would you be able to just give a quick background on yourself?
Yeah, for sure. So I'm a second year CS student at the University of Waterloo. I'm interning at a small fintech company based in downtown Toronto.
Okay.
It basically like sells loans. I'm working on a bit of full stack with like Spring Boot and Angular, and just like at implementing new features on the same. I've done about like 184 lead code questions till date. I still wouldn't say I'm really confident, but I'm getting there. Yeah,
Mm-hmm.
that's all from my end.
Okay. When did you start coding?
Me, I think it was like ninth grade. I just learned a bit about basics of like Python.
Nice.
Like learned a bit more about like object oriented programming, and
Mm-hmm.
then yeah, like from there like a bit of full stack, and then yeah, like university I learned about Racket and C, and then second year it's going to be C++ and like data structures. So I haven't taken a data structures course yet.
Yeah, I see. So what was your question? You're asking me what happens when you become a manager?
Yeah. How does the role like vary from like let's say a staff, and then what does the progression look like? Can you become like let's say a VP or director like without being in management?
It's different. It's a different skill set to succeed in the different roles. So there's the individual contributor route. What does it mean as an individual contributor? You're pretty much just writing code, and you're an individual contributor. You're doing stuff like individually. I mean, you work in in the context of your team, but you have like the output that your output is coming from you, versus when you're in the management role, you're not a lot of times you might not actually be directly contributing, but you're working with a team and you're telling that team what to do, and then they're implementing the code, and sort of your work is their work. What they're able to produce is a reflection of how you manage them, kind of thing, and that's more of how you're assessed. Like, how can you tell someone's a good manager? I mean, one way people would say is, how well is their team performing? How good are the features that their team are performing? That's obviously, you could just have a really good team and just suck it as a manager, but that's the main way that managers are being assessed a lot, is how well are they managing the team, and then how do you track a team's performance? Well, what's the output of the team? How, like, if a team is handling a service, how often is that service down? How often are they pushing new features and advancing the code? Does that make sense?
Yeah, thank you so much. That answers my question.
Yeah, and there's different levels of being a manager. You could start off at the bottom level of a manager, where you're just managing a bunch of software engineers, right?
Right.
That's usually level 1. What's level 2? Level 2, you're usually managing other managers. So maybe you have a team of managers, and you're managing those managers, and they're managing the actual software engineers. And then
Got
there
it.
might be a level above that. Maybe you're the director of AI. So maybe you have like your manager of managers of managers kind of thing. You're leading a whole organization, and there could be multiple levels under you.
Got it. Thank
Yeah.
you so much.
And when it comes to software engineering levels, like junior, intermediate, senior, I think the main thing is more. So when you're from going to junior to intermediate, it's pretty much all about execution. So to see if somebody's still a junior is you give them some task, and it's well scoped task, and they still can't finish it in a reasonable amount of time. Usually, you want them to be able to finish tasks in a reasonable amount of time before they become intermediate, and you also want them to do it with not as much guidance. If you have to guide them really hard on every single feature, they're still a junior engineer,
Got it.
right? So I think it's more about just execution and autonomy. When you get to intermediate, it's more about it's still about execution. You still need to execute, but the problems you're solving are becoming more vague. And of course, like, you need to be autonomous, but vague as in there are multiple solutions to solve the problem, and you need to talk with different people to understand how to solve that problem and choose the right one. So it's not just coding anymore, but it's figuring out, like, it's requirements gathering. It's involves some people skills in it. Does that make sense?
Yeah.
Yeah. And then, yeah, in intermediate, you'll start doing stuff like getting on call. You might be asked to do things like or you start thinking about the systems as well. But I think when you get to senior, that's when you have I would say you would have full scope of the system. You're handling everything from on call, right? Taking all the on call issues, not just on call, making sure on call is not noisy. Building out the testing systems so that your system is, like, you can track when issues happen. Architecting the system so that your system is a good system. You know what I mean?
Yeah.
Like, if you realize that latencies are very high, people pretend you're building a newsfeed and the newsfeed is really slow, you can go in there and make that newsfeed faster. So you're working at a different scope than maybe an intermediate or a junior developer.
Got it.
Yeah. Any other questions, or that's it?
No. We can get into the technical.
All right. Sick. So how familiar are you with the other, with, like, the different, like, arrays, backtracking, etc.?
So like not so much with backtracking. I've done like, I would say I know quite a bit of trees, linked list, and then I was recently doing DP. I've forgotten a bit of graphs because it's been a while since I've done like all the like topological sort and like all the like Khan's algorithm and stuff.
Mhm.
But yeah, apart from that, I think and backtracking, like I've done heaps as well. So like apart from like a bit of graphs and like backtracking, I think I should be somewhat. I should have. I should have an idea how to solve the problem, like somewhat. At least I hope so.
Okay, sounds good. Okay, so what we have here is an interactive code editor. We're gonna prioritize working code. What language do you want to work with?
Python.
Okay, sounds good. So I'm gonna post in the very first question. We're gonna be and tell me if you've done this question before. I can switch it.
I have done this before,
Okay.
but yeah.
Let's change it up. I'll find you a good question. Have you done 380? Insert, delete, get random.
Yeah, I did that today actually, and it's subpar too. Like the follow up where you could have duplicates which are allowed.
Yeah.
Like I have a question. Like with a lot of these questions, if you haven't done them before, like it's really hard to go about. Like I don't know how I'll fare against a new question.
Yeah, it's all really about practice and having good fundamentals.
Right.
Because if you look at if you see a new question, what's the odds that question is going to use a pattern that's never been invented, or you've never seen before? It's not a depth first search, a breadth first search, a two pointer, a binary search.
You're right. We can segregate them for sure.
Exactly. But if you don't know any of those patterns, you don't know any of the data structures, you're just not going to be able to solve that problem because you'll have to think about the algorithm on the spot.
Yeah, I agree. Yeah.
Yeah, so it's all about understanding the right fundamentals. Like pretend you're doing math, right? And you don't know how to do derivatives, you don't know how to do integrals, you don't understand algebra. If you see a problem you've never seen before and it requires some of those, you're never going to solve it. I mean,
Right.
it's going to be hard. But pretend you do know how to do those. Would you be able to break it down at that point into something you can solve? There's a question. Oh, can you hear me?
Yeah.
Okay.
Question for me, right?
Yeah.
So I would say I'm forgetting, but like there's like this really great tutorial by someone like I think it's like Scrimba or something like that on React. I think it's like an interactive tutorial where basically you can go on the website and then you can like code up things as he's teaching it. So like it's interactive. So I believe that really helps a lot. And then React's documentation is quite good. I'd say they have like a beginner tic-tac-toe project as well. You can definitely check that out. And then yeah, like once you're done with a bit of like obviously you have to master the fundamentals like HTML, CSS, and like a really strong command of like JavaScript, and then like you basically progress towards like any frameworks like React, Angular, with React being the most popular one, and then backend you can just pick up anything like Node, Flask, depending on like what specific companies you're targeting, or then like just anything in general that you enjoy with. That's from my end.
Okay. Okay, I'm gonna post in the first question. Hopefully you haven't done this one.
No, I don't think I've done this.
So there are n people standing in a queue, and they're numbered 0 to n minus 1 in left to right order. You're given an array of heights of distinct integers, telling you the height of each person. A person can see over another person to their right in the queue if everybody in between is shorter than both of them. So return an answer array of length n where answer I is the number of people the I person can see to the right in the queue. So I'll show you this. So we're given heights as a list, and this is our output. So we just need to return an answer of the number of people the ith person can see. So these are heights. So this person is height 10, this person's height 6, this person's height 8, this person's height 5, 11, 9, etc., right? So person 10 could see 3 people. They can see 6, 8, and 11. I think. Wait.
6, 8, and 11.
Let's see. Oh, we have the list, or this is the. Yeah, so person could, it's going by index. So it's like 0, 1. Are you downtown Toronto?
Yeah. Can you hear it? Should I mute myself?
No, it's good. I live in downtown SF, so you just hear that all the time too.
Yeah.
Is it right outside your house though?
Actually, I'm just next to U of T's campus. Like, there's like one ambulance going in every hour.
So person 0 can see 1, 2, and 4. Can you tell me why?
Person 1 can see 1, 2, and 4.
Person 0 can see 1, 2, and 4.
Sorry. Yeah, person 0. like it has to be shorter than 10, but like wait, it has to be the ith person can see the jth person if I is less than j. That means basically the index, obviously it has to be towards the right, and the minimum of heights of I in j is greater than the maximum of heights of I plus 1, heights of I plus 2. I'm still trying to process this. Like,
Sure.
minimum of heights of I, let's just assume that j is like 6, sorry, index 1, and then I is basically 0. So minimum of 10 and 6 gives me 6, and that should be greater than max of heights of I plus 1, which is going to be max of 6, 8, etc.
Honestly, this is weird to look at. Let's just look at this right here. So 10, what does that mean? 10 has a height of 10. And if it
Yeah.
looks to the right, it could see 6, it could see 8. Why can't it see 5?
uh I'm not sure, like
Well, because 8 is taller than 5. So let's look at it in come to the drawing.
yeah, just a sec.
So we can look at it like this: 10. This is 10. We have 6. 8. 5. 11. 9. So let's just do 10. So these are the numbers, or these are their heights. This one's height 10. This one's height 6. This one's height 8. This one's height 5. This one's height 11. This one's height 9. So we're saying person 0 can see 1, 2, and 4. Like person 0. These are the people 0, 1, 2, 3, 4, 5. Because this guy is smaller than him, he's kind of hiding.
Oh, okay. Okay. The guy is hiding, right?
Yeah, you see, like this guy's taller, so you can't see him.
Right.
Yeah.
And,
Okay.
And person
Who
two
can person
consumer-
1 see? Who can person 1 see? This is 0
Only-
index.
only 2.
Yeah, person 1 can only see 2. So this is 3. So they can only see 1 person. What about this guy?
2 can see 3 and 4.
Yeah. So 2. What about 5?
Can I say that the one at index 3 or 5 basically can see both at index like 2 and 4? But like it can only see like towards the right, right? It can't see towards the
Yeah, you
left.
can only look it to the right.
Yeah, so then that's just 4.
So it's just they could just see 1.
Yeah,
What about
just
person
1.
4? How much people can person 4 see?
Yeah, just 1.
Okay, how about person 5?
0.
Yeah. So you see how we get that output there?
Yeah.
Okay. I'll let you go now.
Okay. Yeah.
Let you jump up there.
So like the first thing that comes to my mind is like this is like a problem of utilizing like a monotonic stack. Like I'm not sure if it's going to be in increasing or decreasing order. So like I'll have to keep appending to the stack and keep popping based on few conditions. Like if probably like that is something that I'll have to figure out. Like if like the height at index at the I plus 1 at index, if it's like less than the last element in my stack, and like so on. So like let me just begin this problem. I'll just like define a stack to be like let's just say I have a stack which is empty, and then let's just like should I just I'll just create a function def
Let's talk about your approach first before you hop into coding.
Okay, sure. So what I'm thinking is somewhere I know for a fact I'll have to use a monotonic stack. So like what I'm thinking is how many times will I have to pop, and what the condition for that would what the condition for that will be. So
So why are you saying we need to use a monotonic stack as well? Could
because
you
we're like
elaborate?
maintaining a particular order, like it could be either decreasing or increasing. and then like we append and like pop from the queue accordingly, so that we can effectively decide like how many people that we can see compared to like a normal stack.
Okay. So let's just do this. Take this array. Like, how would we build up that monotonic stack? I'm not sure I understand your approach.
Um, so like maybe I begin by like what if I'm just thinking like what if I start from the end of the array, like I traverse it in like the reverse direction. I'm at 9. Let's just say I start at 11, right? I basically add like 9 to my stack, so my stack currently contains 9,
Sure.
and then I check 11. 11 is basically this starts from like length of like array minus 2, and then I check if that number is basically greater than the last element present in my stack. So we know for a fact that 11 is greater than 9. In that case, I'm thinking like should I have a no? I don't think there's any need of a counter variable. I probably pop that from my stack. So if 11 is greater than 9, then I pop that from my stack. And then but what do I do with the popped element? Like the effectively uh, what I'm trying to figure. Okay, yeah, another thing, like another edge case that like I can think of instantly. We know for a fact that the last element is always bound to have like can see no one else, because he's basically the guy standing at the front of the queue.
Mhm.
So he can only look forward and there's no one, so it's going to be initialized to be 0. So we
Sure.
know for a fact that a resultant array, the last element is going to be 0. And
Yeah.
then what I could do is or like what if I instead start like from the front of the array, like I'm probably I was thinking of using like a reverse approach where I'm iterating the array like in reverse order. What if I begin from the front and then see, maybe that makes a difference. I'm not sure which method would lead me to the correct answer, but then we can reason through both.
Sure.
So like uh, I'll like inside my resultant array, I'll just initialize that to be like none, and like times the length of the array, and then in the last element, I'll just put 0 there. And
Hmm.
coming to the logic, what I'm thinking is
So what are could you just show that, like, zero, like we're gonna be like a
sure,
bunch of
sure, sure,
nuns
sure,
and the
sure.
result.
So yeah, so like let's just say this is the resultant array. It's going to be initialized by none times the length of the array, right? And then basically I'm going to say res of -1 is basically equal to 0,
Sure.
because that's basically going to be the last element in my resultant array.
Yeah.
And let's just say this is the array as of now, so that I'm not getting an error. Wait, why this is highlighted?
Okay. And then you say we're gonna try going through the front of the array, the back of array.
Yeah, that's what I'm trying to figure out. That like if I think what, like since I've already initialized the last element to be 0, I think it makes more sense to start from the end. So like let's say I start from like for I in range len of array -2. This goes until the 0th index, and then I'm decrementing by 1. uh, yeah, and then basically I check that if my current element, which is array of I, if that is or it should rather be while, because then I could have multiple elements. While array of I is greater than the last element present in my stack, I keep popping from my stack. And otherwise, like I'm just thinking about the logic that like for example, like we know that 10 can see 6, 8, and 11, right? So like do I maintain like does that depend on the length of the stack, that if I have 3 elements in my stack, in that case the resultant answer would be 3. So that's something that I'm trying to reason through.
Mm-hmm.
So okay, so like let's just think about it. I'm currently standing at 11, and I know that um like okay, I should probably initialize my stack by the last element in my last element in my array, right? So like ideally speaking, stack of -1 should basically be nine array of -1, or like we could just say stack of 0 actually, since there's like no element. Yeah, and so I already have 9 in my stack at this point. So stack is equal to 9, and I basically see that my first condition is that 11 is greater than 9. So in that case, I pop 9 from my stack, and I guess I move forward. Um, so like now I'm at 11, and like there's basically no element in my stack. So I guess I'll have to, inside my while condition, I'll have to check while I have an element in my stack, and like array at index I is greater than the last element present in my stack, because that's really important that my stack is not empty. Then only can I pop from my stack. But I'm still trying to reason through my logic as to when I'll see 3, 1, or 2, like what would my approach be for the same. Like something I'm thinking is, I'm not sure, but is it something to do with like the length of the stack, like the elements present in my stack? Does that give me 3, 1, or 2, 1, etc.? So
The length of the stack.
yeah, I don't think that's how I would do it though. I'm just thinking about it.
What I would do is, can we try simulating your approach in the comments to just see that it yields the right result?
Sure. So stack basically contains 9.
Sure.
This is basically so this is like 1, 2, 3, 4, 5, 6. So none, 3, 4, 5, and then last element is initialized to be 0. And then basically I'm iterating through my array. I'm at 11, and I see that there's one element in my stack, and I see that 11 is basically greater than the last element present in my stack, which is 9. So in that case, I pop it, um, and but like I think, but like if I know that 11 is greater than 9, so that means that I found one element. So basically, that gives me the one here, which was shown in the Xcali draw, where basically like we're basically iterating through it in the reverse order. So I should set it to be 1. But then I'm just thinking, like, should I use like a separate counter variable which counts it? But then how do I keep track of that for like every single height, right? That is something that I'm considering right now, because I'm not sure what exactly would I be doing there. So yeah, so like if I've popped it from the stack, I guess I could do uh, res at what index would that be? Res at index I, right? Res at index I would be count, I guess. But then like there's no point of maintaining a separate counter. I don't think using a counter would help here. um, bec- because like I'll have to keep track of the state for every single height. So I'm just thinking, what other method could I use? Like, is the length of the stack something useful in this case? But then again, like if I'm popping from the stack here, I have no element present in my stack. So how would I get 1? That is something to consider. And or what if, like, instead of popping, if I appended that to my stack? In that case, I'll have 9, I'll have 11. Um, I'm still thinking about this. Like, what would my approach be? So the ith person can see the jth person if I is less than j, and I guess I can skip that. I should like look at my monotonic stack approach only. But um,
Okay,
so
you
why not?
popped out the. So how do you fill in? How do you know using the monotonic stack? Because you introduced this monotonic stack, but how are we gonna use the monotonic stack in order to achieve our goal? I guess because you just mentioned, yeah, we need to have a monotonic stack. It's gonna store things in either decreasing or increasing. But how is the knowledge of what's increasing or decreasing before us going to help us figure out our result?
I'm forgetting like how we used a monotonic stack, but then like for some reason I'm thinking of using the length of the stack, but I'm sure like that's not the case. So I'm just thinking
What would
about
the
it.
length of the stack give you?
Like the length of the stack will give me basically like for basically the resultant array. So like for example, if there are three elements in my stack and I've reached like index 0, so in that case I'll just do like res dot append the length of the stack, and then I presume at that case there's going to be three elements in my stack.
Wait, could you repeat that?
Like I was thinking that basically like if I'm at index 0 and then assuming I have like three elements in my stack, so in that case the length of stack is 3. So in that case I just do at the ith index I basically append the length of the stack, which will give me 3. But I think that is wrong, to be honest.
So let me see if I give you a hint here, advice. I mean, I think we need to. You are going the right approach, but you're going in circles because you're not simulating it properly, right? Or simulate it all the way through, and then work from there. As in simulate it and then actually update the result and then move this pointer back. Tell me how the stack works. Like simulate the whole thing. So we start with 9. 9 is 0. Yeah, we know that. We move to 11. What happens now?
The like I compare that with the last element in my
Okay.
stack,
And then what?
and like I'll have to decide that if I'm maintaining a particular order, will I pop it, or would I just let it be remain in my stack
Okay.
and move forward with the next set of iterations?
Okay. So what are the options? You can either, if you pop it, what happens? It becomes a
If I
monotonically decreasing stack or an increasing stack if you leave it, because that affects it. Like the condition you're building here affects it.
so like if I leave 11, right? So then I have 9, then 11. So effectively, I have a monotonically decreasing stack, right? Because like a stack is last in first out.
If you leave 11 or if you put 11,
Like I'm just thinking, which direction am I seeing it? Is it like 9 to 11 or is it 11 to 9? Because that depends if it's like increasing or decreasing, right?
well, like if it goes 9, 11, 12, that's an increasing stack, right?
Right. So in that case, like I'm probably following a monotonic increasing approach where basically if I'm letting it stay, then it's increasing. But then what I was discussing so far was like a decreasing approach that if it's a greater element, I just pop it. But then like if I'm at 11 and I see 5, so that means in that case I'll have to let it remain in the stack, right? Because
Okay.
it is
Let's explore both. Okay, let's say keep it. That means it's an increasing stack, right?
right.
And then
Yeah, let's
and then what did we put for n here for 11?
for 11 it's gonna be 1,
Okay,
right?
one. We say it's the length of the stack, right? That's what you
Yeah.
said. Okay. We look at 5. What do we want to store 5? The result should be 1, right?
um
Or yeah, like here for
yeah we basically we want a monotonically increasing stack. So if I have 5, in that case I see that 5 is smaller than 9 and 11. So in that case I think I should, ideally speaking, pop like all elements from my stack, right? Until I find someone who's like smaller than 5, but then there's no one who's smaller than 5.
well, who can 5 see here?
5 can only see 11 right now.
Okay.
Yeah.
5 can see 11, but 9 is in the stack. So now let's explore the other. Explore the other method. We just saw that keeping it doesn't work. So we put 9, then we go to 11. 11 instead of putting it, we put 11. Now it's a decreasing stack. It's a monotonically decreasing stack.
Yeah.
Like this one. Then we go to
And
5. Okay, who can 5 see?
5 can only see 11, so I'll add that
So
to
this
the
this
stack.
one, right? But Do
Yeah.
we add, now we say it's monotonically decreasing, so we add 5 here, right? So now we go to 8. So
Uh,
it's a decreasing stack. So what do we do with 8?
we see that 8 is greater than the last element in my stack, which is 5. So in that case, I keep popping from my stack, right? And then I
Okay.
get 2.
But what do we store in the result
Uh,
first?
like the number of times we were popping from the stack.
Okay, let's just say we returning the length of the stack because we see 8 and we can see 5 and 11, right? Okay, there's 2.
Yeah.
Okay, now
So
we
then
see
we
8, and now you said we pop it because we want it to be monotonically decreasing, so we get 8 here.
yeah. Um, wait, I'm just thinking. So like we were at 11 and 5, and the only um like 8 is greater than 5. Okay. I guess that makes sense. Yeah.
Yeah, like we
Cool.
pop 8 or 5 because it's smaller than 8, and now we don't pop 11, so now we have 11, right? Okay.
Yeah,
Pretend
and
we get
then
to 6. What do we do now with 6?
with 6 we just add that to our stack because it's in a decreasing fashion. Like 6 is basically
Okay, but how? What
smaller
do we
than the
update
last.
the res? What do we update the res?
Like 6 can only see 8, right?
It could see 8 and 11, right? It could see 8 and 11's taller.
Right. But then it can see both. But then the thing is that in my resultant array, like 6 can only see 8, right?
Which resulting array? This one?
Like what you've written in Xcali draw, like the drawing tool, like 6 can only see 8, right? Because it can't see 11. Like right here, 6 can only see one person.
Let's see. Oh yeah, you're right. Let's see. 6 and let me see. Wait, let's see. Yeah, 6 can only see 8 because they're covered. Is that the case? Let's see. Yeah. 6 can only see 8. So we need to
Right.
update the stack differently.
Yeah, exactly. So I'll have to, in that case, pop both elements from the stack, right?
Which ones? All of them if they're smaller?
Yeah.
Okay, let's work backwards again. See, but I think the main point is because we got a little confused here, but we need to actually try to simulate it because you went into writing the code kind of thing, and I don't think we'll be able to get to a solution unless we try to work it out like this, right? I think this for me, I think this is a good way to approach it, or will help us get there. Or is the way that I would do it in an interview.
Right.
But like, let's step back. Let's say we have a stack, right? And then we have an array, and we have a result. Okay, now similar way that I did it, or like, could you try to simulate it, kind of thing? Now,
Yeah.
like, try to follow that kind of step.
Yeah. So like basically like I'm at basically like let's just say, I'm just thinking. So if I have a monotonic stack, I'll firstly have to store like if I have an empty stack. So in that case, I'll basically add the current person's height to my stack, right?
Sure.
So like let's just say I add like 9 to my stack. So stack basically contains 9, and then after that, I I think we should also use like a separate counter variable to count the number of visible people, right? So let's just say that count is 0 as of now. Um, count is 0 as of now, and my stack contains 9. So moving forward, I basically come towards 11, and I see that 11 is greater than the last element present in my stack, which is 9. So in that case, I increment my counter by 1, right? And then like I increment my counter by 1, and I pop the last element from my stack. So count has basically now become 1, and my current stack is again empty. So on the next iteration, I'm at 5. Since the stack is empty, I add 5 to my stack, and after that, I'm basically at my next iteration, and I see 8 is there, and I see that 8 is basically greater than the last element in my stack. So I'll just increment my counter from 1 to be 2 now. And basically, I'll have to pop like 5 from my stack now. And wait, I was at 8, right?
Um, yeah, I'm getting confused because you're saying a bunch of stuff, or you're kind of saying it out loud. And I think just try to manage the pointers here. I think it'll be better, and actually, and manage the stack. Let's take a step back and slow down.
Okay, okay, cool.
So okay, start with 9. What happens? You push 9 onto the stack. Okay, and then you move the pointer back. We're looking at 11.
Yeah.
What happens
Now,
now?
now 11 is greater than 9, so I increment my counter by 1. Count is
You have a
initialized to be
count?
0. Yeah,
Okay, count to 0. You put count equals to 1.
yeah. And so like, and I'll pop this element from my stack. So I pop 9 from my stack. If the new index array of I is greater than like the last element present in my stack.
Okay, you put 11. Okay, so it's
Uh, yeah, and then I
it's an
put
increasing
11.
stack then. It's an
Yeah, yeah, yeah.
okay,
And then I'm basically now at like 5, right?
yeah, okay. Now what do
Now
you do
I'm
when you fire?
and then 5 is not greater than 11. So in that case, 5 is not greater than 11. So I
Or what's
basically,
the result here? What did I store here for 11?
for 11 you basically stored the count, right?
Okay, 1. Okay, now we're here. Okay, continue.
Yeah. So you're basically at 11, right? And then like you have no, sorry, you're at 5, and you see that 5 is not greater than 11. So you basically don't pop anything. But in that case, like if you still have an element present in your stack, you increment the counter by 1.
Sure.
But um like if I increment the counter by 1, like we know that if the stack is not empty, then the current person can basically see the next taller person, right?
The stack is not empty. Oh, I don't know what you mean by that. Could you explain it?
Yeah, sure. So like let's just like go a step back, right? Back to 9, like just so that I can explain this better. So my stack is empty. So like in that case, I add 9 to my stack, and visible count is basically going to be 0, because I'll just like res of I basically becomes my count, my current count, and then I basically move like a step back, and now I'm at 11. Uh, Now I'm at 11. 11 is greater than 9, so I increment my counter. So my count now becomes 1, and I pop the element 9 from my stack. So now my stack is empty, right? Uh, so I'll now I'll basically add the current person to my stack, which is going to be 11, and I'm basically going to store my current count in my resultant array, so that becomes 1. Next, I move like a step back. I'm now at 5,
Yeah.
and at 5 I see that 5 is not greater than 11. So, but I see that there's an element in my stack, so I increment my count by 1, um, and I append the next person in my stack. So that becomes, I think, 5 comma 11, right?
Or why do you push it to the front? Is it a stack?
Yeah, sorry, push back, my bad. Yeah, that becomes 5, and then basically I store count as 2 in my result. But then what I'm getting confused is that we saw that 5 can only see 11, right? The next person who's taller than him, not
Mhm.
9.
Mm-hmm.
So there's something wrong with my algo so far. Like that's what I'm thinking. Like,
Okay, let's debug. So
yeah.
well, you're at 5. You push 5, and you put 2. What is person 0 1 2?
Like I think something is going
Okay,
wrong.
this
Like
is before.
I shouldn't have appended 11 to my stack. Maybe that's what's wrong.
Okay, pretend we push. We're looking at 8, right?
Yeah.
So if we're looking at 8, what can 8 see? It could see 5. You could see 11.
Yeah. So like if I'm at 8, 8 is greater than the last element in my stack, which is 5. So in that case, I'll have to increment my counter by 1, right? And then pop that element from my stack. Do you want me to code
Wait,
it out?
okay. Code what up? I don't think we have a solution though. That's the thing. Like,
I think I have something in mind.
would you be able to just explain it on the note or no? 'Cause if you have it in mind, or are you more like, I'll code it up and then I could figure it out as we code it kind of thing?
Yeah, like I think I'm more like that type of a guy.
Because let's see, we're looking at 8, right? I mean,
Yeah.
you can go ahead and try to code it. We have like 10 minutes left. Try coding it then. But usually, what I like to do is just make sure that they know what they're gonna code before.
Oh, okay. Yeah, so
Cause like, yeah, once we write the code and pretend they went in the wrong direction or they like, I see like how it might help.
yeah.
So just go ahead and try to write it. Let's see.
Yeah, sure. So, I have a local counter like initialized to be here, and then I'm basically gonna start like at like len of array -1, basically at the last element, and then like while I have an element in my stack, and basically array of I is greater than the last element present in my stack. In that case, I'll increment my counter by 1, which is what I was saying, and then pop that element from my stack, right? And then like I know that if my stack isn't empty in that case, the current person can basically see the next taller person. So in that case, like if I have if stack, so in that case I can basically increment my counter by 1 because you can see the current person can see the next taller person, right? And then I always add the current person to my stack. So stack dot append that is array of I, and then basically what I'm thinking is that I'll store the counter in my resultant variable, right? So res of I basically becomes my count, and then maybe what we can do is like try printing out res here, right? Can I like
Run
run
it?
this?
Sure, run it. Let's see.
Yeah, I'm not sure. Like
This assignment's out of range.
so like I should probably initialize this to be an empty stack.
Well, you already had stack up here. Isn't it?
Oh, sorry about that. So like the solution for that was 3 1 2 1 1 0. So like we're doing something, we're I think we're almost there, but then why aren't we getting 3? That's like something I'm trying to debug. Because like where's the drawing tool? Yeah, so because like 10 can see 6, it can see 8, and it can see 11. So let me like res of I is equal to count.
Okay, just fix this part.
Yeah, I think that is why it was wrong. Yeah.
Nice. Okay, let's try running this.
Yeah. Let's now run through this.
Okay, can
So
you dry run it for me on the code?
yeah, sure. So count is basically 0, right? Stack is currently empty, so I start at the last index. There's no element in my stack currently, so in that case I just append like array of I, which is basically going to be 9. So in my stack I'll append 9, and then res of I is basically count, and we know that count currently is 0, so this becomes 0. Next, I move forward. I'm now at 11. Basically I have like an element in my stack 9, and 11 is basically greater than 9, so I increment my but yeah, sorry, I have to reset my count every but okay, it's all right, it's already at 0. So I increment my count by 1, right? And then I pop the element from my stack, so like there's no element in my stack. And I append the array of I, which is basically going to be 11, so I have 11 now in my stack.
Nice.
And res of I becomes count, so that is just 1 right here.
Yeah.
Moving forward towards the next iteration,
Yeah.
I'm basically going to be at 5, and I see that 5 is not greater than 11, but I do have an element in my stack. Also, obviously, I'll have to reset my count to be 0, right? Because it's inside the for loop.
Mm.
So now this becomes 1 because I already have 11 in my stack,
Yeah.
and I basically end up appending like 5 to my stack, right? And I basically push my count to my I basically push the count to my resultant array.
Sure.
I move back. I'm at 8. I see that 8 is greater than 5. So I increment my count to be 1. Like obviously it was reinitialized to 0. So count becomes 1 now. I pop the last element from my stack. So end up popping 5. I see that there's like one element present in my stack, which is 11. So I have a next dollar person. So I end up incrementing my count by 1. And I append 8 to my stack, and I basically push the count to my result. So this ends up becoming 2, and then basically now from 8, I'm at element 6. I see that obviously I'll have to reinitialize my count to 0. At
Mm.
6, I see that 6 is basically not greater than 8. So but I do have elements in my stack, so I basically incrementing my count by my I increment my count by 2 here, because like I have 2 elements in my stack, and I basically end up appending 6 to my stack. And in my result, sorry, my bad. Like it's not while stack, it's if stack. So in that case, I'll just like increment it by 1, not 2. That was wrong. And basically, reservoir basically becomes count. So this becomes 1. I move back to 10, which is my last element. Um, at at 10,
Yeah.
at 10, I see that 10 is greater than 6. 10 is greater than 6, and I have elements present in my stack. So I basically, like 10 is greater than 6. So, and 10 is greater than 8. So I increment my count by like 2, count by 2, because like I have 6 and 8 with 10 who's greater than 6 and 8. So I end up popping both of them. And like I have another element present in my stack which shows
Yeah.
that I have another greater height. So I
Mm.
increment my count another time by 1. That becomes 3. And I end up appending like 10 to my stack here. And reservoir basically becomes count, which is 3.
Yeah.
And I'm basically done with my for loop.
Nice. Okay. Yeah, makes sense now, right?
Yeah.
Yeah, we're pretty much at time now. So, what do you think? How was that?
Like I think it was like I had done like a monotonic stack problem before, like, but it had been like too long, so it took me quite a bit of a while to figure out like how to come up with the solution. And I think like I had a solution in mind. I was unable to like comprehend that portray that properly to you. But like as soon as I like, usually what I do is like I end up coding it, and like side by side I end up like dry running it and seeing that if the
Mm.
logic I'm seeing tries to make sense. So I think it worked out at the end. What would you say? How would you rate me? Like,
Yeah, I would say, yeah, you mentioned the monostatic stack in the first 2 minutes, but then it was about like 45 minutes until like it took about 45 minutes to implement it. And the reason I was pushing you to show me the solution in the comments is because most interviewers will not prefer you to just start writing code and then figuring out as you go. They would
right,
want to First off, they would want you to read the solution, ask some clarifying questions. Then they'll want you to start proposing your solution. Oh, I want to. This is a brute forest. It might be slow, so maybe I'm gonna do a monotonic stack, and that's gonna lead to a faster solution, right? Like talking up front of how you're going to do your algorithm, and then once you figure out the algorithm and we figure out the approach, then you go in and actually implement it. And a lot of the times I'm trying to see that if you're actually implementing the code based on the proposed solution that you said. So it's a
right,
negative signal if somebody's, oh, I'm going to do this, and then they start writing the code and it's completely something different. Like think about it in the aspect of where we're working on a project and we need to think about things up front. At some point you might be able to iterate it and be able to get to it, but if we can't plan the algorithm and solution up front, then we can't plan a lot of the project. We can't plan a lot of things because we need to be able to I'm basically just seeing your communication and planning skills, right? It's like this is the algorithm we're gonna do. It's gonna be event time. I'm gonna do a increasing monotonic stack. and then you go ahead and implement that, and the algorithm that you created should match what you proposed, right?
Right.
So I would practice like thinking of the problems up front and the solutions up front, and being able to communicate that with the interviewer up front before you start coding. And then there are going to be little things that we need to figure out when you start coding, but it shouldn't be big parts of the problem.
Right.
Does that make sense? That kind of feedback?
Yeah. So like effectively in any like in most interviews, it's like more effective for me to like begin by like walking through my thought process and like obviously explaining the brute force solution. I think I forgot doing that. Like it instantly clicked that this was something similar to a monotonic stack question. I think there are like a few extra points associated for the same, right? Like if you explain the brute force like just verbally.
Yeah, so you don't even need to. Not every time you need to explain the brute force, but usually, if you look at the criteria for a lot of companies, like, did they clarify questions? Did they ask clarifying questions? Did they propose one or more working solutions? Did they produce the optimum solution? When they wrote the code, did their code reflect what the solution that they proposed, or did they have to fix a lot of things on the fly?
Right.
Right? Is there are they able to talk about runtime complexities, etc.? Like, have they do good communication? Because as an interviewer, it goes all over the place when you're like, okay, you're just writing a bunch of code and then working through the solution at the same time. Like, I don't know, maybe I just it's I've been on here for 10 hours, so, but I don't know. Chat, was it kind of confused? What do you sort of prefer? But all I'll say is, like, from when I had to do interviews and when I had to assess people, that's a lot of my criteria is, did they clarify the question? Did you propose one or more working solutions up front and then not start just writing code? Like, it's a negative signal if they just start writing code right away without ironing the solution. In your case, it worked out, but I've seen candidates who they just start writing code and they went the completely wrong solution, and we could have ironed it out right away if we just talked about it up front, right? In this case, it worked out for you because you kind of figured it out, which is good. But yeah, I think the main thing I'm trying to get at is you just need to follow a more structured approach when it comes to your, like, the way you come up with that, or the way that you like conduct the interview or do the interview.
Got it. Thank you so much,
Yeah.
James.
That makes sense. Like pretend, I don't know if you're watching the system design one, but my advice to them was to just have a more structured approach of just following things in a certain order. Because pretend they're like, oh, they start building out how the server connects to the front end connects to the server to the database. Then they go to the functional requirements. Then they talk about the database index. Then they go to the API, and then they go back to the non-functional requirements. Right? It gets confusing. It's like it's not structuring the ideas properly. So I think, yeah, just following a more structured approach, and yeah, just have things more ironed out before you start coding. I think coding should be the last step, and coding should happen pretty fast, and you should like not have to iterate on the code that much because you already have a clear idea of how you're gonna solve it. But honestly, you solved the question. It's a hard leak code problem. You did good.
Oh wait, it's hard.
Yeah,
Oh shit! I thought this was more like a medium. Oh my.
it depends. Some people, if you look at the discussion, people say that it should be medium, but it's tagged hard, so it's still a hard problem.
Oh
But
my god.
I had to give you a hard. But the acceptance rate is decently high on it and stuff. So I would say it's a medium-ish hard, or just a medium. Or Paul said it's 2,100 elo, so I guess it's pretty hard, which is super high for
Great.
that problem.
Crazy.
But yeah, honestly, you were able to solve it. Good job. My main thing would be figure out a better, or follow a better approach to solving the problem. I think, honestly, it was the perfect question for you, because if I asked you anything easier, you would have just solved it. But this one, it really tested you and made like we uncovered some things that could help you improve. So I think that's good.
Yeah, I agree. Like I've solved like a lot of questions. So there was like a high probability I'd seen the question before and like know like at least like how the algo works at hand. So like thank you so much. Like this is definitely a question which like pushed me in terms of thinking, like
Yeah.
how to like refine my code, and then implement my solution. So thank you for that, James.
Yeah. Thanks for coming on. We should do this again sometime. I actually really enjoyed that session. Just hit me up whenever. Look, I'll send you another link to sign up. But good luck on your studies. You're only second year, so like chat. This guy's only second year. That's pretty insane. You have a lot of good ideas. It's just like the structuring part of it, as I mentioned, like just making sure your thought process is structured. Otherwise, you could have easily blew that algorithm out the water and just had like a very strong hire. I think you were very close to that if you had the right process.
Got it. Yeah.
Did you
No,
see?
thank you so
You
much.
see how when we started using the stat or we started using the comments, it kind of like helped guide you a bit, or it started getting your mind there of like how we're gonna do it.
I agree. Yeah. Was that? I think this was like a lot of help, though, right? Like compared to like a normal technical interview.
Yeah, like I don't know if I would have like helped that much during a regular technical interview, but yeah, it's a harder question, so I gave more advice, and yeah, I don't know. This is all about this is just about practice, right? I just want to make sure you got something out of it as well.
Absolutely. Yeah. Thank you so much. No, I
Yeah.
agree. Yeah. Like if you wouldn't have like pinpointed me towards like using like both approaches, thinking if it's going to be increasing or decreasing, I might not have thought of it. Yeah. So thank you so much.
Yeah, because I just remembering you. Yeah, you were there, and you're like, oh, should I do increasing, decreasing? Should I take the length of the stack? Should I like? You should think about that and sort of explore it a little bit, and not explore it in your head, because a thing you'll see with a lot of candidates is they'll explore solutions in their head, but I'm not in your head, and even if you just explain it to me out loud, like I might not be able to figure out what you're actually thinking. But when you put it into the UI like this and you show me how it's working in your head, it's more clear for me. So for example,
Got it.
like you know what I mean? Like if you're like, oh, I have a stack, I want to do it, I want to talk increasing or decreasing, and you're simulating it in your head. But for me, as I'm just watching you think, I don't understand where you're going with it.
I agree. Like my thought process was cluttered like all over the place, and like yeah, I should have worked on that.
Hmm.
Could I ask you like something about like the other data structures?
Sure.
So like for example, if I have a DP question, am I supposed to like let's say go from recursive to like memoized solution? Do I have to tabulate that and like optimize it to like 1D, like using like a 1D array, or like how much optimal does it have to go?
I mean, it depends on the company you're interviewing for. I would say if you're working at if you're targeting hedge funds and stuff, they ask more DP, but FANG companies really only ask, um, only Google really asks dynamic programming, and most of the time for them, top down memoize is good enough. If you it depends. Some people can figure out the top down memoize better, easier than, but some people can think of bottom up easier.
So
But
sure.
usually, the main thing is what I like to do is I start to do top down, then memoize, and then if I can come up with a bottom up, I'll do that, because when you come up with the bottom up, usually you could only do the very spaced optimized algorithms with the bottom up solutions.
I agree. I agree. Yeah, like I'm targeting hedge funds like down the line. I mean, I have like
Nice.
5 more co-ops to go, but so I guess it's like best like for me to, really go down to like 1D DP and like optimizing the space complexity as well.
Optimize space complexity. Figure out where do you should probably do code forces more than anything. Everybody that I know who worked at a quant that's coming in this channel, because we had people working quant hop on this channel and they do code forces, which is some more combinatorics and probabilities and some math, solving
Yeah,
questions that involve that.
I saw like the videos of like you with Moses like doing
Oh,
the
you know him?
yeah.
Nice,
I met him too. Yeah, he knows me.
nice.
Super smart guy, I
Yeah,
must say. ICPC and God knows what else. Like super
nice.
crack.
Yeah.
And yeah, I mean it's been fun. Like you had like Richard coming into, so I've been following you for quite a bit.
Wow, you know all
It's
them?
been a
Nice.
journey.
Cool. Yeah. Good luck. You're only in second year, and I gave you a hard question. Honestly, it's just more just like having a structured approach. Richard did
Sure.
really good on his. I remember.
Yeah. Like he grinded the hell out of lead code. Like he's done like 600 questions or so.
Yeah.
I gotta get there.
How many questions have you done?
I've done like 180.
And honestly, what I would say is if you did 600 questions, it might not even make you any better because you're already good. I would focus on actually working on questions that challenge you. You could do 400, 500 more questions if you just did medium questions. I don't think that'll set you up well for a hedge fund. But since you're already good, I feel like you're actually pretty good already. You could probably do harder and harder. You should do more hard questions than mediums. Unless you could already really do a lot of medium. Or unless you still struggle with mediums, I'm not sure. But
No, I think I can do most mediums comfortably.
yeah, I would just literally focus on hard questions then for you because you're already good.
Right, and like just another thing, like have you seen like DSU come up like as an optimization for like most graph
The
questions?
joint set,
Yeah,
like union find.
yeah.
Yeah, I've seen it. I've never had to do it in an interview, but I mean it comes up often. I've not, actually never had to do it in an interview though. Like implement a DSU. It's kind of niche. If you think about it, DSU is 10, 15 lines, and then usually you can solve the problem in less than 30 lines if you use a DSU.
I agree. Yeah,
Doesn't really.
highly.
Yeah, it's kind of very specific. If I'm making hiring decision and the dude doesn't know what a DSU is it good to reject them just because they said they didn't know what a DSU is? Like, do you think that's would you just reject someone for not knowing what a DSU is?
No,
Exactly,
hell no.
right? But if somebody couldn't work with a set, then I would be like, okay, that's kind of crucial. But
I
things
agree.
like DSU, heap. I would expect someone to know a heap, but like a dish like union find, I wouldn't not pass on someone who doesn't know what a DS or union find is, in like 90% of cases, unless my company really is using dish like union find.
Yeah, like if it's Citadel, I guess might as well know everything, you know.
Yeah, I don't know. Yeah, cool. Thanks for hopping on. We'll take a
Yeah.
little break.
For sure.
Alright.
Thank you so much for your time,
Yeah,
James.
no
I
problem.
really
Thank you. Peace. Yeah, that guy's good though. Honestly, still good. Second year is crazy. Okay, we're gonna take a quick break. Holy, that was like a 6-hour shift. Take a quick break. Okay, I gotta take a quick break. Actually, holy. Coding for 12 hours straight. Insane. Hello everyone, and welcome back to my channel. So today I'm gonna quickly play this video while I go for a little walk, and then doing a code walkthrough of www.jamesperalta.com, which is this website that I built. And I'm gonna be walking. This is my portfolio website where you can see home video, or you can see a home page. You can see Peralta 75 list, some videos, some mocks. Login works correctly too. So yeah, there's a authentication feature And yeah, I want to do a code walkthrough and highlight some technologies and talk about some of the technology choices that I made. So what I want to walk through is Next.js, which is the framework I use to build the front end. I want to walk through Vercel, which I use to host the Next.js app. And I want to talk about Tailwind CSS, which is how I styled this whole library or this whole page. And then I also want to talk a little bit about Cursor and how you can leverage Cursor in order to build yourself a portfolio website like this relatively quickly. So, yeah. So what I used Next.js, and the main thing that I wanted to just talk about with Next.js is why I decided to use Next.js over something like React is just because I wanted to play around with server-side rendering. So right now there's two common ways to build your apps. There's single page applications where you send the whole JavaScript code to the front end, and then the front end never redirects or anything. It just renders as you interact with the page. So as you pretend you would click onto here, instead of requesting the Peralta 75 HTML, what it would do is it intercepts that and it will render what the Peralta 75 HTML, all generated using JavaScript. So that's the single page application. That was a lot more common when I started in 2015. So probably in the last decade, single page applications were common. And you're starting to see a lot of people go to server-side rendering. And honestly, server-side rendering came first back when the internet first started, the early 2000s. PHP and things like that were server-side rendered. Where, yeah, pretty much whenever you requested. Back then, JavaScript wasn't used as much. And also, devices weren't as strong. So running a ton of JavaScript on the client would probably have been really slow. So yeah, a lot of websites back in the days in the early 2000s were actually server-side rendered. So you would request a web page and it would return you the HTML, and there was very minimal JavaScript. JavaScript started happening a lot later than that, probably mid in the 2010s. You see all these JavaScript front-end libraries start exploding, and now, yeah, I mean, there's been a lot of them, but honestly, it started to slow down. So, yeah, so that was a little rant on service, or the difference between server-side rendering and React. Or, I mean, Next.js is built on React, or it's pretty much exactly like React, but it just adds all the things on top that allows it to server-side render. Let me make sure I covered everything that I want to cover regarding server-side rendering in Next.js. I was building up a script over on this side. Okay, let me talk about why some of the key advantages of using server-side rendering. And a lot of this is why I decided to choose it. The main thing for me that I was thinking is for search engine optimization. My website is a portfolio website. My website will contain a lot of content that I want to get picked up by the search engine so that it could be recommended in things like Google and Bing and all these other search engines. I want people to be able to search Peralta 75, and then it will just show up in the search engine, or even little text in here. I'm gonna have a lot more content. So yeah, I wanted it to be search engine like SEO friendly, and server side rendered is the reason why it's more search engine friendly is because something like a single page application, it generates all of the content dynamically. So it's not easy for a crawler to just go in and crawl and because if you ever use the crawler, you would know how annoying it is to work with a dynamic website like a single page application. It pretty much loads you in one page, and then you have to click around to discover the content, and then there might be weird animations. You have to wait a few seconds for it to render because the JavaScript might be slow, all that stuff. But pretty much with a server-side rendered, when you request the web page and you get it back, the page that you get back is pretty much the content is there. It's more static content because it was generated on the back end, right? That's my main thing. I wanted it to be search engine optimized. What else? There's like faster load, faster first load and stuff like that, especially for slow devices. But honestly, I don't really mind that because most of the people that watch me live in the U.S. But although I want to be inclusive and I want to be accessible, that's also one thing that's important. You want your content to be reached by anyone, but I mean, devices are just super strong these days. What else? Simple security. One thing that's good about server-side rendering too is that you can hide all of your keys and all your API calls away from the client. So when you have to build single page applications, if someone looks at your network tab, they can see all the API calls that you're making. And for better or for worse, they can, like, if you don't have a secured API, they can easily just hijack your API calls and start making those calls themselves. They can fake the headers and stuff like that. I know my brother building on johnperalta.com was talking about like that people could just straight up see his API calls, and I ran into that issue before. So one of the best ways to avoid that is to hide everything, like server-side render, because when they request the web page, and they just make a request to your server for the web page. For example, they'll just make an HTTP call for like Peralta 75, right? When they hit the Peralta 75 list, all they're gonna get back is the HTML. But when they make that call for this HTML, on my server, I'm gonna make my API calls. So now my API calls are hidden from the client, from the person requesting them. They can't see it in their network tab. So all they literally get back is my web page. They can never like inspect and be creepy. You know what I mean? So that's one thing I like about server-side rendering as well. Like simpler security from my perspective, because we don't have to pass a ton of things to the client. We don't have to pass in all the API keys, I mean, you would never pass the API keys, but the client doesn't even need to know that much about the APIs in general. That's what it's like. You never pass the API key into the front end. Let me make that clear. I don't know if I said that earlier, but let me make that clear for in case anyone don't pass the API keys, because JavaScript, you can inspect the element and see all the JavaScript. What is this? Where's source? In a single page application, you could this is all the JavaScript code right there. You can see the CSS, everything. If you put your API keys, somebody could just look at the source and grab your API key, jack your API key, and run up your bill. Yeah. Cool. That was a little bit about server-side rendering. Let's talk about how I used Tailwind CSS. I think that's another important part, because pretty much there's two common ways to build out your, well, let's just say there's three common ways to build out your CSS right now. So the first is using a component library. That's really popular. Something like Material UI was really popular. Then the one I used is Tailwind CSS, which is a utility-based framework. And then you could also just straight raw use CSS. Component library is something like Material UI right here. And these kind of just gives you, this is way more beginner friendly. If I'm just starting off with front end for the first time and I don't want to manage CSS, what I would do is use a component library like Material UI. that offers you all of these beautiful components like autocomplete, buttons, button groups, checkboxes, select, sliders, and they already behind this. You just pick from these components. Look how literally 5 lines of code. And in the background, they style it, they make it dynamic, they do all these things, they follow proper design principles. So you can see what the advantages of using Material UI is you're able to ship faster. It follows material design, which is a principle for how to design beautiful web pages. So it's like a guideline. So you could talk about the Material Design 2 guidelines. I mean, it talks about theming, spacing, icons, what a beautiful typography looks like. They did a bunch of studies. So all of this stuff is encoded into the component library. So it was very useful. Like if you're a beginner, just straight up use Material UI or some sort of component library because it's very, very beneficial for you. It allows you to move a lot faster. And if you don't have that much design chops, you're not used to building design or designing software, designing interfaces, people have done the research for you and they expose the component library for you. And then if you go work at a large company or even some of these later stage startups, a lot of them will have component libraries that they built in-house. Maybe they designed it completely in-house. I've seen that a lot of times where they'll build out what a button is and they'll have a front-end developer build out the whole component library, and they'll have different buttons, but we'll have the design standards and design principles from the founders or from the company. It's specific to the company. And companies like to do that because they like they want to have full control over like the CSS, the styling. They don't want to have to like push a PR against Material UI. I don't know if Material UI is open source, just in order to get it to behave a way that they. Yo, chat, got a special guest. Hop in. My friend Brian again.
Hello.
Hop in. Yeah, we had 16 people right now. Yo, what's going? Like at some point, it's like 40 people.
Oh. Are you sure you unmuted?
So I'm muted. Yeah, I can see my voice.
Okay.
Chat, can you hear him?
Moving along.
Wait, chat. Say yes or no if you can hear him. Probably say Brian. Say something. Like speak up too, cause
Nope.
like talking, it should get up.
It needs to hit up to yellow.
Say.
Oh crap! You need to be loud then.
Yeah, you're too soft spoken, man. Okay. Perfect. Let's see. Let's just make sure. Can you say something, Brian?
AGI.
I got hit with that.
Oh. Now, people were saying they can hear us though.
Can you say something again?
Testing.
Okay.
Testing.
Okay, let's like whiteboard some stuff. All right. Okay, moving a little bit. All right, chat. So the reason that I brought my friend Brian here is to talk about this term, AGI, that's been going around everywhere, and just give a background on yourself of your schooling and stuff like that, because I want them to understand why you're uniquely positioned to talk about this topic.
Yeah, sure. So I did my bachelor's in software engineering, and I first came across the term like AGI around I think second year university for me, so like 2016. And then from then on I decided I want to learn more about the brain to better build AI. So then I did a master's in neuroscience after my bachelor's. And then, I've been working ever since. But, I do, like, neuroscience research on the side.
Yeah, so you've been looking at this AI or your machine learning stuff you're the one who showed me all this new stuff back in 2017 when I started.
Yeah.
You sent me all these the different textbooks that I read.
Yeah, back then neural networks were just getting big. I think AlphaGo was just being built when I got in. I had been with my friends back then.
ImageNet just came out maybe in like a couple of years.
Like AlexNet was 2012. Yeah. So then it was just starting to get big. I remember like was it Andrew Ngo was getting big then? Like Andrew Hinton, Jeffrey Hinton. Yeah, those guys were just starting to get big. But yeah, not to the hype level today though.
Yeah. That's crazy because even at that moment when we were in it, we were thinking, "Oh, this is getting hyped. This is getting hyped." But now it's on insane hype.
Yeah.
Actually, when we were doing it, it wasn't that hyped. It was more like
no. I think it was like blockchain stuff at that time. And I was the first one to tell you about AGI.
Yeah, I remember when we were working on it. It sounded cool, but we didn't know how far it would go. Like this is definitely gonna work. I mean, you think it's a bubble, but okay. Yeah. Let's just talk about what AGI is. Explain AGI in the most primitive form, and not 2025 when they already moved the goalpost or they introduced new terms. What is AGI?
AGI is just artificial intelligence at the human level, right? So, I think the term is kind of vague. It means whatever a human can do, an AI needs to be able to do, right? There's a lot of changing goalposts, right? Because people define what a human can do a lot of different ways, right? Some people may say the physical parts are what make us human, right? So then you need a robot to do all that, right? A lot of people think it's more like our mental skills, right? Our intelligence, right? But then intelligence can be broken down to a lot of things, right?
Can you explain? Like, how could it be broken down in different ways?
There's a lot of different ways. I think I like the one. There's a paper by, I think his name is like Francis Swalet or something along those lines. He's one of the ones that wrote the deep learning textbook that I shared with James back then. So he defined, I think, intelligence, and a lot of psychologists do too. It's like a general ability to solve problems, right? So you're given a problem, you're able to solve it, right? So that can take like many different forms. You have like problems that you already know and you're just testing on, and then you're also gonna compare it against like creative problems, so like problems that nobody has an answer to, right? So it's been a while since I've read the paper, but generally like AI, like intelligence can be broken down to multiple components, right? And then we're trying to say that AGI can do all these components as well as a human can, which we're seeing at this point that it's doing a lot of like white collar job work, right? Like programming, almost to the human level, I would say, or sometimes even beyond, right?
Well, what does it mean to be general? Because AI, there's AI, and then there's the G. What's that G mean?
So AI used to mean like just very specialized systems and narrow focus systems before. For example, Siri would have been one, right? It was just only voice assistant. We had AIs before like the AlphaGo, which only plays Go, or like even before then. The history of AI has a lot of examples of just programs that are very specialized in one thing, right? So there's like that chess playing program by IBM, like self-driving cars, like only one domain, right? So all these are just very specific domains, is what they call them, right? And general means we have a program or AI that can do all of these.
Okay.
So yeah, the goal has always been AGI, and the reason is because once you hit human level, there's nothing special at the human level. That's what a lot of AI researchers say, right? So we know this throughout evolution, right? There's no reason why we need to stop at a human level intelligence. We could actually go beyond, right? And we have examples of this. Like there are humans that do better than other people, right? In certain domains, right? But if you were to grab like all those experts and put them into one person, that would be what you want to be AGI. It's like a master chess player, master programmer, master musician, right?
Why would you want that though?
So the reason why the AGI is kind of a good level is because that's where we are, right? We know the benchmark for humans, right? Because we benchmark against each other. That's like the whole competition within our species. So the whole reason why we want to hit AGI, right? And then it goes into the next term of ASI, like artificial superintelligence, is that once we have an AI, you want to give it the task of improving itself, right? And then that's the point where it gets scary, of where AGI is now designing itself, and then it can improve on itself. So it knows what it needs to do to become smarter, right? So it'll do scientific research, it'll do like experiments, application, and then from those experiments, the AGI will improve itself, right? Eventually that becomes like a feedback loop. You could say we're actually in a larger feedback loop too, of like evolution is now pushing us to build more intelligent systems, right?
Why?
So-
Why is evolution pushing us to build more intelligent systems?
Well, in some ways, it's not evolution pushing us. It's more like we are pushing ourselves, right? You can see. So I think one mistaken belief is that things get more complex or more smart as evolution goes on. That's not true, right? Because evolution is not trying to optimize for intelligence or for complexity. It's just trying to optimize the organism to best suit its environment, right? So that's why, like, throughout all of history of Earth, there has not been like intelligence. Like the intelligence did not start earlier. It took a long time for intelligence to evolve, right? And even now, it's like we're still evolving. People might forget about that part. Evolution's still happening right now.
That makes sense. So, oh yeah, what were you gonna say? You gonna get into some stuff?
It's like you could just draw like a timeline of intelligence, right? And then humans are at one point, but you can imagine like the timeline goes out further, and you would hope it goes up further because we would want smarter things.
Why would we want that? I mean, I talked earlier. I had the chat, and some people said the AI is too good. Stop it right now. A lot of people said that.
Yeah.
A lot of people said that.
Yeah,
They're
yeah.
like, it's already good enough. Stop it.
Stop it. Yeah.
What would you say to those people who are really skeptical on it and scared of it?
Yeah. There's a point of safety too, but it's like there's a lot of people that say if you stop it now, right, then someone else will build it, right? So we have a competitive aspect too, whereas like say all of America stopped building AI, China and Europe and like other countries will start catching up, right? So there's like this kind of like this like arms race of where you need to be the first one to build it, right? Because then you get the benefits of it, and then you can continue building off of what you built, and you don't want to lag behind in the race.
Yeah.
Right.
What do you think would be the benefit of it? That you see
of AGI?
Yeah. Like, are you more doom and gloom about it, or you're optimistic?
No, I'm always optimistic. I think the goal has always been if you go back to even like the very first time AI was like, there's something called the Dartmouth Conference where they set out like the goals of like building AI, right? And the whole point is that like we have problems that are very hard for us to solve, right? But it may be easier for something that's smarter to solve. Just like how we could solve problems like for example, like dumber organisms, right? Like for say ants, like if they had a problem, we could solve it for them. We can imagine that if we have something smarter than us, like an ASI, it could solve our problems, right?
So that's what they set out to do in that Dartmouth.
Well, they just set out to build they just set out to build like a smart system, which is what we are too.
Okay. I mean, what if what could go wrong?
What could go wrong? It's like the ethics question, hey. A lot of things could go wrong with AI. Same reason, like a lot of things can go wrong if you have like a smart person, but they have like malicious goals, right, or like misaligned morals and ethics, right? Then they might use that intelligence against us. That's like known as the alignment problem. So someone called like Nick Bostrom works on that. He's like trying to make sure that even though you're smart, like your decisions are still, there's another axis of like morality or alignment where in intelligence you could make like many different solutions, right? But not all the solutions will align with what humanity wants, right? So we want to aim towards getting an AI or AGI that is aligned with what our goals are.
Yeah. So at this current point, where do you think large language models are? Are we close to AGI?
No, I don't think so.
Yeah. Why do you not say so? What would you just? Yeah. Like, how far do you think? How far do you think we are? I mean, and why do you think
it's like a current bubble?
It's like, yeah. Why do you think it's a bubble? Why do you?
Because it makes mistakes, right? It's like sometimes it makes a very dumb mistakes or very obvious mistakes. So that's kind of a dead giveaway to me that it's not gonna be true AGI. Like if it's making mistakes that a human can catch, it's supposed to be smarter than us, right? Or at least equivalent level. So if the fact it's making mistakes is a sign that it's not as intelligent as we think it is, right? So I think that's like another sign of how you judge someone else, right?
But humans make mistakes all the time, but it also comes up with things more clever than us, though, doesn't it?
Yeah. So that's the trade-off. So instead of like thinking about AGI, you can just think of it as another person, right? If you notice another person make a lot of coding mistakes, right, then you would assume or you would think that they were dumber, right? Than like your average person or dumber than you, right? Because you wouldn't make those mistakes, right? But if they start doing a lot of things that are smarter than you, right, then you would think that they're like more intelligent than you too. It goes
Mhm.
both ways, right? So this is like the weird case of where the current LLMs, right, are making mistakes that are really naive, but it's also doing things that are really smart too.
Yeah. Like what? How smart is it doing things though? What's the smartest thing that you can make it do?
So that's what I was thinking about too. I think the intelligence of the LLMs is not in any one domain. It's that it just knows a lot about everything, right?
Mm-hmm.
So that's has been like the main selling point, is that it's been an expert at a lot of different domains, right? So I would say that's like the most scary part. In terms of its ability to problem solve, I haven't seen anything like amazing,
Yeah.
right? But we still see about the applications.
So what do you think it will take to advance the AGI? Would AGI be controllable, Christian? Would AGIs be controllable, Christian said? Like, what are some ways we could actually control it?
And then, well, I think you have to remember, anything that applies to AGI, it also applies to every single human. So the same ways you control another person, right? We have a lot of manipulation techniques, right? Social parts. You can like manipulate you have to always think like, what does the AGI want, right? Like in some ways, like if it just wants to survive, right, then you can control it by controlling its like feed of electricity, right, or feed of data.
But if it's smarter than us, how are we gonna? Wouldn't it be able to manipulate us better than we can manipulate them?
But that's the given, like if it's smarter than us, right? So is it if it even makes one mistake, right, then you could exploit it and it would be dead.
But an AGI is
Yeah.
supposed to be smarter than us. That's what you just said by definition.
No, but it would be equivalent level to us.
Okay.
Smarter than us would be ASI, right?
Okay, I never heard that.
And
Yeah,
even then, I would say like there's still some point in time where you could still exploit it, right? Even masters, like human masters, still make mistakes.
John, you got any questions for the neuroscience guy? Got him in. I mean, just ramble. You're always talking about AGI, and now you're coming here. It's like, what do people need to know about AGI?
What do people need to know? I think the current cycle is a hype. So that's what I worry about a lot. That the current cycle is too hype, and we're going to go into what's called another AI winter. So I actually did a little research. Yeah, we've had 2 AI winters before, right? Because before we would have the cycle of like all the researchers and like AI researchers would promise something big, right? So I think the first kind of wave was like the expert systems, right? So back then it was just a bunch of if statements.
Yeah.
And they try to code everything into the compute like a database.
Yeah.
Right. So they actually try to code like common sense. Like for example, gravity, like if you drop something, like the object will fall, right? Other common sense is like water is wet, right? And you don't want to touch hot things.
Yeah.
Right. So there were a lot of promises back then, and then those promises didn't pan out, right? Because the expert systems were too fragile. They couldn't handle like edge cases. They couldn't like come up with new innovative things. So then what happened was like there was an AI winter. So research and funding like drops a lot.
For how long? How long was that? Okay, just give us a timeline of,
Yeah.
okay, when did they come up with the expert systems?
Yeah.
And then how long was that AI winter?
Yeah, I don't have the exact time. It's on Wikipedia if you want to.
Okay,
Yeah,
let's go.
you just search up like AI winter. The timeline is the winters last I think between like 10 years. Like depends. Yeah, there are 2 major winters. 1974.
go through.
So yeah, the first winter was about 6 years. Lasted about 6 years. The second winter lasted about 13 years. Right.
Okay.
So I worry about like the current cycles that we're currently hyping it up a lot.
So what happened between 1940 or after 1980 that took them out the AI winter?
So it's like eventually people like forget about it, I think, right? Or like the promises are toned back, the funding is pulled back, and then like people start to become more reasonable about what AI they can expect out of AI, right? The goalposts get reset in a way.
Okay, but then what happened here? How did they break out of 1947 one? Like, what did they come up with? They came out the neural networks in 1969.
Yeah, so neural networks there are already a lot of promises were made back then. Back propagation was not invented yet at this point.
So you think it's similar to the AR VR hype?
Yeah, in some way. I think the hype is even bigger though, which is what I worry. Because there's a lot more money I think being poured into AI, and we've heard the news about like Meta giving out like $100 million salaries to AI researchers.
It's nuts.
The race is on, but yeah, we're in another AI winter will hit, which will also set back like AI research.
Let's talk about where's the money in the sector, pre or post training. John, he did a neuroscience degree. He's working for a startup, but He's doing a lot of research on the side on that stuff.
Where's the money in the sector, pre or post? I think the money in the sector is kind of both right now, right? Pre-training is like NVIDIA, right? That's all your like gathering data. That was like Scale AI. That's what they helped with. And then post-training is like what they call inference. So that's like your ChatGPT or your Gemini models using them.
Let's see. Okay, this is the one that there's
This is
two
the paper.
papers that were interesting. You mentioned there's a paper on by Apple.
Yeah, this is like a really well-known paper. Apple paper, like reasoning. Yeah, on LLM reasoning.
Okay, the illusion of thinking, understanding the strengths. Can you walk me through this paper? I actually never read
Yeah,
it
yeah.
yet.
So the general like technique to reading papers is that the title and the abstract give the most information,
Okay.
right? So you can always don't. So these two parts will tell you everything you need to know.
Okay, read it out. Like, and tell the chat what this paper is. John, this is a different paper on Apple, or that Apple produced. And what's the TLDR on this paper?
TLDR is they tested a bunch of models on a really hard reasoning problem, right? And then so the models were able to solve the reasoning problem up to some certain level of complexity. So do you know the Tower of Hanoi?
No.
The problem?
What's that?
It's just like
Sounds familiar.
yeah.
Oh.
You probably encountered this in leak code problems.
Do it inside.
Tower of Hanoi, yeah. It's the one where you have like the blocks and you have to move them so that
Oh, I've seen this.
yeah. So I think the research. This is one of the examples. The researchers they tested the reasoning models on like solving this problem, and the models can solve it up to a certain complexity. So complexity being like the number of pieces, right? So when the models failed to solve it, they started giving the models like unlimited compute, right, and a limited time to think, and the model still could not solve it. So like that's a sign that perhaps reasoning breaks down after a certain point. Or like these models are maybe these models are not reasoning as we think they are, right? Because I think if you give a person this problem, they'd be able to generalize the solution.
Is this an easy thing to solve? How do you solve this? Like,
There's
can
a certain
any human
algorithm.
just do it? Can any human just do it?
No, you have to be trained to solve it too, right? You can see there's like different types of solutions, iterative solution. It's like a general like leak code problem in a way too. Right? What the researchers test though is if you scale the problem up.
I see.
So this is just one example. I think if you go, so another tip for reading papers is to always just look at the images. So I think you would go view publication. So Sami Bengio is a big name. That's Yoshio Bengio's brother, I think. Yeah, when reading papers, you could just look at the pictures. So you can see, look, they have the Tower of Hanoi. They have this is how they encode the state, right? And then they give the LLM. This is the LLM response, right? Of like moving the disk to whatever peg to solve the problem.
Yeah.
Right. So you can see the complexity is measured by number of disks.
Yeah.
And they use Claude 3.7, and you can see after about like 10, well, let's say around like 7-8 disks, right?
Yeah.
The model just cannot solve it at all, right? It
Yeah.
just crashes completely, right? So this is why this paper has been such a big deal in the media, is that in a way it's saying that these models are not actually reasoning, right? They're just
What does it mean for it to be reasoning then?
exactly, right? So it's like if you were able to reason, then you should be able to use the same algorithm to solve the problem again and again, right? No matter what. It's like it's a good analogy is like leak code, right? If I give you a harder version of a leak code problem, right, but the same algorithm applies, you should be able to still solve that problem. You just take some more steps,
Yeah.
right? It's just longer, but you still know the algorithm,
Yeah.
right? So same thing applies here, right? If the LLMs are actually reasoning, then they should be able to solve it.
So instead of reasoning, they're just literally predicting or they're just spitting out what they know from training.
Yeah, so they're just
That's what
memorizing the answer and not actually thinking.
Okay,
Right,
so
that's why it's a bit bigger.
that's the thing so these LLMs, they're not actually smart. They're just really good at regurgitating information.
Yeah, so
That kind of?
yeah, so example would be like you memorize the test questions, versus you actually know what whereas like actually understanding the material.
Versus you drew on your you draw on your knowledge in order to solve the problem.
Exactly, right? Because then if you draw on your knowledge, then there shouldn't be any limitation except for your knowledge and how well you can reason, right?
I see.
But whereas if you only memorize the answers, then you're limited now by what you memorize, right? So if the test questions change or they add, like your professor now adds like 10 more questions on the same topic,
Yeah.
all of a sudden you can't do it anymore because you just never memorized those questions,
Yeah.
right? So yeah, this is like one thing.
Interesting. Yeah, that makes a lot of sense.
So this is, they tested on like other, they have like other tests too, comparative analysis.
Wait, let me check this. Just make sure it's okay. Continue.
I haven't looked in depth. Let's see. It shows the 4 puzzle environments. So they also did another test called, 3 other tests: checkers, jumping, river crossing, and then they have a blocks world, right? So not just the Tower of Hanoi, because maybe it's just like a Tower of Hanoi situation, right? Maybe the LLMs actually can do well in these other, in a way, games, right?
Yeah.
Reasoning games. And you can see like for checkers, jumping, blocks world, all the LLM just a crash, right?
Like they did good up until some point, and then they just tweaked.
Yeah, so they can do well for like a one checkers or 2-ish, right? But then like after a certain number, it just crashes, right? Which should not be the case because I think the way to solve these problems is that the algorithm always applies the same. You just have to do it more now, right? Same thing with like LeetCode. Like if you give me a DFS of like a tree of 10 nodes versus a tree of 100 nodes,
Yeah.
I can still run the DFS. It will just take me longer,
Yeah.
right? The algorithm's the same. So that's what they're doing here anyway.
I see.
Right.
No, that's actually pretty interesting. What are people saying online about it? Like, are people tweaking out about it?
Well, I think in some ways this is actually, in a way, it does in a way kind of mimic how humans learn too. It's like humans are only really good at one domain and what they train on. Like if you try to test them on something that they've never trained on, like people are going to fail, right? So in some ways that this is kind of just not too surprising that the models fail because they had never trained on that, right? But it's also like the case I've said where if it was just a case of applying the algorithm again or applying like a slight tweak to the algorithm or reasoning, and then you should be able to solve it, then it will say that these models are not reasoning from like a first principles, right?
Yeah.
So I think it would have been interesting if they tried like a Rubik's Cube, because if you scale a Rubik's Cube, like a 2x2 Rubik's Cube to like a 3x3 to 4x4, right? I think the fundamental algorithms change a little bit, right? But you just need to do more steps, right? So I think it kind of applies to these types of games too.
Why do we expect AI just not to use any tools?
If AI can't solve a problem, give it a tool.
Again, definitely, I want to get into the next paper as well because I think you like to understand learning and brain development and things like that.
Yeah, we'll get to the neuroscience side.
Let's get to the neuroscience side. And this one is way more neuroscience side. So I'll just let you go read the abstract and just tell the chat what you're reading and what you're understanding here.
So the title is always the most important part of the paper. So your brain on ChatGPT, accumulation of cognitive debt when using an AI assistant for essay writing tasks. So it's pretty much saying accumulation of cognitive debt, meaning you're storing too much in your memory when you use an AI assistant for essay writing tasks. So in a way it's saying, well, when you use these tools, you should not be accumulating cognitive debt because you're outsourcing that to the tool.
Or no, I don't know what they mean exactly by cognitive debt yet. I don't think that's what they mean.
Maybe that's not what they mean.
Just read through it first. Read the abstract.
Study explores the neural and behavioral consequence of LLM-assisted essay writing. Participants were divided into 3 groups: LLM, search engine, and brain only. So no tools. Each complete 3 sessions on the same conditions. In the 4th session, LLM users were reassigned to brain only group. Brain only group. So they effectively took away the LLM for this 4th session, and brain only users were reassigned to LLM. So now it's like you swap the 2 groups is what you're saying.
Yeah, exactly.
Total of 53 of 54 participants. So I can tell you 54 is not a lot in terms of science. There's a general rule of like you want at least minimum 30 because there's a certain statistical test called the t-test that it will not be reliable until you hit around 30 participants.
That's 54.
Yeah, so I'm saying it's above the threshold, but in terms of science, it's
still low.
Still kind of low, yeah. Still kind of low. But we'll see what they did. Total of 53 participants took part in sessions 1 to 3, complete 18 sessions, completing session 18, session 40, we use EEG to assess cognitive load during essay writing.
Can you explain what an EEG is?
EEG is measuring like the electrical signals at the surface of the skull. So what they do is like they have this net of electrical wires, and then at each of these nodes they have like a jelly thing to help increase the electrical conductance, like, to help them measure the electrical signal. Generally kind of known to be little less reliable, but known to be fast. That's the trade-off.
Okay.
Compared to say like MRI, or the other like brain scanning technologies. So to assess cognitive load during essay writing, and analyze essays using natural language processing, as well as scoring essays with the help from human teachers and AI judge across groups, NERS, engram patterns, and blah blah blah. EEG reveals significant differences in brain connectivity. Brain-oriented participants exhibited the strongest, most distributed networks. Search engine users showed moderate engagement, and LLM users displayed the weakest connectivity.
So how are they tracking the connectivity? What do they mean by connectivity here?
So the way they do this is, so they're saying the brain-oriented participants exhibit the strongest, most distributed networks. So they're saying that if you measure like EEG signals, like the brain signals, you have different networks of the brain, and it's saying that these different networks were talking to each other a lot. Like there was a lot of activity in the electrical signal, right? Search engines users showed moderate, which is kind of expected. You still have to use some engagement when using search engine, and then LLM users display the weakest, meaning they were not thinking much when using it.
Does electrical signal in your brain, like directly tell you how much the person's thinking, or no?
No, that's the problem. Yeah, it's electrical signal is not a direct correlation to brain activity. For example, there's something called the default mode network. So there's a very interesting case of like if you just have a person do nothing and you put the EEG cap on, you'll still see activity coming out of the EEG, right? Because the brain when is what we call the default mode, like doing nothing, but the brain is still doing something. We just the person itself is not aware. Yeah. Right. So they may be daydreaming, or the brain's doing some like background activity, right? Or perhaps it's like thinking, like the unconscious is still active, right? In a way. So that's why the correlation between electrical activity and brain activity is not 1-to-1, right? It's not that simple. Yeah.
Okay. Continue.
Cognitive activity scaled down in relation to external tool use. So I think this is like the punchline of the paper, right? Cognitive activity scaled down in relation to external tool use, aka the more external tools you use, the less you're using your brain, right? Which in a way makes sense, right? The point of these tools is to use your brain less, right? If you had to use your brain 100% of the time, then you wouldn't need these tools. In the same way as like if you had a hammer, right, then you don't need to bash nails with your hand. You can use the hammer.
Yeah. Like if it's not improving, if it's not making it more efficient,
exactly. So in session 4, so the LLM to brain participants showed reduced alpha and beta connectivity.
What does that mean?
Indicating under engagement. So I think alpha and beta are certain signals in EEG. I don't remember what they represent. I think these are the awake signals. Right?
Okay, we can just move on.
Yeah, we can skip that part. These like when they swap the groups. Self-reported ownership of essays was lowest, which makes sense. LM also struggled to accurately quote their own work, which makes sense because they didn't make it. Like if you have the LLM make the essay, you're not going to be able to know what exactly you wrote. While LLMs offer immediate convenience, our findings highlight potential cognitive costs. So over 4 months, LLM users consistently underperformed at neural, linguistic, and behavioral levels. These results raise concerns about the long-term educational implications of LLM reliance and underscore the need for deeper inquiry into AI's role in learning.
Yeah, what do you think? How is this? Yo, Christian, what's up? Manas, what's up?
So in a way, it's just saying that the more you use LLMs, the more you turn off your brain, and so that's what I think they mean by cognitive debt. Is like you accumulate this debt because you're not flexing your brain muscle, right? If you're not thinking when you're doing it, then you start to slowly lose that ability to, for example, like critically think or like write essays, solve problems. So again, like skip. This is the highlight to it, that their main picture, EEG. So you can see these are the different networks of the brain. They have different lines. P-value is how they measure like significance. So this is like just saying more. So red and orange would be most important. I don't know. I'm always
even a good paper or what?
I'm always skeptical of like EEG topics, especially stuff like this. like you would need multiple papers and multiple studies.
It's
And,
by MIT.
I don't trust the big institutions and like the Ivy League. The research is more reliable, but not always 100%. Yeah, this paper's massive. Yeah, I don't know if it's gonna publish like this. There's usually a page limit.
It's already published, is it?
No, this is a preprint, meaning it hasn't been peer reviewed, hasn't been published.
Interesting. You're the peer reviewer right now.
Peer review right now.
He's doing software.
Usually there's like a one image that will summarize the whole paper, which I think they showed at the top. They put like a lot of detail in here. A lot of this will probably be cut out. This or like put it as an appendix.
Yeah, go to end. Like go to conclusion.
Yeah, so they have a lot of analysis. EEG analysis, yeah. As someone who did some of this stuff myself, a lot of this is kind of fluff. That's why.
Oh, okay.
Yeah, like they try to make it seem more important than it is.
Damn, we're talking about for 3 hours about this, and then this guy just came to say this paper is useless.
No. Oh yeah, and then the references. Okay, ignore all that. Yeah. I remember these pictures. Happiness. Topic happiness.
What do you think? How is LLMs gonna affect us? If like is vibe coding the move or what?
I think long term is what the paper's saying too. Like long term, if you want to get actually like understanding of programming, you should not use it. So I think the correct way is kind of the way you should not use it in school while you're learning programming, right? And anytime you come up to a new task, you should try it yourself and then verify it against the AI. I think that has always been the approach that I would use, right? Or if you know ahead of time what you want in your head, right? And you want it just to be done faster, the AI can do that for you.
Yeah.
Right? So if you know you need like these components, you know you need to refactor this way, you should tell the AI to do it, and then you can always verify that. But there's no shortcut to mastery. Like you can't cheat your way. You can use the tool, but it will hamper you in the long term, when like an actual problem comes up, because the AI is not 100%.
That's interesting. So how would you suggest people starting to code these days?
Yeah.
With the age of AI, should they just use it to sort of skip all the steps that we used to do and just get to building things faster, and yeah, just work on projects?
I would just use AI to. I would still avoid AI if you were a student, unless you're like a type deadline or something, or at least use AI to explain stuff you don't know. Like you would handwrite the code and then ask AI how to make it better.
So, Paul, my friend here, he took a neuroscience degree. He has a master's in neuroscience, but he was traditionally a software engineer, and he was doing research. He did AI research as a neuroscience master's, but then he's also been looking into AI since 2016 or 2017, like super early. He's the one who first showed me it in 2018, so it's been a while. He's the first person that showed me the AGI. So he's asking, what do you think of AI ruining children's natural learning process?
Yeah, I think it is going to be a problem. But like this happens with every new tool as well. Like I remember a story where people, when the calculator was first introduced, right? People were like, "Oh, it's gonna not make people be able to do mental math, right?" And then like they're not gonna have like be able to do math as well. And like, what are you gonna do if like you don't have a calculator, right? But now we all live with calculators, and that's just been outsourced. So I think the similar thing may happen actually to writing code. Yeah, people are objectively worse at mental math now, but is it a problem, right? So if it's a problem, then we should not use calculators, right? But if it isn't a problem, then it's just a problem, then we can just ignore it. So something similar now is kind of happening with AI. I always think that for software, writing code has never been like the highlight of the job, right? You actually, there's a stat too, you read code more often than you write it, right? So I don't think it's like a huge hit. You could use AI to like write a lot of code. In the end, you still have to read it and you still understand what's happening, right? And if it makes a mistake, you have to correct it.
He's saying, well, I think AI stopping your learning process of proper grammar, thinking for yourself, etc., is a problem. Because if people just outsource their thinking, as in
Yeah.
how to structure sentences, how to write their essays.
So I'll say that's an actual problem, because if you can't think for yourself, you're pretty much trusting the AI to do everything, which should not be. You can't trust these AIs. Like the second you see a mistake, right, you have to be able to know it's a mistake, right? You have to be able to verify. If the AIs were 100%, then we wouldn't need this problem, right? But then we wouldn't even need to work anymore.
But that's what an AGI is going to be. It's going to be
Exactly. Yeah. So, but it's still making mistakes, so you can't just offload everything.
So how would you suggest studying AI? And also I would say, how is it different than software engineering?
Well, AI is like a whole different beast. It's like research, right? And it depends on which paths you want in AI.
What are the different paths?
I would say that in my head, there's like the computer science path, right? And within computer science, you have different kinds of AI. You have like the machine learning side is like the very popular one now, right? But there's still other forms of AI in computer science that have not been explored, right? So if you remember the whole textbook, there's like a whole reasoning aspect of AI that like about decision trees, if statements, how to reason, like how to get common sense into these models, right? Like how to get world models into AI. That whole part has still been ongoing, right? So you can focus on the new hype stuff like the machine learning, the transformers, LLMs, right? But that's still only been a part of AI, and that's only been the text part too, right? We still have the whole vision part where it's like AlexNet. I think OpenAI had like the image generator, but we still.
Well, we have multimodal models right now, don't we?
Yeah, but I think that would be the next part of AI, the multimodal models, right? Language is now starting to be exhausted. They're running out of training data, right? At least for terms of like text. But I think images are always much more rich, right? But it's also much more difficult.
This guy's in here. Let's see what other questions. Yeah, I think this guy and I agree, not really an issue for coding or adults. Most of an issue for development years. Yeah.
Yeah, I agree. It's more really an issue for development. If you know what you're doing, it's a good tool. If you're learning, you should not rely so heavily on it. You have an interview?
Yeah, we're gonna
All right.
We're gonna do it at the same time, bro. All right, that's the end of that session. What's up? Who do we have here?
Hey, it's IK.
Wait. Let me do this here. One sec. One sec. Let me set this up.
All right, let you do your interview.
No. Hop in. Shadow.
Shadow the interview?
Yeah. Come go on this side. All right. You can throw in your. Okay, wait one just sec. We're just setting up.
Okay, sounds good.
You can hear him, Brian?
Yeah.
Wait, can you say something? Just make sure it's clear.
Me?
Yeah. Oh, it's kind of loud for them. Okay, say it. I'll just adjust
Hey.
it. Okay, cool. All right. Brian, make sure you're in there. All right, perfect. So today could you just quickly introduce yourself?
Okay, my name's IK. I'm a computer engineer. I do electronics, firmware, type of thing. I have an interview coming up soon, which is why I'm trying to practice for it. It's also in the software. Oh, it's not software engineering. It's also in the firmware engineering kind of space. So I know it's not kind of what you're used to, but I just it's still a LeetCode style question anyways. It's just not anything super complicated. Like it's more like hash maps or
Hash maps.
basically the basic stuffs, right?
Really?
None of those graphs or like a lot of linked lists, arrays, hash maps, strings.
Is it more practical or just or random lead code question that has a small trick to it?
Well, actually, the ones I've been doing are actually very practical. So I know Amazon they do more like lead code style questions, right? Where you're implementing an algorithm and then you have like, oh, this algorithm is this time complexity. But the kind of problems I've been faced with so far for this company is more like a how do I explain it? It's more like you have this so an example was two processes, they're trying to two threads, right? You want to use spinning of two threads and you want to print the thread ID of the other thread.
Yeah.
Right.
So it's a concurrency type thing?
Yeah.
Concurrency type?
So that was concurrency. But it's usually more like practical stuff, more not an algorithm, but just more like an idea. Like can you solve it? So for that one you'd have
Okay.
to set up like a mutex and
I
then
see.
everybody will wait on the mutex. And
So how many lead code questions have you solved?
like 150.
Okay, how are you with the different aspects like arrays?
I'm good with pretty much anything except graphs though.
Just not graphs?
I said except graphs. Graphs.
Because graphs are a big portion of the lead code questions, but we'll try to stick to arrays for the first one.
Okay.
Let's come up with a good one. We're gonna do one that's more of a design question.
Okay. Yeah.
We're gonna do.
Yeah.
You're probably familiar with this one. So my friend is shadowing me. He's gonna be doing interviews soon too.
Okay.
Yeah.
Design.
Yeah.
So I just want to just get a hold of your sort of this is gonna be more of practical, but we're just trying to get a sense of your programming and object oriented skills. What programming language are you gonna use?
I can do Python. Yeah.
You're gonna use Python?
Yeah, that's fine. Usually I just change based on the difficulty of the question.
I see. Okay.
But I think for this one I can do all Python. Usually, yeah. For my interviews I do everything in C because it's supposed to be like an embedded
Yeah.
problem.
So for this first question, we're gonna be designing an underground railway system. And
Okay.
This is just the first question. We might get into more, but
Okay.
let's see. Let me quickly.
Yeah, actually before we start, I wanted to say thank you though for doing this.
No problem.
Yeah, I know it's a lot, and especially for free, that's insane. So I just appreciate
Yeah.
that.
Thanks for hopping on. This is fun when we get people who are doing cool stuff, hopping on and we get to see their thought process. So it's important. We get to share. Like how many people have I interviewed now, and so many different solutions and so many different levels. So you get to see it. So here, I'll send you the link. Take a read of that question.
Order path. So, what about you, James? What do you do?
I'm a software engineer, pretty traditional software engineer.
Okay.
Yeah. Work at pretty much the application level, a lot of full stack. So do front end, do back end. Like pretty much I've worked at all size companies, so you pretty much just do whatever needs to get done. You focus more on sort of what business problems you need to solve, and then you just figure out what you need to get done there. It's not like, oh, I'm just gonna be picking up front end tasks or picking up back end tasks, or it's more like how does work come in? It's like there's a business need,
Yeah.
and all of a sudden that business needs come to you, and that business need could be anything. It could be literally on the front end. It could be the front end and the back end. It could be optimizing, like some database performance issue, and that could be on the infrastructure. It could be in your database. It could be in like your wacky code, just the way you queried it down. It's like, it changes. That accurate?
Yeah.
Ryan?
Yeah.
All right. Are you in here? I sent it to you. Oh, he dropped out? Wait just a sec. You have time though or no?
Yeah.
Okay.
Yeah, I need some practice too.
Wait, the guy dropped out. Where's he at? He's lagging. Give me a sec. Wait for him to come back and grab something. Records. Tell me when he's back.
All right. Oh, he's back.
Okay, yeah, sorry.
Oh, hello, hello.
Can you hear me?
Yes.
Also, this CoderPad doesn't want to load. I don't know why it's.
Well, I sent you the link, right?
Yeah, I saw it. Could you actually resend it? Cause
Then we're hour and 1 minute. We just have to survive 59 more minutes. You ever
Yeah, I
been
don't know
code
why
for 12
this-
hours straight?
it's not load. It's not working on mine. And let me try opening it up.
What's the longest you went in a row just coding?
Just coding.
Yeah, just straight, just staring at your editor and just writing code.
Maybe like 5 hours.
5 hours? Say swear.
Swear.
Okay.
Even if you're stuck on a problem, you're just like, after 5 hours you call it?
Oh no, I never give up. It was maximum took 5 hours.
Damn, this guy's too smart. What if it's a whole project? You're like, I just want to get this project done right now. By the end of this day, I'm finishing this project. I don't care if I sleep.
Yeah, I'll push
You never
myself.
had that?
Nah. Never needed to push myself that hard.
Even at your current company? You sure about that?
Yeah, the current company's the one that did 5 hours at. When they did a study. You can do max like 4 hours of like deep work. 4 or 5 hours.
All right.
Yeah, but what if you do like the next 6 hours in 50% work? You still get 50%. You still get more done than the
Yeah.
person.
Like I told you, diminishing returns, you still get returns.
Yeah. All right. We're given a simple. What we're gonna do here is we're gonna design an underground railway system that keeps track of a customer's travel times between different stations. They're using this data to calculate the average time it takes to travel from one station to another. We need to implement 3 functions: a check-in time, a checkout time, and then another function called getAverage. So 3 functions.
Okay.
So basically, check in, you take in an ID of the person who's checking in. You take in a station name, which is the starting station name, and then the time that they checked in. Right? And then later at some point, that person is going to check out at some station name.
Mhm.
At a specific time t. So get average time, we should be able to ask the system, what's the average time it takes to go between start station and end station? And like the reverse isn't true. It's like it's unique to the start and end station here. I think it says right here.
Oh, you said the reverse isn't true?
Yeah, it's not just because it takes average 10 seconds to go from start station to end station doesn't mean that it's gonna take the same from go to end to start, right? It says right here. The time it takes to travel from start station to end station may be different from the time it takes to travel from end station to start station, like the reverse. So, yeah, you may assume that all calls to the check-in and checkout methods are consistent, and if the customer checks in at time T1, then they check out at T2, where the T1 is less than T2. All events happen in chronological order. So I'll let you go ahead and figure out what's happening here.
Okay. So question seems very detailed, so I'm just have to read it a lot.
Sure.
I might not have any questions. So I see that the customer can only be checked in at one place at a time, which is good. So that means we can actually use a map. So we can map the ID to the station that the person is in right now. Actually, we want to do the other way around. Let's see, because we need to have the average. Maybe we have two maps. We need to have the average time. So, okay, how many sorry, people are going to be using this train station?
How many people? A lot of
Mhm.
like unlimited people. It shouldn't be a limit.
Unlimited people. Okay,
Should be
so
a
I shouldn't.
lot,
Okay,
yeah.
okay. So definitely, I have to hash the ID. That's for sure. And it's a unique ID, right? So essentially, one person has that one ID for the whole duration of.
Yes.
Okay.
Well, not one person. Well, I guess yeah. We could say the ID is unique to one person. Everyone's gonna use their own ID, have their own ID.
Okay.
Yeah. Yeah, it says right here, a customer with a card ID equal to ID.
Okay. Let's see. Can I get average time from star station?
Want to eat after?
I'm down.
After this?
Okay, and what about the stations? Are they a finite amount of stations?
Not finite. We shouldn't assume it's finite. There could be a lot of stations. Or let me ask you this: how is that going to affect the solution if there's finite?
So okay, so because I'm thinking of essentially anytime somebody checks in, right? I store. Actually, I don't. So I was thinking of having like a 2D array, right, of each station, right, from station to station, and then store the average time in that 2D array. And anytime someone checks out, I update the 2D array with the check-in time and with the average time, right?
Could you explain a little further what you mean by 2D array of the station names? Oh, so something like station names is this 2D array where you have like the names like A, B, C. These are stations A, B, C. Then over on this side, you have A. You have station B. You have station C.
Yeah, just like that.
Yeah, something like this.
Yeah, and then each value stored at that station would just be the average time.
Okay,
for that station.
Pretend we had a very high. We had maybe even just 10 D, A, B, C, D, like all the way to like Z, right? All the way to Z, and then only one person. Only one trip happened from A to Z. So we have this massive array of data, and we only have like one entry there. So I think it's not that efficient on space.
Yeah. Okay. Because the other idea I was thinking was a 2D map, but I've never heard of that before. I don't know how. Like basically the same thing, but just with a map. Does that look feasible? Right. We have like the stations. And then it's just, if it's Python, just something like this. It's a map. It's a map of maps, a dictionary of dictionaries, and each station is like A has its own dictionary, and B. I guess that works too.
Then what happens in here inside? It's like, does A, B here mean that they entered an A and left in B?
Yes. Yes. Sorry, I need to be more explicit. Yeah, it means that they entered at A and left at at B, and then we would have since each person can only be okay. So another question I have is
Mm-hmm.
someone else can check in after that person, right? That's
Wait, could
obviously
you
a given.
repeat that again? You cut
I'm
off.
saying if I checked into station A
Yeah.
at time 1, somebody else can check into station A at time 2.
Yeah,
Right.
like somebody can check in after me, but I can't. We could assume that the input is well formatted. Like I'm not gonna check into station A then check into station C at the same time
Yeah.
because you can't teleport, right? You need to check into station A, then you need to exit, and then you need to enter again. We could assume that it's well formatted in that sense.
Okay. All right. So this is what I have for this. Right. So we'll have the stations map, and then we'll also have like a user location map, right? And then basically, this maps to probably a tuple, and the first thing is the station name, so maybe like station A, and the second one is the time they entered,
Okay.
and this is just the check-in location, right? And then when you check out, actually, since you can only be in one place at a time, we don't need to store the. Well, actually, no, never mind. We do, because we need to use this A to get the average. Okay, so essentially, when you check in, you put the tuple in the user location. When you check out, you remove it, and then so this is T1, right? Check in is T1, and then when you check out, you remove it, and you say something like, it's actually might be tough. I'm trying to get an O of 1 average. I think that's kind of what I'm thinking, because I want this call. Maybe I'm because I'm thinking of the optimal solution too early. I want this call get average time to be O of 1, and
Okay.
I'm essentially that would mean storing the average in this station's thing itself. But that might.
Sure. Let's just let's make sure it works over one. I mean, what would be an unoptimal solution?
An optimal would be probably to store an array here of all the times, right? You can store this person's T1 minus T2, or T2 minus T1, and then store another person's T2 minus T1,
Sure.
right? And every time, so we just store these values in the array, and anytime you call this, you then call the average on this guy every time.
Mm-hmm.
So, right, that works, but I think we could do better.
Yeah.
So it does mean that okay. So
No.
do I have to implement this, or is it just more like a?
No, you have to implement it. You have to implement it.
Okay. Do you want me to kind of?
I mean, how can we make that faster, right? Pretend we have a bunch of A and B,
Okay.
and that list is big, and we just keep querying the same average time for that start and end station. We query it 1,000,000 times. It's
Yeah.
slow,
So
right?
we have something called a running average, and that's what we'll use here.
Okay. Sure.
So the first value would be the actual average. So I'm going to store a tuple instead now, or maybe, yeah, a tuple is probably best. An average, and then here would be the n, right?
Mm-hmm. So how do we calculate the average using average and n?
Actually, no, sorry. I think an easier way, instead of storing this average and n, would be to store the sum and n. Right. If you wanted to store average and n, it's possible. You have to do like average times n, then plus the new value. I guess I can do that too. Sure. And then you divide it by n plus 1, and then you increment n. Yeah, let's do it like that.
I mean,
Right.
let's isn't it easier to just calculate, have the total sum and the number, and then just divide it? Or
Yeah, that's what I was
Yeah.
saying. It's just easier to do it like that. Yeah, rather than doing all this fancy math.
yeah,
Sorry, sometimes I get ahead of myself because like in Python it's okay, but what if the sum is greater than like I don't know 32 bits?
like it overflows, right? Yeah, that makes sense.
Yeah.
So how would your other solution stop that? You're multiplying averages
Well,
by n.
that's actually that's true. Yeah. Okay. Good. GG's. Yeah. That makes sense. I didn't.
Like it could. I'm just wondering. I'm just trying to see.
Yeah. Now that
Yeah.
I think about it, I don't think it's possible. Yeah.
It depends on your calculation, but
Yeah.
it is something you worry about if it's gonna overflow. But you're using Python here, so if we're using C++ or Java, then I would say worry about it. But we're using Python.
Yeah. Okay.
Okay, so what are you thinking for the solution? That's the user location.
Yeah.
You calculate the average time. Just go ahead and implement it now, so we can move on to the next question as well.
Okay. Sounds good. So for the
What are you
check-in,
thinking so far?
Man, you
check in
suggest you
and
go to
see
brute
what-
force solution first. Optimize later.
so I'm just looking at the thing. Check-in with ID, string, and then the time. Okay.
Okay, we want to follow like object-oriented principles too. So,
Okay.
please break it down into like object, like a class and stuff.
Okay. Okay. It's looking like there doesn't need to be a constructor for this. I don't like. Is there going to be a constructor for this class?
Okay. I mean that would be a question for you. When would we need to introduce a constructor or not? Like, what does a constructor do in an object-oriented sense?
It sets up the structures that we need. I guess I will need one. My question was more like, is there something that we need to the caller to pass to this railway anytime they initialize it? But since you said that everything is infinite, right? In the case, maybe you could pass like, the number of railway stations we have, or a list of routes, right? You can only go from A to B.
It makes sense, but all I would say is, it's you're designing this thing. So if you want to decide to add stuff, you just let me know, and I'll agree with it or not. Because I want to see what you're able to create.
Sounds good. So I'm just going to initialize the. Oh, sorry. I don't really know Python like that. Initialize all the stuff we need, like stations, user location, and all that stuff. Stations. Actually, I'm gonna call it station average. So station average is it's a map of the maps. I don't think so. It's a map.
Your face.
And then
Just thinking about the problem.
the user location self dot user location is another map. So 2 maps. I think that's all we need. And on check-in, essentially we just
You get what it's asking though? The
Yeah.
question?
Yeah.
You read it? What do you think about his solution so far? Is it making sense? Like,
I'm a little confused. Wait, let's see. Hash map of hash map.
that part is we definitely could fix that.
So I think this is station.
Okay. So they add the user ID and location. They check in.
Mm-hmm.
Makes sense. Okay.
And then for the checkout, same thing here. ID. I think checkout also has the station, right? Yeah, it does. Station and time. Self dots. So then here, this is where we would have to so I can get the station. Okay. Station name and check-in time. I don't know how to pop stuff from Python.
How to pop stuff?
From Python dictionaries, right? If I let's say self the user location. So how do I like pop? 'Cause I don't need it anymore. Right? If I want to
user location.
So I want this ID, but I don't want to just read it. I want to pop it out.
Okay, I'll just give you the if you want to delete it, you can just do delete.
Oh, okay, sounds good. Okay, so station name, check-in time is self.user location ID. So we're taking the name and the time. I don't know why it's grayed out, but hopefully that's not a bad thing. So we take the station name and check-in time, and then essentially in this user location, in the stations, we then want to take the station. So I want to change this from station name to start station. So this is a start station, and this I'm just going to call this the end station. Then stations from the stations average from the start station to the end station. Sorry. So just read that, and then I see self.station average from the start station to the old station to the end station is equal to so it's a tuple. The first location. Well, okay. So if I guess we have to first check if these guys are in there, right?
Start station, end station are in the station average.
Yeah.
What would happen if it wasn't?
Well, it'll crash with a key error. So and this just means that maybe this is the first time the user is taking this route, or first time anybody's taking this route, a lot of stuff. So maybe instead of doing that, I could do I can first of all check if the start station is in the self.station average. I guess I can delete this one. And here, if also the end station is in self.station average start station. But I want to have a default value here. So old val is then so the default sum would
Okay,
be
let's think about this. Like, is there a better way to do this than the double map? Like, is there a way that we can generate a key to the map that it doesn't include us creating a double map?
yeah, maybe you could concatenate the start and end station together.
Yeah, that'd be better. I think
Okay.
it would just make it more simple.
Okay. It just feels like it's gonna take some time though.
Okay.
Maybe not. Okay, let's do that. So let's so then I can say something like station value is like the station average that gets, and then I can get this before I do that. I want to say the key is start station plus just want to add like a plus in between it, end station. Okay. Then key, if not, we want a tuple that is 0 0. That is no sum and no travels here. This should be stopped at station direction. Okay, and then now I can say that at this key, thanks for that hint. I don't know how I got like tunnel vision and couldn't really see.
No problem, it happens.
Okay. So then stop the station average key. Yeah, and then it's pretty simple. We just want to take the station val. Just gonna station val.
Rethinking
0
I
1
would not have solved this on my first.
and add. Actually, maybe I should probably take this sum and n, s and n. Then just take s plus. What's the first? So I want to add. I want to take the time it takes. So that's time minus the check-in time. Right.
Okay.
And then we just take this n and we do +1. Okay. And then when we define this get average time from the start station to end station, start station, end station. We essentially just return. Also, I need to put self here. We essentially just return. Say the key. I'm gonna copy this guy. Same thing here. And then they say, so I'm not doing any checks because I see that in the code it says that
it's gonna be well formatted. So,
yeah, exactly. So I'm not really doing any checks. So key start station with end station, and then essentially I just want to return. I want to take the sum and the n, and then it's just equal to self.station average at this key. And then I just want to essentially return sum divided by n. That's the average.
Okay.
So
Makes sense.
does this look good?
Let's run it out on some test cases too, or let me run it on this test case that I'm gonna send you.
Okay.
Actually, I know it's good. Let's move on to the next function that I want you to implement. So I'll implement it at the bottom here.
Okay.
I want you to implement. Get me the last k travel times.
Oh, okay. And everything is the same?
So what's gonna happen is in our railway we're gonna be inputted some k, and k is gonna tell us is the k for this function get last k.
Okay.
So what this is gonna do is this is just gonna tell us the last k travel times in the whole system.
Okay. So travel times, what does that mean?
So pretend someone went A to B.
Mhm.
Let's say k is equal to 2, right? So what we mean is we want to pass or return the last 2 travel times. So if the last 2 travel times were AB and then AC, and one was 4, one was 10 seconds or whatever time
Okay.
or unit, we just want to return these last 2. Does that make sense?
Okay. And the 4 and the 10 is basically this start time, end time, and a start time.
It's just telling us the last k travel times, as in how long did it take.
Okay. Okay.
Yeah, length of trip. Get the last k travel times in length.
The end of the length
So
of the
if A to B took 4 and A to C took 10, and those were our last the last trips that happened, it would come if it was in this order, 4 and 10. Like 10 was the very last one and 4 was the most recent one. That's gonna be the result here.
Okay, so does it have to be in any order?
It needs to be. It doesn't really need to be in any order, but we just need the last k travel times.
Okay. Sounds good. Seems like we want a queue of some sort, or yeah. Let's see. So essentially, we just want, I could say, an array of the k most recent travel times. That
Pardon?
sounds
Yeah, the k most recent travel times.
okay. I'm thinking of using a queue, and I just like a double-ended queue, right?
Sure.
And I add to the end and pop from the top, and that type of thing, right? And the most recent one will be added to the end, and then if we're more than k, we pop the top one. So essentially, it's a queue that only has k items in it.
Okay.
That sounds good.
Sure. Yeah. Go ahead and implement that. Sounds about right.
Okay. I know Python has a double-ended queue thing. Trying to see if I can remember how to. No, I have to import something. Like import that queue. Was it smaller? Nope, I don't remember.
I'll do for you from collections.
Okay. Okay. Thank you.
No problem.
Collection input queue. Actually. I see. Just trying to remember the format on this. So that's the queue, and then that's the okay. Sounds good. So this is going to be our self dots.
What are you gonna do here?
Start with K, and then self dots recent times. It's an array, which is our double-ended queue. And then basically we only know the times when we check out. So in checkout here, this is where we'll do the magic. So we can do like a the recent times, the append second. Okay, how do I? So I know I appends to the end.
Appends it to end.
Oh wait,
And then we
that's
have
not.
we have a pop left to get from the start.
Okay.
Or from the pop left is the start. If you want to add to the end, you could do append. Pop left to remove from the left side.
Okay. Thank you. Append is we append to this queue self dots recent times, and we're appending this time minus the check-in time. And then basically, if length of the self dot recent times is greater than k, then we pop left the queue dot pop left. Hey, is that right? Pop
Or
left?
I'll just fix this up for you a little bit. Like the API is more like you create a DQ, like this, and then you go self dot recent times dot append, and self dot recent times dot pop left.
Okay. I thought it was more like the heap thing, because I know. Okay.
Yeah.
Self the recent time the pop left, and then we pop just anything really, yeah. And yep, and then in the function get k last travel times, I guess we can just return, if we want it as a list, maybe we can return this list of self dots k get k last travel times. Wait, sorry, I don't know why. Wait, what? Is it because? Oh, it's called recent times. There you go. Yeah.
Okay.
That sounds like what it looks like, right? That sounds like yeah, that sounds good to me.
Okay. This one we could just talk about for a few minutes.
Okay.
But what if we want to get the K fastest trips?
Okay, fastest trips. Okay, yeah, we could use a heap, something like a min heap, and so it'll be pretty much the exact same thing.
Yeah.
But instead of using a double in the queue, just use a min heap.
Yeah. Okay. Cool.
Yeah.
Sounds good. All right. How do you think you did?
I think I was a little rough, choppy. Definitely didn't really know much Python. I'm not sure if I communicated well
Yeah.
what I was doing. Yeah.
Yeah. Brian, what do you think first?
Yeah, I think you did well. Maybe a little slow at the beginning, but once you start programming, went well.
Yeah, that's my friend. Big with 12 hours crazy work. Yeah, I would say just the main thing is just speed here. Like you clearly understand heaps, you understand hash maps, you understand the syntax, you able to do the math, right? But I would just say that you should focus on pumping out these questions a lot faster. So getting this question done within 20 to 25 minutes would be my goal. So we can move on to another question. So I think it's all about just working at a specific or at a much faster pace. I would say try to work at 2 times the speed you're working at right now. Because that's like the pace that people would expect at an interview as well. Because pace also matters when it comes to getting the job. If you do this question, honestly, the question is like pretty straightforward. So I would expect most candidates to solve it. But then the part that I would judge them on is how fast were they able to solve it, and how many mistakes did they make, and how optimal is their solution in different areas like that. I think you have all the fundamentals there, but it's just working on the speed portion of it.
Okay.
Yeah. Why do you think it was a reasonable pace or no?
Oh yeah, I don't think it was a reasonable pace. I don't know why I was typing that slow. I have no idea.
No, it's no
Maybe
problem.
it's because I'm trying to talk.
Yeah,
I don't know what I'm supposed to be saying and what I'm not supposed to be saying.
yeah.
Um,
Like I think honestly, these
Mhm.
days a lot of the companies are testing how fast can you come up with ideas and then implement it. Right? Isn't that in the criteria in a lot of
Yeah.
them? A lot in the
Okay.
companies that I had to I had to run interviews for. We care how fast that they do it because they want people who can think really fast and come up with solutions really fast and implement really fast. It's like speed is important as well, especially when you have 10 different candidates. If this question at least 6 or 7 are going to solve it, and then now I need to see who came up with the solution, who came up with their ideas the fastest, and who was able to iterate through the ideas the fastest, who was able to write the cleanest code, etc.
okay.
Yeah, so I think you have the fundamentals there. So I would suggest just timing yourself when you do questions, and just try to work at a faster pace. And it might feel uncomfortable at first, but you need to sort of push yourself when you're doing the questions as well.
Okay.
You could get through more and more questions. But yeah,
Will you say that like the time it took me to get to the solution was slow too? Or,
it
like,
took a
too
while.
long?
It took a while to get to the solution.
Okay.
I don't know. I'll have to watch it over, but a lot of the times, yeah, we would just expect to get you to the solution within X amount of minutes, usually 10 to 15, and then implement it in another 10 to 15, and then start working on more complicated follow-ups right away, or start working on the next question. But yeah, that's my advice. I think you're doing good. You understand the fundamentals. I would just make sure to just lock in more of the, if you're going to be using Python as your programming language, understanding more of the language specifics,
Mhm.
like building the keys to the hash map, right? You could have also just stored it as a tuple, because tuples are serializable, so you could actually use that as keys in the Python library, or as keys in the Python dictionary. That's one thing you could have done. So little small things like that, language related, would go a long way too. And then yeah, because I know you said you don't use Python that much.
Yeah.
Yeah. Cool. All right. Thanks for hopping on for the interview.
All right. Thank you.
All right, thanks.
Thanks. See ya.
See you.
Damn.
Damn.
I'm at 11 hours and 42. What should we eat? Chat, thanks for coming out. Holy crap, my neck is hurting.
Yeah, 12 hours. Here, let's
Bro.
swap chairs. Like, holy.
Yeah.
Yeah, sit back. Whoa, shit.
What are you thinking? What should we eat?
Must be nice
Celebrate.
today.
We're pushing this
What is chat
down
think?
to. They don't know nothing about that stuff. Holy crap. Yo, thanks for tuning in. We covered a lot of ground. We did some really hard lead code questions. We got up to hards and stuff. I was asking people hards.
Damn.
They're solving it.
Holy.
Dev Joey, is this your first time tuning in? I stream all the time.
This man lives on stream.
The last 6 months of my life has been on stream. Where are you based? Yeah, what do you think about his solution though, Brian? It's good, clean.
Not bad. He needed hints though for the major parts.
Yeah.
Double hash map was good. I think he just needs to start coding though. Like get the brute force one out first,
Yeah.
and then iterate after.
All right, chat. Thanks for tuning in. Appreciate y'all. Catch y'all in the next stream. Peace.
Bye.
Nice. All right. See you around. Hopefully you tune into the next ones. We'll be doing this a lot more often. All right. So we're officially at 11 hours. 11 hours and 44 minutes, so right under 12 hours. That's how long we streamed for. Hopefully the stream saves, but yeah, catch y'all in the next video. Peace.
Peace.